Somewhere it's late. Somewhere a light is still on. I like knowing that this story is finding you wherever you are tonight. Drop your city in the comments if you feel like it. And if you'd like more nights like this one, the subscribe button is how you find your way back. Now, let's begin. There is a particular kind of darkness that settles over a city when the war is finally over. Not the darkness of bombs or blackout curtains or fear of what the night might bring. Something quieter than that. The darkness of exhaustion, of a world that has survived and is not yet sure what to do with that fact. London in 1945 looked like a city that had been chewed up and set back down again, not quite in the right order. The scars of the Blitz were everywhere. Crumbling buildings, empty lots where houses used to stand, streets still marked by the ghosts of incendiary bombs, as though the ground itself remembered what had fallen on it. Britain had won, yes, but victory had come at an almost unimaginable cost. And in the meantime, people were hungry. Rationing, which had begun in 1940, continued for nearly another decade after the fighting stopped. If you wanted butter in those years, you received 2 ounces per week. Meat amounted to roughly 1 shilling's worth, approximately 2 small chops if you were fortunate. Bread rationing, which had not even been necessary during the war itself, was introduced in 1946 because the situation had somehow worsened. Sugar remained rationed until 1953. Full rationing did not end completely until 1954. So when we speak of post-war optimism, we should hold that phrase gently. For most of the late 1940s, optimism was less a lived experience than a form of prayer. But then something shifted. By the early 1950s, the economy began to stir. Factories that had spent years producing tanks and aircraft turned toward consumer goods. The government launched massive housing programs. More than 1 million new homes were built between 1945 and 1951 alone. Prime Minister Harold Macmillan would declare in 1957 that Britons had never had it so good. The remark would later be criticized, but it captured something real about the mood of the era. For the first time in a very long while, ordinary families could dream of owning things. Not just necessities, but luxuries. A television, a refrigerator, a car. And for their children, toys that would have been unthinkable just a few years before. This is the world into which the chemistry set was born, or rather, reborn. Chemistry sets had existed in various forms since the 19th century, but they had been expensive, niche products for wealthy families or dedicated hobbyists. The post-war manufacturing boom changed all of that. Suddenly, companies could mass-produce these kits cheaply, packaging them in colorful boxes with exciting illustrations of young scientists making amazing discoveries. The marketing was quietly brilliant, tapping into 2 powerful currents of the age. The belief that science would solve all of humanity's problems, and the desperate desire of parents to give their children opportunities they themselves had never had. And here is the thing worth sitting with for a moment. Those parents were not wrong to believe in science. The 1950s were genuinely an era of miracles. Penicillin, discovered before the war, was now saving millions of lives. The polio vaccine arrived in 1955, defeating a disease that had terrified parents for generations. Nuclear power promised unlimited cheap energy. Plastics and synthetic materials were transforming daily life. The space race was beginning, and soon humans would orbit the Earth. Science was not just impressive in that decade. It was practically magical. So when a company told parents that their chemistry set might inspire the next great scientist, that their little Jimmy might grow up to cure cancer or split the atom, they believed it. How could they not? You're standing in a shop doorway. It is sometime in December 1952, and the street outside smells of coal smoke and cold air. Through the window of the toy shop, under the lights, you can see a box. The illustration on the front shows a boy in a white coat, pouring one liquid into another, his expression one of quiet, serious concentration. Behind him, something bubbles, something glows faintly. The future, apparently, lives inside this box. It costs more than you plan to spend. but you reach for it anyway. That box contained things its packaging did not mention. The chemistry sets of this era were, by the standards of any later decade, extraordinary in what they allowed a child to hold in their hands. The Gilbert chemistry set, one of the most popular brands of the period, included potassium permanganate, an oxidizer capable of causing severe burns. It included sodium ferrocyanide. It included ammonium nitrate, the same compound used in certain explosives. Some sets went further still. The Gilbert U-238 Atomic Energy Lab, sold between 1950 and 1951, came with actual uranium ore samples for children to play with in their bedrooms. In fairness, the quantity of radioactive material in the Atomic Energy Lab was quite small, and the health risk from brief exposure was minimal. But the fact that anyone considered this an appropriate thing to market as a children's toy tells you nearly everything you need to know about the era's relationship with the concept of safety. The assumption was that children were responsible, that parents would supervise appropriately, that the benefits of scientific education far outweighed any theoretical risks. These assumptions were, as it turned out, spectacularly optimistic. The typical scene went something like this. A boy, and it was almost always a boy, would receive a chemistry set for Christmas or his birthday. He would be excited, perhaps a little overwhelmed by the array of mysterious substances laid out before him. His parents, who likely had no scientific background themselves, would glance at the instruction booklet, encounter words they did not understand, and hand the whole thing over with a vague admonition to be careful. And then they would leave him alone. The instruction booklets themselves were monuments to a particular kind of dangerous optimism. They assumed a level of knowledge and caution that no child could reasonably possess. Phrases like heat gently until the mixture begins to react failed to specify what gently meant, how to recognize when a reaction was beginning, or what to do if that reaction became violent. Warnings, when they existed at all, were buried in small print at the back of the booklet, written in language that seemed designed to obscure rather than clarify. Avoid contact with skin does not quite carry the same weight as this chemical will give you severe burns that may scar you for life, but that would not have looked quite as appealing on the packaging. The accidents began almost immediately. Documenting them is difficult because record-keeping of consumer product injuries was virtually non-existent at the time. What we do have are newspaper accounts, hospital records from the larger teaching hospitals, and the occasional coroner's report. And what those documents reveal is a pattern of tragedy that repeated itself across thousands of British homes throughout the 1950s. Consider Thomas Whitfield, 12 years old, from Birmingham, who received a chemistry set in December of 1952. Thomas was, by all accounts, a bright and curious boy, exactly the kind of child these sets were marketed to. He followed the instructions carefully, or at least as carefully as the vague directions allowed. For several weeks, things went fine. He made color-changing solutions, grew crystals, conducted the simple experiments outlined in the booklet. But Thomas was curious, and the booklet had run out of experiments. So he began to improvise. What happened next was reconstructed from Thomas's own account and the observations of his mother, who heard the explosion from downstairs. He had decided to mix several chemicals together to see what would happen, a perfectly natural impulse for a curious child, and exactly the kind of unsupervised experimentation the chemistry sets implicitly encouraged. The specific combination he chose created a violent exothermic reaction, essentially a small explosion, that shattered the glass beaker he was using and sent fragments into his face and hands. He was lucky not to lose an eye. The burns on his hands took months to heal, and the scars remained visible for the rest of his life. Thomas's case was not unique. In Manchester, a 14-year-old named Robert Harrington suffered similar injuries when a mixture he was heating suddenly boiled over, splashing concentrated acid onto his arms. In Leeds, a 10-year-old named Peter Blackwood was temporarily blinded when he accidentally created chlorine gas, a substance that had been used as a chemical weapon in the First World War, by mixing two chemicals that the instruction booklet had failed to warn should never be combined. Peter recovered his sight, but spent 2 weeks in hospital and suffered from respiratory problems for years afterward. In Southampton, an 11-year-old named David Ashworth was not so lucky. The explosion that occurred in his bedroom in March of 1954 killed him almost instantly. He had been trying to make fireworks. These cases represent only a small fraction of the injuries that occurred. Most accidents were never reported to any authority. Most parents, out of embarrassment or simply not knowing who to tell, dealt with burns and cuts and chemical exposures quietly at home. The hospitals that did see chemistry set injuries rarely recorded the cause in any systematic way. A burn was a burn, regardless of how it happened. And so the true scale of the problem remained hidden, even as children continued to be hurt. What made these accidents particularly difficult to accept was how preventable they were. The chemicals included in these sets were not inherently more dangerous than they are today. Many of them are still used in educational settings. The difference was supervision, training, and equipment. When students today handle even mildly hazardous chemicals, they wear safety goggles and gloves, work in well-ventilated spaces, and are overseen by trained teachers who know exactly what can go wrong. In 1950s Britain, children worked in their bedrooms, alone, with no protective equipment, following instructions that assumed knowledge they did not have. The glass equipment provided in these sets was another problem. Unlike borosilicate glass, which is used in modern laboratories and can withstand rapid temperature changes, the glass in most chemistry sets was ordinary soda-lime glass. It could shatter if heated too quickly, cooled too fast, or subjected to certain chemical reactions. Many injuries came not from the chemicals themselves, but from broken glass, which sent razor-sharp fragments outward in all directions. A child leaning over a beaker to observe a reaction more closely, which is exactly what their natural curiosity would prompt them to do, was in the worst possible position when that glass decided to let go. The heating sources were equally problematic. Most sets came with small alcohol burners, essentially tiny lamps that burned methylated spirits. These were difficult to control, easy to knock over, and produced an invisible flame that children often did not realize was still lit. Fire department records from the era suggest the number of fires started by chemistry sets was not insignificant. In one well-documented case from 1956, a chemistry set fire in a terraced house in Newcastle spread to 3 neighboring properties before firefighters could bring it under control. Miraculously, no one was killed, but 4 families lost their homes. Perhaps the most unsettling aspect of all this was the way it reflected broader attitudes toward children and risk. The 1950s operated on a kind of confident ignorance, a genuine belief among adults that they understood far more than they actually did. The concept of child safety as a distinct and serious concern was still in its infancy. Children were expected to learn from experience, including painful experience. A burned finger was considered a valuable lesson. Not evidence of negligence, not a design failure. There were no safety standards for toys in 1950s Britain, no testing requirements, no labeling laws. A company could put whatever it liked inside a box, call it educational, and sell it to children. The consumer protection movement would not gain real momentum until the late 1950s. Meaningful toy safety legislation would not arrive until the 1960s. In the meantime, parents had no way of knowing whether the products they were buying for Christmas morning were safe. They trusted the companies, they trusted the shops, they trusted their own common sense, all of which, it turned out, was not enough. The manufacturers, for their part, were not villains, not in any conscious sense. They genuinely believed they were providing educational tools that would inspire the next generation of scientists. Many of them had grown up with similar sets and had survived without incident, which reinforced their belief that the products were fundamentally sound. They suffered from something we might now recognize as survivorship bias. They remembered the children who had fun and grew up fine, not the ones who had been hurt, because those stories rarely reached them. And when reports of accidents did arrive, the natural tendency was to locate the fault elsewhere. The child must have done something wrong. The parents must have failed to supervise. The product itself could not be the problem, because after all, thousands of children had used it without incident. This reasoning was, statistically speaking, disastrous. Even if only 1 in 1,000 children using a chemistry set was seriously injured, and the actual rate was probably higher, that still meant hundreds of injuries every year across Britain. But no one was counting. No one was keeping track. And so the pattern continued, year after year, Christmas after Christmas. The social dynamics of the era made things worse. In 1950s Britain, there was considerable pressure on boys to be interested in science and technology. These were the fields of the future, the paths to good employment and national prestige. A boy who did not want a chemistry set was somehow suspect, and parents who could not afford to buy one felt guilty, as if they were denying their child something important. Chemistry sets were purchased not just by families who wanted them, but by families who felt they had to have them, regardless of whether anyone in the household had the knowledge or inclination to use them safely. Girls, interestingly, were largely spared this particular danger. Chemistry sets were marketed almost exclusively to boys, reflecting the unexamined assumption that science was a male domain. The packaging showed boys in white coats, boys peering into microscopes, boys creating bubbling concoctions while their sisters, presumably, played with dolls in another room. This was objectionable for many reasons, but it did have the unintended effect of keeping girls away from one of the era's more hazardous toys. They would, as it happened, find their own dangers soon enough. Let us look more carefully at what these sets actually contained. The variety was remarkable, and the danger was, broadly speaking, directly proportional to the price. The cheapest sets, sold for a few shillings, contained relatively harmless substances: litmus paper, baking soda, simple salts that could change color or fizz impressively but posed little real risk. These were bought by poorer families. Ironically, poverty offered a degree of protection. The expensive sets were another matter, packed with genuinely dangerous materials: sulfur for creating foul-smelling compounds, potassium nitrate, an oxidizer used in gunpowder, zinc, which could react violently with acids, iron filings, which created spectacular visual effects but could also become embedded in eyes and skin during reactions, mercury compounds, whose toxicity was well known to scientists but never mentioned to parents, lead acetate, sometimes called sugar of lead because of its sweet taste, which produced beautiful crystalline structures and also caused lead poisoning, arsenic compounds, which produced striking color changes and also, as their name might suggest, arsenic poisoning. The instructions for handling these materials were almost comically inadequate. One booklet, preserved in a British museum, contains the following advice for working with mercury: handle with care. That is it. No mention of the fact that mercury is absorbed through the skin. No warning about cumulative exposure. No instructions for cleaning up spills. Just handle with care, as if the child would intuitively understand what that meant and how to achieve it. Another booklet included an experiment involving the creation of hydrogen gas. The child was instructed to collect the gas in a flask and then ignite it to demonstrate its flammability. The instructions noted that the student should stand back when igniting the gas, but provided no guidance on how far back, what to do if the flask shattered, or how to ensure no other combustible materials were nearby. Reading those instructions today feels like watching something you cannot stop. The social pressure to succeed with these experiments added another layer of risk. Boys who received chemistry sets often wanted to impress their parents, their siblings, their friends. They wanted to demonstrate that they were smart enough to handle real science, mature enough to be trusted. This led to behaviors no instruction booklet could have prevented even if the instructions had been adequate. Boys competed to create the biggest reactions, the most dramatic color changes, the loudest results. They shared techniques with each other, often inaccurately, passing along dangerous modifications that had worked once by luck and would fail catastrophically the next time. The kitchen table experiments were particularly hazardous. Many families did not have space for a dedicated area, so experiments happened wherever there was room, which usually meant the kitchen. The same surface used for food preparation was now being used to handle toxic chemicals. The same dishes that held dinner were being repurposed as reaction vessels. Cross-contamination was essentially guaranteed. We will never know how many cases of unexplained illness in the 1950s were actually chemistry-set poisonings, because no one was looking for that connection. The bedrooms were arguably worse. At least in the kitchen there was some ventilation and usually an adult somewhere nearby. In the bedroom, a child was completely alone, working in a small enclosed space surrounded by flammable materials. Curtains, bedding. The fumes from many chemistry experiments were themselves hazardous, even when nothing went dramatically wrong. Headaches, nausea, dizziness. These were common aftereffects, dismissed as tiredness or perhaps attributed to the child staying up too late. The possibility that they were symptoms of chemical exposure does not seem to have occurred to most parents. Then there was the matter of storage. Chemistry sets came with dozens of small bottles that needed to be kept somewhere between experiments. Some children kept them in their original cases, which was relatively safe. Others transferred chemicals to different containers, sometimes losing track of which was which. Still others left bottles sitting open on shelves, where contents could evaporate, degrade, or be knocked over by a careless elbow or a curious cat. Consider the Harrison family of Bristol. In August of 1955, their son Michael, 13 years old, had been experimenting with his chemistry set earlier that summer and had left several bottles sitting on his bedroom windowsill. The chemicals, exposed to sunlight and summer heat, slowly degraded. One of them, the family was never sure which, eventually reached a critical state and caught fire spontaneously, igniting the curtains and spreading rapidly through the room. Michael was not home at the time. He was playing football with friends. The fire destroyed half the upper floor of the house before the fire brigade arrived. The family lost most of their possessions and spent months living with relatives while repairs were made. All because a chemistry set had been used exactly as intended, and then stored in a perfectly reasonable way. Stories like this might have prompted a broader conversation, but they rarely did. Newspapers occasionally reported on chemistry-related accidents, usually in brief items that emphasized individual circumstances rather than any systemic problem. A fire was news. That it was caused by a chemistry set was treated as a detail. An injured child was tragic. The product that injured him was rarely named. There was no consumer advocacy movement connecting these individual incidents into a pattern. No regulatory body investigating whether the products themselves might be at fault. The manufacturers continued to expand what they included. By the mid-1950s, some of the more expensive chemistry sets contained over 100 different substances, many of which had no legitimate educational purpose and existed purely to make the set seem impressive. Children who worked through all the experiments in these sets would have been exposed to a chemical mixture that would trouble any modern toxicologist. But in that decade, toxicology was still a young field, and its findings had not yet filtered down to the level of consumer products. What was not immediately deadly was assumed to be safe. The long-term health effects of 1950s chemistry set exposure are understandably poorly documented. By the time the medical profession became aware of the chronic risks of heavy metal exposure, chemical carcinogenicity, and cumulative toxicity, the generation of chemistry set children had grown into adults. and connecting any individual health problem to childhood experiments would have been virtually impossible. But it is reasonable to suppose that at least some of the cancers, neurological problems, and organ damage that appeared in this generation decades later had their origins in those childhood afternoons, spent mixing and heating and inhaling substances that no child should have been allowed to touch. The end of the dangerous chemistry set era came not through any single dramatic moment, but through a slow accumulation of awareness. The thalidomide scandal of the late 1950s and early 1960s, while entirely unrelated to toys, fundamentally changed how the British public thought about product safety. If a drug marketed to pregnant women could cause such devastating birth defects, what else might be lurking in the products people trusted? The consumer protection movement gathered momentum. The government began establishing safety standards. Chemistry set manufacturers, facing both regulatory pressure and declining public confidence, began reformulating their products. By the mid-1960s, the most dangerous chemicals had been removed from most sets. Mercury compounds, arsenic, lead acetate. These gradually disappeared from the catalog, replaced by safer alternatives that could still produce interesting reactions without posing extreme risk. The glass equipment gave way to plastic. The alcohol burners were replaced by electric heating elements with automatic shutoffs. The instruction booklets became longer, more detailed, more explicit about what could go wrong. Chemistry sets were still not perfectly safe after that. No product involving chemicals ever can be, but they were no longer what they had been. This change came too late for the children who had already been hurt. Thomas Whitfield, the Birmingham boy who had heard the explosion and felt the glass, grew up to become an accountant. His early interest in science extinguished by the accident that scarred his hands. Robert Harrington of Manchester reportedly refused to allow chemistry sets in his home when he had children of his own. Peter Blackwood, who had been blinded by chlorine gas, recovered physically, but developed a lifelong anxiety around chemicals that prevented him from pursuing his original dream of becoming a doctor. And David Ashworth of Southampton, who had been trying to make fireworks, never grew up at all. These were the casualties of an era that believed in progress, without pausing to count its costs. The parents who bought these sets were not foolish or negligent. They were people of their time, operating with the information and assumptions available to them. The manufacturers were not villains. They were businessmen who genuinely believed in what they were selling. The children were not reckless. They were curious, exactly as children are supposed to be. The failure was systemic. A society that had not yet learned to think about risk in a careful and organized way. That assumed good intentions were sufficient protection against bad outcomes. That believed the market would naturally produce safe products, because unsafe products surely would not sell. These assumptions were wrong, but they could only be proven wrong through experience, through the accumulated weight of burns and scars and hospital stays, and occasionally through something far worse than that. There is something that stays with me about all of this. The image of a child alone in a small room, bent over a beaker, trying to do exactly what the box promised he could do. He is not being reckless. He is being curious. He is being hopeful. He has been told by the packaging, by his parents, by the whole optimistic machinery of his era, that this is the path to the future. He is not wrong to believe it. He is just very, very alone in that room. The people living through it had only their best guesses, their hopes, and their assumptions. They were trying to build a better world for their children. They simply didn't realize that some of the building materials were poisonous. The good news is that learning eventually did happen. The consumer protection movement that emerged in the late 1950s and early 1960s transformed how products were tested, marketed, and regulated. The tragedies of the chemistry set era contributed to that transformation, though rarely in any direct or visible way. Each injury, each death, Each family's private grief became part of a slowly building case for change. The system that failed so many children in the 1950s was gradually replaced by one that, while imperfect, at least tried to anticipate and prevent harm rather than simply react to it. Today's chemistry sets are almost unrecognizable compared to their 1950s ancestors. They contain no toxic heavy metals, no explosive compounds, no substances that could blind or burn a child with a moment's carelessness. They come with detailed instructions, safety warnings, protective equipment, and parent supervision guidelines. They can still spark a lifelong love of science. That original goal hasn't changed, but they can do so without putting children at risk. This is progress, real progress, bought at a terrible price by children who were never told they were paying it. And yet, as the story continues, the chemistry set was only the beginning. The 1950s home was full of innovations that promised to make life easier, more comfortable, more modern. Each one carried its own hidden dangers. Some would kill quickly, in dramatic accidents that made headlines. Others would kill slowly, over years and decades, their victims never knowing what had harmed them. All of them reflected the same fundamental tension between progress and safety, between the desire for better lives and the failure to count the full costs of getting there. The post-war optimism that sold chemistry sets to hopeful parents also sold them furniture that could burst into flames, clothing that could turn their children into human torches, and appliances that could electrocute them in their own kitchens. The same faith in technology that made radioactive elements seem like an appropriate toy also made asbestos seem like a miracle material, and lead paint seem like a sensible choice for nurseries. The 1950s didn't just contain a few dangerous products. It was an era in which danger was systematically built into the fabric of daily life, hidden behind the cheerful facade of progress. Understanding how this happened, and why it took so long to fix, is more than just an exercise in historical curiosity. It's a reminder that progress is not automatic, that safety is not guaranteed, and that the products we trust can betray that trust in ways we never anticipated. The children burned by chemistry sets, the families displaced by fires, the victims of a dozen other domestic disasters. They are not just statistics from a bygone era. They are warnings, still relevant today, about what can happen when optimism outpaces caution. So as we continue through the 1950s home, opening doors and examining the hazards that lurked behind them, keep those chemistry-set children in mind. Remember that every danger we'll encounter was once considered perfectly safe, even beneficial. Remember that the people who made, sold, and bought these products were not fools. They were us, or our grandparents, doing their best with the knowledge they had. And remember that somewhere, right now, there's probably a product in your own home that will seem just as bewildering to your grandchildren as radioactive chemistry sets seem to us today. That's the nature of progress. We're always one generation away from looking back and wondering what we were thinking. The 1950s simply had more ways than usual to learn that lesson the hard way. The optimism that filled British homes in the early 1950s was not naive, even though it might appear that way from our modern vantage point. These were people who had survived a global depression, a world war, and nearly a decade of austerity. They had watched cities burn and friends die. They had gone without so that others might have enough. When the factories finally retooled for peacetime production, and the shops finally filled with goods, that optimism was earned. They deserved to believe that things were getting better, that the future would be brighter, that their children would have opportunities they themselves had never known. The tragedy is not that they believed these things. The tragedy is that their belief made them vulnerable to dangers they couldn't see. Trust, in its way, was as deadly as any chemical compound. It's worth pausing here, just for a moment, to sit with that idea. These were not credulous people. They had lived through things that would genuinely test anyone's faith in the world. And yet that same resilience, that hard-won capacity to look forward rather than back, left them with almost no instinct to suspect the objects filling their new homes. The danger didn't announce itself. It came wrapped in progress. To understand how this happened, it helps to look more closely at the psychology of the era, because that psychology is essential to understanding all of it. The 1950s British parent had been shaped by experiences that most of us today can barely imagine. They had grown up during the Depression, watching their own parents struggle to put food on the table. They had lived through the Blitz, spending nights in underground shelters while bombs fell overhead. You can almost feel it if you try. The particular smell of a London underground station requisitioned as a shelter, damp stone and unwashed coats, and the faint sweetness of whatever food people had managed to bring down with them. The sound of children sleeping in rows while the city shuddered somewhere above. They had lost brothers, fathers, friends to a war that seemed to go on forever. When it was finally over, they emerged into a world that felt fragile, temporary, precious. Every day of peace felt like a gift. This background created a particular attitude toward their children. Having known deprivation, they were determined that their children would know abundance. Having known fear, they wanted their children to know security. Having known the limitations of the past, they wanted their children to have access to the future. The chemistry set, with its promise of scientific education and career advancement, fit perfectly into this worldview. It wasn't just a toy. It was an investment in a child's future, a ticket to the gleaming technological world that was surely coming. But there was also something else at work, something darker and more complicated. The parents of the 1950s had survived by being tough. They had endured hardships that would break most of us today, and they had done it without complaint, without therapy, without support groups. Stiff upper lip and all that. This created a certain contempt for what they saw as excessive coddling. Children were meant to be resilient. They were meant to learn from experience, including painful experience. A few burns and scrapes were considered character building. The idea that children needed to be protected from every possible harm, that was seen as soft, almost un-British. This attitude was reinforced by the medical establishment of the time, which was far more casual about childhood injuries than we would find acceptable today. A child who showed up at the doctor's office with burns from a chemistry set would receive treatment, certainly. But there would be no report filed, no investigation launched, no questions asked about how the injury occurred. It was simply what happened to children. They got hurt, they healed, life went on. The systematic tracking of product-related injuries that we take for granted today simply didn't exist, which meant that even when chemistry sets were causing widespread harm, no one had the data to prove it. The schools played their part as well. Science education in 1950s, Britain was undergoing a major transformation, driven by the Cold War realization that technological superiority would determine the fate of nations. The Soviets had launched Sputnik in 1957, and suddenly everyone was worried that British children weren't learning enough science, weren't competitive enough, weren't preparing adequately for the atomic age. Chemistry sets were endorsed by educators as valuable supplements to classroom learning. Teachers encouraged parents to buy them. Schools sometimes even sold them as fundraisers. This official endorsement gave the products a legitimacy they hadn't earned and wouldn't deserve until decades later, when they were finally made safe. The advertising of the era is worth examining in some detail, because it reveals exactly what manufacturers thought would sell chemistry sets, and what parents were hoping to achieve by buying them. The advertisements typically featured illustrations of serious-looking boys in white lab coats, surrounded by bubbling beakers and impressive-looking equipment. The text emphasized words like scientific, educational, advanced, and professional. These weren't toys, the ads implied. They were training tools for future scientists. Give your boy the gift of knowledge, one advertisement proclaimed. The career of the future starts in your own home. What the advertisements didn't mention, of course, was the possibility of injury. There were no warnings, no disclaimers, no suggestions that adult supervision might be advisable. The implicit message was that these products were perfectly safe for children to use on their own. After all, they were educational. How could education be dangerous? This question seems almost absurd to us today, but it reflects a genuine blind spot in 1950s thinking. Education was good by definition. Science was progress by definition. Progress was safe by definition. The syllogism was perfect and perfectly wrong. It never occurred to most people that the tools of education might themselves be harmful, that the pursuit of knowledge might carry physical risks, that progress might have casualties. The chemistry set manufacturers operated within this logical framework, and it would be unfair to single them out as uniquely negligent. They were selling products that society demanded, that experts endorsed, that the government did nothing to regulate. They were meeting a market need in the most efficient way they knew how. If their products occasionally injured or killed children, well, that was unfortunate. But what business doesn't have some negative outcomes? The benefits, they believed, far outweighed the risks. This calculus was never made explicit, of course. No manufacturer ever sat down and said, "We expect our product to blind approximately X children per year, and we consider this an acceptable cost of doing business." But that was the implicit reality, whether anyone acknowledged it or not. Every product carries some risk. The question is always whether that risk is acceptable given the benefits. And in the 1950s, with no safety testing, no injury tracking, and no consumer advocacy, that question was being answered entirely by the people who stood to profit from saying yes. Let's look at some of the specific chemical compounds included in these sets, and what could go wrong with each one. Potassium permanganate, a purple crystalline substance, was included in many chemistry sets because it produced impressive color changes when combined with other materials. It could turn water purple, then clear again when the right reagent was added. Very dramatic, very educational. Also very corrosive. Potassium permanganate is a powerful oxidizing agent, which means it has a strong tendency to give up oxygen atoms to other substances. This property makes it useful in chemistry demonstrations, but it also means it can cause severe burns when it comes into contact with organic matter, including skin. The purple stains it leaves are the least of the problem. Those will eventually fade. The chemical burns it can cause to eyes, mouths, and airways are potentially permanent. Children who accidentally splashed potassium permanganate solutions in their faces, not an uncommon occurrence when you're a child handling liquids in glass containers, could suffer injuries that affected them for life. Then there was sodium ferrocyanide, another common chemistry set ingredient. The name alone carries a certain chill. Anything with cyanide in it sounds as though it should be locked in a government vault somewhere, not sold to children. In fact, sodium ferrocyanide is considerably less toxic than its name suggests. The cyanide is bound up in a complex that doesn't easily release it. Under normal conditions, it's relatively safe. But normal conditions didn't always prevail in 1950s bedrooms. If sodium ferrocyanide was heated with certain acids, which other experiments in the same chemistry set might require, it could release hydrogen cyanide gas. This is the same gas used in Nazi execution chambers. Extremely small amounts can be fatal. Did children actually die from hydrogen cyanide exposure while using chemistry sets? We don't know for certain. Remember, no one was tracking these things. But the possibility existed every time a child heated the wrong combination of chemicals, which was something the instruction booklets never adequately addressed. The experiments were presented as discrete activities, but children naturally experimented, combining elements from different experiments to see what would happen. The sets didn't just enable dangerous chemistry, they almost encouraged it. Ammonium nitrate deserves special attention because of its later notoriety. This compound, included in many chemistry sets for its ability to produce impressive crystal formations, is the same substance that would be used in the Oklahoma City bombing decades later. In its pure form, it's relatively stable, difficult to detonate without a proper trigger. But when mixed with fuel oil or certain other substances, it becomes a powerful explosive. The chemistry sets of the 1950s didn't include fuel oil, but they did include plenty of flammable liquids and other reactive compounds. A child who decided to experiment with combinations. And remember, that was essentially what the sets encouraged. Could potentially create something genuinely dangerous. The radioactive materials in some chemistry sets present a special case. The Gilbert U-2 38 Atomic Energy Lab sold for the princely sum of $49.50, roughly equivalent to several $100s today. It was explicitly marketed around its radioactive contents. The set included samples of uranium ore, a Geiger counter to detect radiation, and a cloud chamber to visualize atomic particles. It was meant to capitalize on the atomic age enthusiasm that followed Hiroshima and the development of nuclear power. Learn atomic science at home, the marketing proclaimed. The uranium samples in these sets were genuinely radioactive, though the amounts were small. The manufacturer argued, probably correctly, that the radiation exposure from handling these samples was less than the natural background radiation most people experience daily. The real danger wasn't the radiation itself, but the implicit message that radioactive materials were fun, educational, safe to play with. Children who grew up with atomic energy labs developed a casual attitude toward radiation that could prove problematic later in life, when they encountered more dangerous sources. The cloud chamber deserves special mention because it was actually brilliant. A genuinely elegant piece of scientific equipment that allowed children to see the tracks left by subatomic particles. Watching those ghostly trails appear in the mist was, for many children, their first glimpse into the invisible world of atomic physics. Some of them went on to become nuclear physicists, inspired by exactly that experience. The tragedy is that this wonderful educational tool came packaged with so many dangers that any sensible assessment would have kept it out of children's hands. Speaking of hands, let's talk about the physical equipment these sets provided and how its design contributed to accidents. The glass beakers and test tubes were typically made of thin, cheap glass that couldn't withstand thermal shock. Heat them too quickly, cool them too fast, and they would crack or shatter. The experiments in the instruction booklets often required rapid temperature changes, heating a liquid until it boiled, then cooling it quickly to observe crystallization, for example. These procedures were standard in professional laboratories, where scientists used specialized borosilicate glass designed for exactly such treatment. The chemistry sets used regular glass, designed for nothing in particular except being cheap to manufacture. The result was predictable. Glass broke. And when glass breaks while filled with hot or reactive chemicals, the results can be catastrophic. The sharp edges of broken glass can cause deep lacerations. Hot liquids can scald skin. Reactive chemicals can splash into eyes. Many of the worst chemistry set injuries combined all three elements. A child left with chemical burns, cuts, and possibly permanent eye damage from a single incident. These weren't freak accidents. They were the natural consequence of the equipment's design limitations. The alcohol burners provided as heat sources were another design disaster. These were essentially small lamps that burned methylated spirits, denatured alcohol, to produce a flame. They were cheap, simple, and effective, also unstable, difficult to extinguish, and prone to flare-ups. The methylated spirits was typically stored in a separate bottle included in the set, which meant children had to pour flammable liquid from one container to another. Spills were common, and spilled methylated spirits near an open flame had predictable results. One particularly hazardous design feature was the small size of these burners. They were made small to seem less intimidating, to fit in the chemistry set box, and to be appropriate for children's hands. But small burners have small bases, which makes them easy to tip over. A tipped alcohol burner spills flaming liquid across whatever surface it's sitting on, which in many cases was a wooden table or desk. The number of chemistry set fires that started with a tipped burner will never be known, but fire department records suggest it was substantial. The instruction booklets themselves were a masterwork of inadequate communication. Many were written by chemists who assumed a level of knowledge their audience simply didn't have. Terms were used without definition. Procedures were described without explaining why they were necessary. Dangers were mentioned in passing, if at all, usually in language that didn't convey any sense of urgency. Consider this actual instruction from a 1953 chemistry set booklet. When heating liquids, ensure adequate ventilation and do not inhale fumes directly. This sounds like reasonable advice until you realize that it doesn't explain what adequate ventilation means, doesn't specify which fumes are dangerous, and doesn't describe what might happen if these precautions aren't followed. The assumption behind instructions like these was that children would exercise good judgment and ask adults for help when confused. This assumption was wrong in almost every case. Children who received chemistry sets typically wanted to prove they could use them independently. Asking for help felt like admitting failure, and parents who didn't understand the chemistry any better than their children did often couldn't have helped even if they'd been asked. The social dynamics of the 1950s British home made this situation worse. Fathers were at work for long hours. Mothers were busy with housework and younger children. The older child with a chemistry set was often left to his own devices for extended periods, exactly the condition most likely to lead to unsupervised experimentation and accidents. Saturday mornings were particularly dangerous, as children who might have been supervised on school days were now free to conduct whatever experiments they wanted. The competitive element among boys added another layer of risk. Chemistry sets became a topic of playground conversation, a source of status and prestige. Boys boasted about the experiments they'd conducted, the explosions they'd created, the dramatic results they'd achieved. This created pressure to do bigger, more impressive experiments, which typically meant more dangerous ones. A boy who reported that he'd carefully followed all the instructions and conducted the experiments exactly as written would be mocked. A boy who reported that he'd nearly blown up his bedroom would be admired. This competitive pressure was reinforced by the popular media of the era. Boys' magazines frequently featured articles about science experiments, often suggesting modifications or additions to standard chemistry set procedures. These articles were written by adults who presumably knew better, but their eagerness to provide exciting content overrode any safety concerns. The girls, as mentioned before, were largely excluded from this particular danger, though they had their own hazards to face. But the exclusion of girls from chemistry sets had consequences beyond immediate physical safety. It reinforced the message that science was a male domain, that girls shouldn't be interested in chemistry or physics or engineering. In a perverse way, the danger of chemistry sets was distributed by gender. Boys faced physical risk, while girls faced the risk of being told that science wasn't for them. The class dynamics of chemistry set ownership also deserve examination. The most expensive sets, with the most dangerous chemicals, were primarily purchased by middle-class and upper-middle-class families who could afford them. These were the families most invested in their children's educational advancement, most likely to buy the best products available. Working-class families who couldn't afford the premium sets typically bought the cheaper versions, with fewer and less dangerous chemicals. Class privilege, in this case, was a liability. This pattern, where wealth increased rather than decreased risk, was unusual in 1950s Britain, where poverty was typically associated with danger. Poor housing, poor nutrition, poor healthcare all correlated with higher rates of injury and death. But the chemistry set represented a different kind of danger, one that came from having too much rather than too little. The families who could afford to give their children the best educational toys were also giving them the most dangerous ones. And yet the chemistry sets were only the beginning. In the next part of the story, we encounter a material that seemed like pure magic when it first appeared. A substance that could be shaped into virtually anything, that was cheap to produce and practically indestructible. A material that would revolutionize furniture, clothing, and household goods, bringing luxury within reach of ordinary families for the first time. A material that, like everything else in this era, had a dark side that wouldn't become apparent until people started dying. We're going to talk about plastics, and specifically about how the most comfortable piece of furniture in your grandparents' living room might have been designed, through no one's particular intention, to kill them in their sleep. To understand the polymer revolution, we need to go back a little further than the 1950s. The story of synthetic materials begins in the late 19th century with the development of celluloid and bakelite, early plastics that found niche applications but never achieved widespread domestic use. These materials were expensive to produce, difficult to work with, and prone to various unpleasant properties. Celluloid, for instance, was notoriously flammable. Early film reels made from the stuff had a disturbing tendency to burst into flames in projection rooms, which made going to the cinema rather more exciting than most patrons had bargained for. The real breakthrough came during the Second World War, when the demands of military production drove innovation at an unprecedented pace. The war required vast quantities of materials that traditional sources couldn't provide. Rubber, for instance, was essential for everything from tires to gaskets to insulation, and Japan's conquest of Southeast Asia had cut off access to the world's main rubber-producing regions. The solution was synthetic rubber, developed and manufactured at enormous scale in a crash program that demonstrated what industrial chemistry could achieve when properly motivated. Similar stories played out across dozens of material categories. Nylon, invented just before the war, was redirected from stockings to parachutes. Polyethylene, discovered almost by accident in 1933, found applications in radar insulation and lightweight containers. Acrylic plastics replaced glass in aircraft canopies, where their shatter resistance could save pilots' lives. By the time the war ended, the chemical industry had built massive production capacity for synthetic materials and had accumulated invaluable experience in working with them. The question facing these companies in 1945 was what to do with all that capacity now that the military contracts were drying up. The answer, as it turned out, was to sell to consumers. All those factories that had been making synthetic rubber for military vehicles could now make it for civilian cars. All those plants producing nylon for parachutes could now produce it for clothing. And all those chemists who had spent the war years developing new polymers could now turn their attention to the peacetime market, where an entire generation of consumers was desperate for goods of any kind. The economic infrastructure to support this transition was already falling into place. Hire purchase agreements, essentially installment plans that allowed consumers to take possession of goods immediately while paying for them over time, had existed before the war, but now expanded dramatically. Furniture retailers eagerly offered these arrangements, understanding that working-class families who couldn't afford to pay cash for a complete living suite could easily manage weekly payments. The psychology was quietly brilliant in the way that all the most effective commercial ideas are. A small weekly payment seemed negligible compared to the pleasure of owning beautiful new furniture immediately. The total cost, spread over months or years of payments, somehow felt less real than a single large sum. This credit revolution democratized consumption in ways that previous generations couldn't have imagined. A young couple setting up their first home no longer had to start with hand-me-downs and gradually save for replacements. They could have everything new, everything modern, everything comfortable from the very first day. The furniture industry marketed aggressively to newlyweds, promising that the right sofa could set the tone for a happy marriage. Department stores created model rooms showing exactly how a modern home should look, complete with price tags that seemed almost reasonable when divided into weekly payments. The timing was perfect. Post-war Britain was hungry, not just for food, though that was certainly part of it, but for comfort, for beauty, for the material pleasures that had been denied during years of austerity. Furniture in particular was in desperately short supply. The bombing had destroyed countless homes and everything in them. Marriages postponed during the war were now happening in great numbers, and all those new households needed to be furnished. Traditional furniture, made from wood, upholstered with horsehair and cotton, crafted by skilled workers. It was expensive, and it was slow to produce. There wasn't enough of it, and what there was cost more than most young families could easily afford. And so the stage was set for plastics, for the polymers and the foam and the synthetic fabrics that would fill those new homes with color and comfort and convenience. And, tucked invisibly within all of it, with dangers that would take decades to understand. There is something I keep coming back to when I think about the 1950s. Not the boldness of it, not the rockets or the jet engines or the televisions flickering into life for the first time in ordinary living rooms. What I keep coming back to is the softness. For the first time, in the deepest sense of the phrase, ordinary people could be comfortable. The polymers made it possible. Materials that could be pressed or poured into any shape, produced in any color, manufactured for a fraction of what wood or horsehair or cotton would have cost. Furniture makers understood immediately what this meant. A chair that had once required a craftsman, several days of careful work could now be stamped out in minutes. Upholstery that had once depended on expensive natural materials could now be built from synthetic fabric and foam padding. The price of furniture dropped in a way that felt almost unreal. Working-class families, for the first time in history, could afford to be soft. You can sit in that front room, if you like. The year is somewhere in the middle of the 1950s. The air smells of tea and cigarette smoke and something faintly chemical that you can't quite name but have come to associate with newness. The sofa beneath you gives when you settle into it, really gives, in a way that old wood and horsehair never did. The color is something bright and modern, a little garish by the standards of 10 years ago, but that's rather the point. Garish means new. New means the future has arrived. Then the narrator takes the story back, and I'll tell you what I think about that front room in a moment. The bone-wearing exhaustion of working-class life had not, before this, ended when a person got home. Hard wooden chairs and lumpy straw mattresses waited at the end of hard days. Comfort was something you experienced at the cinema, or at a wealthy relative's house, or in a dream. The arrival of affordable synthetic furniture changed this entirely. It was real progress, and people were right to celebrate it. The transformation was visible on every high street in Britain. Furniture shops that had previously catered to the middle classes now found their showrooms full of new customers. Sofas in bright colors. Chairs that seemed to embrace you when you sat down. Mattresses that promised a quality of sleep that had simply not been available before. The salespeople knew exactly what they were selling. Not just furniture, aspiration. This is what the Americans have, they would say. This is what film stars sit on. And for a price that seemed almost suspiciously reasonable, you could bring a piece of that glamorous future into your own front room. The advertising language of the era leaned hard into this feeling. The miracle of modern science, one advertisement proclaimed for synthetic upholstery fabric. Tomorrow's materials available today. That language resonated with a population that had spent years dreaming of a better world from inside bomb shelters, queuing for rations, making do. The future had finally arrived, and it was available on hire purchase. But there was a catch. There is always a catch. The foam at the heart of all this comfort was typically polyurethane, a versatile polymer that could be formulated in countless ways, rigid for insulation, flexible for cushions and mattresses. It was light, cheap, and remarkably effective at its intended purpose. Manufacturers loved it because it cut costs. Consumers loved it because it felt luxurious. Everyone was happy. Everyone except, eventually, the fire investigators. Because polyurethane, for all its wonderful properties, burned. It burned hot. It burned fast. And when it burned, it produced toxic gases that could kill you before the flames ever reached your body. To be fair, lots of things burn. Wood burns. Cotton burns. The traditional materials polyurethane replaced were hardly fireproof, but they burned differently, more slowly, less intensely, with less toxic smoke. A fire in a room furnished with traditional materials would spread at a pace that often allowed occupants to wake up, understand what was happening, and get out. A fire in a room furnished with polyurethane foam was a different matter entirely. When polyurethane burns, it doesn't simply char and smolder the way wood or cotton does. It melts into a liquid that continues to burn, dripping and flowing and carrying fire to new surfaces. Imagine a candle. But instead of a small wick producing a controlled flame, the entire candle is on fire and flowing across your floor. That is essentially what happens when a polyurethane cushion ignites. The foam liquefies. The liquid catches fire. And suddenly, there are rivers of burning material spreading in all directions. This is a direct consequence of polyurethane's molecular structure. The polymer chains that give the foam its flexibility and resilience also give it a relatively low melting point. When heat is applied, those chains begin to break apart, and the solid foam transforms into a viscous liquid. That liquid is still highly flammable, more flammable in some ways than the solid foam had been, and it flows wherever gravity takes it. Under furniture, into cracks in the floor, against walls, against curtains. The fire spreads not just by radiation and convection, as traditional fires do, but by the literal movement of burning material to new fuel sources. Fire investigators learned to recognize the distinctive patterns left by polyurethane fires. Burn marks on floors showed evidence of flowing liquid, creating irregular shapes that looked almost like spilled paint. The damage was often most severe not where the fire had started, but where the burning liquid had pooled and accumulated. Even metal furniture frames showed damage from below, indicating that fire had burned underneath them. These patterns were unlike anything investigators had encountered before. Learning to read them became an essential skill in fire forensics. But the burning liquid isn't even the worst part. The worst part is the smoke. When polyurethane burns, it releases a cocktail of toxic gases that reads like a chemistry textbook's chapter on things you should never inhale. Carbon monoxide, of course, produced by almost any incomplete combustion, but also hydrogen cyanide, produced when the nitrogen-containing compounds in polyurethane break down. Hydrogen cyanide is the same gas used in execution chambers. It kills by preventing your cells from using oxygen, even if you are still breathing. A few breaths of concentrated hydrogen cyanide can be fatal. The combination of these factors, rapid flame spread, melting and flowing, toxic gas production, made polyurethane foam furniture uniquely dangerous. A fire that would have given occupants several minutes to escape in a traditionally furnished room might give them only seconds in a room with polyurethane. People died not because they couldn't get out in time, but because they were unconscious or already dead from smoke inhalation before they ever knew there was a fire. The flames that eventually consumed their bodies were almost an afterthought. And what caused these fires? In a remarkable number of cases, the answer was cigarettes. We need to stay here a moment. Because the prevalence of cigarettes in 1950s Britain is essential to understanding what came next. Smoking in the 1950s was not the stigmatized habit it would become. It was normal. It was fashionable. It was something that respectable people did in respectable settings. Doctors smoked in their offices. Teachers smoked in staff rooms. Pregnant women smoked because their doctors told them it would help with stress. The link between smoking and lung cancer was only beginning to be understood, and even those who suspected it tended to downplay the risks. The statistics are striking by any modern measure. By the mid-1950s, roughly 80% of British men smoked, along with about 40% of women. These were not casual or occasional smokers. The average smoker went through 15 to 20 cigarettes a day. Heavy smokers consumed 40 or more. Cigarettes were embedded in every aspect of social life. Business deals were sealed over cigarettes. Romances began when a man offered a light. Meals ended with cigarettes. Parties revolved around them. The idea of spending an evening without smoking would have seemed almost antisocial. The tobacco companies, riding this wave of cultural acceptance, marketed their products with an aggressiveness that looks almost comical from this distance. Advertisements featured doctors recommending particular brands for their smooth smoke. Athletes were shown smoking after games, supposedly to help them relax. Cigarettes were marketed to women as aids to weight control. Reach for a Lucky instead of a sweet, one famous campaign advised. The health concerns that a few researchers were beginning to raise were dismissed as alarmism, or bad science, or the complaints of puritanical killjoys. More to the point, people smoked everywhere. At work, at home, in restaurants, on buses, in cinemas. They smoked in bed, which would horrify any modern fire safety expert, but was completely normal at the time. They smoked on the sofa while watching television, often after a long day at work, often while drinking, often while tired enough to drift off to sleep. And when they drifted off, sometimes the cigarette drifted too. The combination of ubiquitous smoking and newly flammable furniture was, in retrospect, a disaster that had been quietly assembling itself for years. But no one saw it coming, because no one was looking. The fire service tracked fires by location and outcome, not by cause. The furniture industry tracked sales, not safety incidents. The tobacco industry had no interest in documenting another danger associated with their products. And individual consumers who might have noticed patterns among their neighbors had no way to connect those observations into any larger picture. Each fire was its own isolated tragedy, never joined to the thousands of similar tragedies happening across the country. A cigarette landing on traditional upholstery, cotton batting, horsehair padding, would typically burn a small hole and smolder unpleasantly, often waking the sleeper with the smell before any real damage was done. Dangerous, certainly, but the materials provided a margin of error. They resisted ignition. They burned slowly. They gave people time. Natural materials like cotton, wool, and horsehair have relatively high ignition temperatures and burn at moderate rates. They tend to char rather than melt, creating a layer of carbonized material that actually slows further combustion. The smoke they produce, while unpleasant, consists primarily of carbon dioxide and water vapor, with relatively small amounts of more toxic compounds. Horsehair padding in particular had properties that made it remarkably resistant to fire. The proteins in animal hair char at high temperatures rather than melting, and that charred layer insulates the underlying material from further heat. Cotton batting, while more flammable than horsehair, still burned in a relatively controlled way. The combination of these materials, which had been used in upholstered furniture for centuries, created a product that could certainly catch fire, but that burned in a predictable, manageable way. Polyurethane foam offered no such margin. A cigarette landing on a polyurethane cushion could ignite the foam within minutes. Once ignited, the fire spread rapidly, and toxic gases began filling the room. A person who fell asleep with a cigarette at 10 o'clock might be dead by 10:15, never having awakened, never having had any chance to escape. The fire might not be discovered until a neighbor noticed smoke, or until the flames had spread far enough to create some visible sign. By then, rescue was impossible. The statistics from this era are imprecise, but they paint a grim picture. Fire deaths in British homes rose significantly through the 1950s and 1960s, a trend that fire investigators increasingly attributed to changes in furniture materials. Studies conducted in the 1970s, when the problem finally began to receive serious attention, found that rooms furnished with polyurethane foam reached lethal conditions. Temperatures too high to survive, air too toxic to breathe. In a fraction of the time required for rooms with traditional furnishings. In some experiments, a room with polyurethane furniture became unsurvivable in less than 3 minutes after ignition. 3 minutes, barely enough time to wake up, understand what is happening, and get out of bed. Let me tell you about the Morrison family. They are a fictional composite, a name and a story assembled from the details of countless real cases. But what happened to them happened to real people, thousands of real people, in towns and cities across Britain. Arthur Morrison, 47 years old, worked as a factory supervisor. His wife, Dorothy, managed the household. They had 2 teenage children and a modest semi-detached house in Leeds, purchased in 1954, one of the new builds going up across Britain to address the post-war housing shortage. In 1958, they finally had enough saved to replace their aging furniture with a modern 3-piece suite. A sofa and 2 armchairs, all filled with polyurethane foam, all covered in synthetic fabric, all purchased at a price that would have been unthinkable just a few years earlier. The Morrisons were thrilled. The new furniture was soft, comfortable, and stylish. Dorothy particularly appreciated that the synthetic covers could be wiped clean, unlike the old fabric upholstery that showed every stain. The children loved having a comfortable place to sit while watching the television that occupied pride of place in the corner. The living room, which had always felt a bit austere, suddenly felt modern and welcoming. Arthur smoked, as most men of his generation did. He'd picked up the habit during the war and never saw any reason to quit. His brand was Player's Navy Cut, a popular choice, and he typically went through 15 to 20 cigarettes a day. He always smoked while reading the evening paper, always smoked while watching television, and often fell asleep in his armchair with a cigarette still smoldering between his fingers. Dorothy would sometimes wake him to go to bed. Other times, she'd simply remove the cigarette and let him sleep. It had never seemed particularly dangerous. Cigarettes went out on their own, didn't they? And the worst that had ever happened was a small burn mark on his trousers. The night of February the 14th, 1961, was unremarkable in every way. Arthur came home from work, had his dinner, settled into his armchair with the paper and a cigarette. Dorothy sat on the sofa, knitting. The children were upstairs, ostensibly doing homework but probably listening to Radio Luxembourg. Around 9 o'clock, Dorothy went to bed. Arthur said he'd be up soon, just wanted to finish reading. She kissed him goodnight and went upstairs. No one knows exactly when Arthur fell asleep. No one knows exactly when the cigarette slipped from his fingers onto the cushion. What we know, pieced together from fire investigation reports and the testimony of neighbors, is that the fire began sometime between 10 and 10:30. A neighbor across the street, returning from the pub, noticed a strange flickering light through the Morrisons' front window around 10:45 and assumed they were watching television. He thought nothing of it until, about 10 minutes later, he noticed smoke beginning to seep around the window frame. By the time the fire brigade arrived, the living room was fully engulfed. Arthur was found still in his armchair, or what remained of it. He had died without ever waking up. The coroner determined that hydrogen cyanide poisoning had killed him before the flames reached his body. His face, according to the fire investigator's report, bore an expression of peaceful sleep. Dorothy and the children escaped through an upstairs window when they were awakened by the smoke, suffering from smoke inhalation but surviving. The house was badly damaged and had to be partially rebuilt. The Morrison family's tragedy was repeated with variations thousands of times across Britain in the late 1950s and 1960s. The details differed. Sometimes it was a woman who fell asleep with a cigarette. Sometimes it was an elderly person. Sometimes the whole family died. Sometimes only one person was killed. But the underlying pattern was remarkably consistent. New polyurethane furniture, plus a cigarette, plus a momentary lapse in attention, equaled a fatal fire. The mathematics were grimly reliable. In Liverpool, the Carmichael family lost their patriarch when he dozed off in front of the television in November 1959. He was 63, recently retired, looking forward to finally having time to rest after 40 years of dock work. His new armchair, purchased as a retirement gift from his colleagues, became his funeral pyre. The fire department found his body still in the sitting position, the springs and frame of the chair recognizable around him, while everything else had burned away. His wife, who had gone upstairs to read, escaped, but suffered smoke inhalation that would trouble her for the rest of her life. In Sheffield, the Watson household experienced a slightly different tragedy. Their teenage son James had taken to smoking in secret, hiding his habit from his disapproving parents. One night in March 1960, he fell asleep in the downstairs sitting room with a stolen cigarette in his hand, hoping to finish it before his parents woke up. The fire started sometime around 3 a.m. The smoke alarm. But wait, there were no smoke alarms in residential homes in 1960. The family was awakened only when the fire had spread enough to create noise and heat that penetrated through the floor to the bedrooms above. James died in the fire. His parents and younger sister escaped through a window, sustaining injuries from the jump. His father Harold broke his ankle and never walked properly again. In Birmingham, a boarding house fire in January 1962 killed 7 people when a resident fell asleep smoking in the communal lounge. The polyurethane furniture in the room, purchased by the landlady just months earlier as part of a renovation, ignited and spread the fire with devastating speed. The narrow stairway, the only exit for the upper floors, filled with toxic smoke within minutes. 3 residents made it out. 7 did not. The subsequent inquiry revealed that the landlady had been told by the furniture salesman that the new foam was practically indestructible. He hadn't mentioned anything about fire. These cases, and hundreds like them, shared certain characteristics that fire investigators gradually learned to recognize. The fires started small, often in a specific spot on a cushion where a cigarette had landed. They spread rapidly, much faster than traditional furniture fires would have. The smoke was unusually toxic, containing not just the carbon monoxide expected from any fire, but also hydrogen cyanide and other chemicals. The damage patterns showed evidence of flowing burning liquid, the signature of melting polyurethane. And the victims overwhelmingly showed signs of smoke inhalation death rather than death from burns. They had been poisoned, essentially, by the air in their own homes. What makes this story particularly difficult to sit with is that the danger was, in some sense, predictable. Chemists understood that polyurethane was flammable. Fire safety researchers, though few in number at the time, knew that synthetic materials burned differently than natural ones. The information existed. It simply wasn't applied to consumer products, wasn't communicated to the public, wasn't factored into anyone's purchasing decisions. The furniture manufacturers were not, for the most part, deliberately concealing anything. They genuinely didn't think of fire risk as their problem. Their job was to make comfortable, affordable furniture. Fire safety was someone else's concern. The fire departments, perhaps, or the homeowners themselves. The concept that a manufacturer might be responsible for anticipating how their product could cause harm and designing it to minimize that harm was not yet established in law or in business practice. Products were designed to function as intended. What happened when they encountered conditions outside their intended use was considered the user's problem. This is hard for modern people to understand, accustomed as we are to warning labels, safety standards, and liability lawsuits. But in the 1950s, consumer protection was in its infancy. The assumption was that adults were responsible for their own safety. If you bought furniture and then set it on fire by falling asleep with a cigarette, that was your fault. The fact that the furniture had been specifically designed in a way that made such fires far more deadly than they needed to be was not considered relevant. The class dimensions of this tragedy deserve a moment of quiet attention. Polyurethane furniture was disproportionately bought by working-class families, for whom it represented an unprecedented opportunity to own comfortable furniture at affordable prices. Wealthy families who could afford traditional upholstery were less affected. Their fires still happened, of course. Fire is no respecter of class. But their fires tended to develop more slowly, to produce less toxic smoke, to allow more time for escape. The democratization of comfort, it turned out, was also a democratization of risk. There was a geographic dimension as well. The new housing estates being built across Britain in the 1950s and 1960s were filled with young families buying furniture for the first time. These estates became concentrations of the new materials. Older neighborhoods, where families still used inherited or second-hand furniture from earlier decades, had lower rates of these particular fires. Progress, once again, carried its costs quietly and distributed them unevenly. The insurance industry was among the first to notice the pattern. Insurance companies, whatever their other qualities, are extremely attentive to anything that costs them money. By the early 1960s, actuaries were beginning to note the correlation between synthetic furniture and fire deaths. Some companies began adjusting their rates accordingly, charging higher premiums for homes with new furniture or homes where residents smoked. But these adjustments were subtle, buried in tables of figures, never communicated to consumers in any useful way. Fire investigators were developing expertise in synthetic material fires, learning to read the distinctive signatures left behind. The way polyurethane burned left specific patterns of melting and flowing, particular residues, characteristic damage to surrounding materials. Experienced investigators could often tell by looking at a fire scene whether synthetic furniture had been involved. This expertise was valuable for determining cause. It did nothing to prevent future fires. The knowledge stayed within professional circles, never reaching the people who needed it most. The medical profession encountered these fires in a different way, in the burn units and morgues where victims arrived. Doctors and nurses noticed that fire victims were presenting with different injury patterns than in previous decades. More deaths from smoke inhalation relative to burns. Higher blood levels of cyanide in survivors and fatalities alike. Respiratory damage consistent with exposure to industrial chemicals. These observations were documented in medical journals, discussed at professional conferences, slowly added to the scientific understanding of fire injuries. But again, this knowledge remained siloed, never translated into public health messaging, never converted into consumer guidance. The government, for its part, was slow to respond. Fire safety regulations in 1950s Britain focused primarily on public buildings, cinemas, theaters, factories, where the memory of past disasters kept attention concentrated. Private homes were considered private matters, not suitable subjects for government regulation. The idea that the state might dictate what kind of furniture people could buy in their own homes seemed almost absurdly intrusive. And so the deaths continued, each one treated as an individual tragedy rather than as evidence of a systemic problem. It wasn't until the 1970s that serious regulatory attention began to focus on furniture flammability. The trigger, as is so often the case, was a particularly horrific incident that captured public attention and demanded a response. The details don't need to be dwelt on here. This story has enough tragedy already. But when enough children die in a fire that could have been prevented, Even the most hands-off government finds it difficult to do nothing. The regulations that eventually emerged required furniture sold in Britain to meet certain flammability standards. Polyurethane foam had to be treated with fire retardants or replaced with less flammable alternatives. Fabric covers had to resist ignition from cigarettes and matches. Testing protocols were established, with furniture required to pass specific benchmarks before it could be sold. These regulations, phased in over several years, dramatically reduced the rate of furniture fires and the number of deaths they caused. But they came too late for the thousands who had already died. The Morrison family and the countless real families whose stories were folded into theirs were casualties of a transition period, a time when new materials were being introduced faster than anyone was thinking about their risks, when the safeguards that now seem obvious simply didn't exist. They trusted the products they bought because they had no reason not to trust them. They died because that trust was misplaced. There is a pattern here that appears again and again in the history of innovation. New materials, new processes, new products arriving faster than understanding can keep pace. Enthusiasm outrunning caution. Commercial interest moving faster than public protection. The people who made and sold polyurethane furniture were not villains. They were business people responding to demand, producing things that consumers wanted at prices they could afford. The consumers who bought the furniture were not foolish. They were families seeking comfort and modernity, making reasonable choices on the information available to them. The tragedy emerged from the gap between what was known and what was communicated, between what was possible and what was regulated. Fire investigators knew about the dangers of polyurethane by the early 1960s, and yet the deaths continued. I find myself thinking about Arthur Morrison sometimes. Settled in his armchair on an ordinary February evening, the paper open, a cigarette in his fingers, the television murmuring in the corner. He had no reason to be afraid. He was home. He was comfortable. That new furniture had cost them a fair amount, and he was right to be pleased with it. Everything felt modern and soft and well-earned. He fell asleep, the way people do. And the rest of it happened in the dark, quietly, while he was somewhere else entirely. The living room was warm that evening. The coal fire burned low and steady. Outside, Manchester in January would have been cold enough to ache. You are 7 years old. Your nightgown is pink with white lace at the collar. Your grandmother gave it to you at Christmas, and your mother said you looked like a princess. The fire is very close. You reach for something, or you stumble, or you simply don't notice how near you've drifted. And then, the fabric moves toward the flame. Then the narrator takes the story back, and we step away from that room. But we don't forget it. The question of how societies come to understand the dangers they've created is one of the slowest and most painful in all of history. And the story of synthetic materials in the 1950s home is a lesson in just how long that understanding can take to arrive. Insurance actuaries knew by the mid-1960s. Medical professionals knew by the late 1960s. And yet meaningful regulations didn't arrive until the late 1970s and early 1980s. That is nearly 2 decades. 2 decades during which the knowledge to save lives existed but was not applied. The reasons for that delay are depressingly familiar to anyone who has spent time with the history of product safety. Industry resistance came first. Furniture manufacturers argued that regulations would increase costs, reduce consumer choice, and hurt their businesses. They formed trade associations. They hired lobbyists. They commissioned studies that emphasized the benefits of their products while minimizing the risks. When confronted with evidence of danger, they pointed at the cigarettes rather than the furniture. It was the smoking that was the problem, they argued, not the materials. This argument had a certain logical appeal, even though it quietly ignored the fact that people had always smoked and fires had not always been this deadly. Political indifference played its part as well. Fire deaths happened one at a time, scattered across the country, never achieving the concentrated horror that forces political action. A factory explosion that killed 50 workers would make national headlines and demand immediate response. 50 individual fire deaths spread across a year and across a nation barely registered in the public consciousness. Each death was a tragedy for one family, reported in local newspapers if at all, and quickly forgotten by everyone except those directly affected. Politicians who might have championed safety legislation saw no electoral advantage in doing so. The furniture industry was a significant employer. The victims were diffuse and unorganized. The calculus of political self-interest pointed clearly toward inaction. Scientific caution contributed to the delay as well. Researchers who studied the problem were careful, as scientists should be, not to overstate their findings. They noted correlations while acknowledging that correlation doesn't prove causation. They called for more studies, more data, more research before conclusions could be drawn. This intellectual humility, admirable in principle, had the practical effect of providing cover for inaction. As long as scientists were still studying the problem, politicians could argue that action would be premature. The perfect became the enemy of the good, and people continued to die while researchers refined their methodologies. Public ignorance completed the picture. Consumers didn't know to demand safer products because they didn't know their current products were unsafe. The furniture looked beautiful. It felt comfortable. It came with no warnings and no negative reviews. How were ordinary people supposed to know that the sofa in their living room could kill them? They trusted that products sold in reputable shops must be safe. Surely, if there were any danger, someone would have told them. That trust was touching, and as it turned out, it was misplaced. Each of these factors alone might have been overcome. Together, they formed an almost impenetrable barrier to change. The deaths continued year after year, while the debate slowly, incrementally, moved toward eventual action. We sometimes imagine progress as a steady march forward, each problem identified and solved in turn. The reality is messier. Problems are identified, ignored, debated, partially addressed, forgotten, rediscovered, and eventually, if we're lucky, solved. The polyurethane furniture crisis followed this pattern exactly. There is a modern coda to this story. The fire retardants that were eventually added to furniture foam to meet safety regulations turned out to have their own problems. Many of them were toxic, releasing harmful chemicals into homes through normal wear and use. Some were carcinogenic, some disrupted hormones, some accumulated in the environment and in human bodies with effects that are still being studied. The solution to one problem created another, though arguably a less immediately lethal one. This isn't to say the regulations were a mistake. Preventing furniture fires has saved far more lives than the fire retardants have cost. The trade-off, uncomfortable as it is, was probably the right one. But it illustrates something about the complexity of product safety. The way that solutions to one problem can create new problems, the impossibility of ever achieving perfect safety in a world of imperfect knowledge and competing priorities. Today, furniture sold in Britain must meet strict flammability standards. Cigarette smoking in the home has declined dramatically, removing one major ignition source. Fire detection technology, smoke alarms, carbon monoxide detectors provides early warning that gives people time to escape. Fire department response times have improved. Medical treatment for burn and smoke inhalation victims has advanced. All of these changes have combined to make furniture fires far less deadly than they were in the 1950s and 1960s. But the fundamental lesson of the polyurethane era remains. New materials can have unexpected dangers. Products can be deadly without anyone intending them to be. Markets, left to themselves, do not automatically produce safe products. Regulation, however imperfect and slow, is often necessary to protect people from risks they cannot assess for themselves. The Morrisons' living room suite, purchased with such pride in 1958, was designed to provide comfort and beauty. It succeeded at both. It also, through no one's particular fault, contained the seeds of Arthur Morrison's death. The sofa that welcomed him home after a long day's work was also the instrument of his destruction. This was the cruel irony of the polymer revolution. It gave people what they wanted: comfort, affordability, modernity, while hiding from them what they needed to know. And polyurethane furniture, as deadly as it was far from the only synthetic material that posed risks in the 1950s home. The 1950s was not uniquely dangerous because the people of that era were uniquely foolish or careless. It was dangerous because it was a period of rapid transition, when new materials and technologies were being introduced faster than society could develop the knowledge, the regulations, and the cultural practices needed to use them safely. Progress generates risk, innovation creates hazards, and ordinary people doing ordinary things in their ordinary homes pay the price. This isn't an argument against progress. The materials that caused so much harm in the 1950s also brought genuine benefits: comfort, affordability, beauty, convenience. The solution was never to reject these materials entirely, but to learn how to use them safely, to develop the regulations and practices that could capture the benefits while minimizing the risks. That learning took time, and it cost lives, but it did eventually happen. The world we live in today, with its safety standards and warning labels and consumer protection agencies, was built in part on the lessons of the 1950s. Every regulation we now take for granted represents a problem that was once tragically unregulated. The people who died in polyurethane furniture fires were pioneers in a grim sense. They were the first to encounter a danger that the rest of us would eventually learn to avoid. Their deaths were not meaningless, even though they were preventable. They taught us something at terrible cost. Whether we fully learned that lesson is another question. New materials continue to enter the market every year. New products promise comfort, convenience, and modernity. Most of them are probably safe. Our regulatory systems are far better than they were in the 1950s. Our scientific understanding far more advanced. Our cultural awareness of risk far more developed. But the fundamental dynamic hasn't changed. Progress still generates risk. Innovation still creates hazards. And somewhere, probably, there is a product in your home right now that will seem just as strange and dangerous to your grandchildren as polyurethane sofas seem to us. That's not meant to frighten you, just to sit with quietly for a moment. The 1950s are not as distant as we sometimes imagine. The people who lived through that era are still among us, some of them bearing scars from chemistry, set explosions, or furniture fires, or the other hazards we'll discuss in time. Their children and grandchildren, which is to say many of us, grew up in homes that still contained some of these dangers, that still used some of these products, that were still shaped by the assumptions and blind spots of that transitional era. Understanding the 1950s isn't just an exercise in historical curiosity. It's a way of understanding ourselves, of recognizing the patterns that repeat across generations, of learning to see the risks that our own assumptions hide from us. The people of the 1950s weren't stupid. They were us, in different circumstances, with different information, making the best decisions they could. They deserve our understanding, not our condescension. And now the story turns toward the other product of the polymer revolution, one that turned ordinary children into human torches: synthetic clothing, and particularly the nightgowns and dresses that killed and maimed young girls with terrifying efficiency. The chemistry is similar to what we've already considered. Synthetic materials that burned hot and fast, that melted onto skin, that produced toxic smoke. But the victims were different, and the emotional weight of the tragedy was, if possible, even heavier. The story of synthetic clothing begins, like so much else in this era, with the technological innovations of the wartime period. Nylon, invented by DuPont in 1935, had been revolutionary from the start. The first truly synthetic fiber, created entirely from chemical compounds rather than processed from natural materials. Before the war, nylon had been used primarily for stockings, replacing expensive silk with something affordable, and crucially, American-made rather than imported from Japan. When war came, nylon production was diverted to military uses. Parachutes, rope, tire cords, anything that needed to be strong, light, and durable. After the war, nylon returned to the consumer market with enormous fanfare. Women queued for hours to buy nylon stockings, which had become almost mythical luxury items during the years of scarcity. But stockings were just the beginning. Manufacturers quickly realized that nylon and other synthetic fibers could be used for virtually any textile application. Shirts, dresses, underwear, curtains, upholstery. Anything made of cloth could potentially be made of synthetics, usually cheaper, and with properties that seemed almost magical to consumers accustomed to cotton and wool. The appeal of synthetic fabrics was genuine and substantial. They didn't shrink in the wash, a perpetual problem with natural fibers. They dried quickly, reducing the burden of laundry in an era before tumble dryers were common. They resisted wrinkles, maintaining a crisp appearance with minimal ironing. They came in vibrant colors that didn't fade, and they were cheap. For children's clothing in particular, synthetics seemed like a godsend. Children are notoriously hard on clothes. They grow out of things quickly. They stain everything. They tear fabric with an almost supernatural efficiency. Why spend money on expensive natural fiber garments that would be outgrown or destroyed within months when you could buy synthetics for a fraction of the price? Parents embraced synthetic children's clothing with enthusiasm, and manufacturers were happy to supply them. Nightwear was a particularly popular category. Synthetic nightgowns and pajamas could be produced cheaply in an endless variety of colors and patterns. They felt smooth against the skin, which children generally preferred to the rougher texture of cotton. They could be washed frequently without wearing out, and they looked lovely. Little girls in flowing synthetic nightgowns looked like something from a fairy tale, all soft pastels and delicate lace trim. Parents bought them by the millions. What those parents didn't know, and what the manufacturers either didn't know or didn't think important enough to mention, was that these beautiful garments were essentially wearable kindling. The synthetic fibers that made them so practical for everyday use also made them extraordinarily dangerous in the presence of open flame. And in 1950s Britain, open flames were everywhere. To understand this danger, we need to think about how British homes were heated in this era. Central heating, which we now take for granted, was essentially non-existent in ordinary British homes. A few wealthy families might have had it installed, but for the vast majority of the population, heating meant fireplaces. Coal fires in the living room, sometimes a smaller fire in the kitchen, perhaps a paraffin heater in the bedroom on particularly cold nights. These open flames were the heart of the home, sources of warmth and light around which family life revolved. The coal fire was not merely a heating appliance. It was a cultural institution. Families gathered around it in the evenings. Children did homework by its light. Meals were cooked on the range or in the oven that shared its chimney. The fire needed constant attention, feeding with coal, raking out ashes, adjusting the damper to control the burn. Someone in the household, usually the wife or mother, was responsible for maintaining it throughout the day. The first task each morning was relighting the fire. The last task each night was banking it to keep embers alive until morning. This intimate relationship with open flame meant that most people had developed a certain comfort with fire that might seem reckless by modern standards. Burns from accidental contact were common and generally treated as minor inconveniences rather than serious injuries. Children learned early which parts of the fireplace were hot and developed an instinctive sense of safe distances. Also, the theory went, in practice, familiarity bred a kind of contempt, not deliberate disregard, but a gradual lowering of vigilance that came from living with a hazard day after day. The economics of heating reinforced these patterns. Coal was not cheap, and many families rationed their use carefully. The fire would be lit in the morning, allowed to burn down during the day when the house might be empty, and built back up in the evening when the family gathered. During the coldest months, the fire might burn continuously. During milder weather, it would be intermittent. This meant that children's exposure to open flame varied seasonally, minimal in summer, constant in winter, and that fire safety habits might lapse during the warmer months and need to be relearned each autumn. Gas fires were becoming more common, particularly in newer homes. But these presented their own dangers, which we'll consider in time. For most families, the traditional coal fire remained the primary heat source. Children grew up around these fires, learned to respect them to some degree, but also became accustomed to their presence in a way that bred a certain familiarity. The fire was always there, always burning during the cold months, a fixture of daily life rather than a special hazard requiring constant vigilance. The architecture of British homes from this era exacerbated the danger. Living rooms were typically small, with the fireplace as the focal point. Furniture was arranged around the fire for maximum warmth, which meant people sat close to open flames as a matter of course. Children played on the floor near the hearth. The distance between a person and the fire might be only a few feet, close enough that a stumble, a moment of imbalance, could bring clothing into contact with flames. The layout of working-class homes was particularly problematic. Space was at a premium, and rooms served multiple functions. The living room might also be the dining room, the homework space, the play area, and the primary heated room in the house. Families gathered there because everywhere else was cold. Children couldn't be sent to their bedrooms because bedrooms were unheated and often bitterly cold in winter. The living room, with its fire, was where life happened, and where synthetic clothing came into closest proximity with open flame. The housing stock itself varied enormously. Victorian terraces built for a different era had fireplaces in multiple rooms, but were designed around the assumption that fires would be constantly tended by servants. Post-war council housing had modern conveniences, but often only a single fireplace in the main living area, concentrating family activities around that one heat source. The new estates being built in the 1950s sometimes featured more modern heating arrangements, but many still relied on coal fires, either because of cost considerations during construction or because that was simply what families expected. Draft was a constant enemy in these homes. The same chimneys that vented smoke from fires also created air currents that drew cold air in through every gap and crack. Families sat as close to the fire as they could stand, partly for warmth, but also to escape the cold drafts that flowed along floors and walls. This proximity to flame was not carelessness. It was a rational response to physical conditions. The choice wasn't between sitting safely far from the fire and sitting dangerously close. It was between being warm or being cold. Most families chose warm. Fire guards existed, of course. Metal screens that could be placed in front of the fire to prevent direct contact. But they were not universal, not legally required, and not always used even when available. Many families found them inconvenient, blocking the heat they were trying to enjoy. Others simply never got around to buying one. And fire guards that were adequate for preventing a coal from popping out of the grate were not necessarily adequate for preventing a child from falling against them and pushing through to the fire beyond. Now, the chemistry. Because the chemistry is central to understanding why these fires were so devastating. Natural fibers like cotton and wool, when exposed to fire, tend to char and smolder. They burn, certainly, but relatively slowly. And they don't melt. A cotton nightgown that caught fire would certainly injure its wearer, but the fabric itself wouldn't adhere to the skin. The fire could potentially be extinguished by dropping and rolling, by dousing with water, by smothering with a blanket. There was a margin for error, a window of time in which intervention was possible. The behavior of natural fibers in fire had been understood for centuries, simply because humans had been using these materials for so long. Wool in particular had remarkably good fire resistance. It required higher temperatures to ignite than cotton, burned slowly once lit, and tended to self-extinguish when the heat source was removed. This is why wool blankets were traditionally recommended for smothering fires. The material itself would not readily catch and spread the flames. Cotton was more flammable but still behaved predictably, charring rather than melting, burning at rates that allowed human reaction. The British textile industry had long experience with these materials and their fire properties. Fire safety in factories had been a concern since the Industrial Revolution, when crowded mills full of cotton dust had proven to be explosion and fire hazards. Regulations had been developed, precautions instituted, practices refined over generations. By the 1950s, the behavior of natural fibers in industrial settings was well understood and reasonably well controlled. But synthetic fibers were something entirely new. The industrial knowledge accumulated over centuries simply didn't apply. Each synthetic material had its own properties, its own ignition temperature, its own burning behavior, its own risks. And these properties had been studied primarily in laboratory settings, where scientists were interested in chemical reactions rather than practical safety implications. The question of what would happen when synthetic fabric caught fire on a human body had not apparently occurred to anyone until it started happening. Synthetic fibers behaved entirely differently from their natural counterparts. Nylon in particular had a relatively low melting point, around 220 degrees Celsius, which is easily reached by an open flame. When nylon fabric caught fire, it didn't just burn. It melted into a liquid that continued burning while flowing across any surface it touched, including human skin. The technical term for this behavior is drip ignition. The tendency of melting synthetic material to form burning droplets that fall and spread fire to surfaces below. In laboratory tests, scientists could observe this phenomenon with detached interest, noting the rate of drip formation, the temperature of the burning droplets, the distance they could travel before extinguishing. In a home with a child wearing the fabric, these same properties translated into something else entirely. Different synthetic materials exhibited different behaviors, none of them reassuring. Acetate, commonly used for linings and decorative elements, was even more flammable than nylon, igniting at lower temperatures and burning more readily. Rayon, technically a semi-synthetic made from plant cellulose, was more similar to cotton in some respects, but had been treated with chemicals that could make it highly flammable. Polyester, which would later become dominant in synthetic fabrics, had a higher melting point than nylon. But when it did melt, the liquid was even more viscous, adhering more persistently to surfaces it touched. The manufacturers of these fabrics knew their flammability characteristics. They had to, for industrial safety purposes, but this knowledge was not communicated to consumers. Product labels, such as they existed, mentioned fiber content for care purposes, whether to wash, whether to iron, but said nothing about fire behavior. Parents buying synthetic nightgowns for their children had no way to know that they were purchasing garments with radically different fire properties than the cotton or wool alternatives. The choice between fabrics was presented as purely a matter of preference, convenience, and cost. The implications of synthetic fabrics' fire behavior are difficult to sit with even now. A child whose cotton nightgown caught fire might suffer burns to whatever skin was directly exposed to flame. A child whose nylon nightgown caught fire would suffer burns wherever the melting fabric flowed, which could be virtually anywhere on the body. The liquid nylon would adhere to skin, continuing to burn even as the child or parents tried desperately to remove the garment. Pulling at the fabric would spread the burning liquid further. Dousing with water would do little good because the nylon itself was the fuel. The child's own movements, their panicked attempts to escape, would spread the destruction across their body. Medical professionals who treated these burns developed terminology for them. Drip burns and flow burns, describing the characteristic patterns left by liquid synthetic material running down the body. The burns typically followed gravity, creating vertical streaks of destruction down limbs and torsos. They were often deepest where the fabric pooled, in the creases of elbows and knees, in the groin, at the waist where garments gathered. The scarring these burns left behind was distinctive, immediately recognizable to any doctor who had seen them before. The gender disparity in these injuries was stark and disturbing. Girls were far more likely than boys to suffer serious burns from synthetic clothing. And the reason was simple: nightgowns. While both boys and girls wore synthetic pajamas, only girls typically wore nightgowns, long flowing garments that extended from shoulders to ankles, creating a maximum surface area of flammable fabric. These nightgowns were often loose-fitting and frilly, with ruffles and gathers that caught air and increased the garment's effective surface area. They were, in short, designed to be beautiful rather than safe. And beauty in this case was almost precisely opposed to safety. A girl in a flowing synthetic nightgown who got too close to a fire was essentially wearing a single large sheet of highly flammable material. When it ignited, there was nowhere for the flames to stop. The fire could spread from hem to neckline in seconds, engulfing the child in a cocoon of burning, melting synthetic material. Boys in fitted pajamas, while still at risk, at least had some natural fire breaks. The separate top and bottom, the tighter fit that limited air circulation, the shorter length of the pajama legs compared to a full-length nightgown. The numbers tell a grim story. Hospital burn units across Britain saw a significant increase in pediatric burn admissions through the 1950s, with synthetic fabric fires accounting for a growing proportion of cases. Precise statistics are difficult to establish because record-keeping varied between hospitals and categories of injury were not standardized. But the doctors and nurses who worked in these units knew what they were seeing. The same distinctive injuries week after week, year after year. The same heartbreaking cases of children whose bodies would be scarred for life, whose faces would never look the same, whose futures had been altered in seconds by a garment that should never have been made. Margaret Thorne was 7 years old in January 1956. She lived with her family in a terraced house in Manchester. It was a cold evening, and the family was gathered in the living room around the coal fire. Margaret was wearing a new nightgown, pink synthetic fabric with white lace trim, a Christmas present from her grandmother. Her mother thought she looked like a princess. At some point during that evening, Margaret moved too close to the fire. Perhaps she was reaching for something. Perhaps she stumbled. Perhaps she simply didn't realize how close she had gotten. And we can leave that sentence unfinished for a moment, because what came next is something the medical literature recorded in careful clinical language. And what that language describes is a child's life, changed in seconds by a garment her family had no reason to fear. There is something about a piece of fabric that we have never really stopped to think about. We handle it every day. We dress ourselves and our children in it without a second thought. It is so ordinary, so mundane, so entirely beneath notice. And yet, for a particular stretch of time, in a particular country, a particular kind of fabric became something far more dangerous than anyone had understood. This is the story of that fabric, and of the people who encountered it at its worst. You are standing in a small front room on a February morning in 1957. The fire in the grate is the warmest thing in the house. Everything smells of coal smoke and toast. Somewhere in the kitchen behind you, a woman is listening for the kettle. and a small child in a blue nightgown is standing very close to the flames, as children do, drawn by the warmth. She is 5 years old. Her name is Susan Walsh. She lives in Leeds. Her nightgown cost a few shillings at a market stall. The hem touches the fire. Her name was Susan Walsh, and she was 5 years old, and she was wearing a synthetic nightgown, blue, her favorite color, that her mother had bought from a market stall for a few shillings. When the hem caught fire, Susan panicked and ran, which fanned the flames and spread them faster. By the time her mother heard her screaming and reached her, Susan was almost completely engulfed. Susan survived. Third-degree burns covered her legs and lower torso. Second-degree burns extended to her arms and chest. Skin grafts were harvested from the few undamaged areas of her body. The healing process took over a year, during which she was in and out of hospital, enduring procedures that don't bear describing in too much detail at this hour, learning to live in a body that had been fundamentally transformed. She developed a lifelong fear of fire. Even the candles on a birthday cake became a source of terror for her. Susan's case was not unusual. It was documented, as several of these cases were, because it proved useful as a teaching example. The Birmingham Accident Hospital alone treated dozens of synthetic fabric burn cases annually through the late 1950s. London Hospital saw hundreds. The pattern was always the same. A child, usually a girl, usually in a nightgown, too close to an open fire. A moment of contact, and then catastrophe. There was Margaret, whose case the source material does not give an age for, but whose story begins earlier, at the very beginning of this account. The hem of her nightgown touched the flames. Her father reacted immediately. He was at her side perhaps 2 seconds later. The flames had already spread up her body. He tried to smother the fire with his hands, sustaining burns himself. Her mother ran for water. The neighbors heard screaming and came to help. Margaret survived, which already placed her among the fortunate. She spent 4 months in hospital. She underwent multiple skin grafts. She bore scars across more than 40% of her body for the rest of her life. Her face was largely spared, which was one of the few mercies in an otherwise merciless story. The psychological trauma for Margaret, for her parents, for her siblings who had watched it happen, is impossible to quantify. But it was undoubtedly severe. There was also Patricia Edwards, 8 years old, from Bristol. Her case was documented in December 1958, and what made it notable was what it revealed about the sheer speed of these fires. Patricia's father was a former soldier. He had, by his own account, trained himself to react before he consciously registered what was happening. When Patricia's nightgown caught fire during a family evening, he was moving before he understood why. And still, Patricia sustained burns to nearly 30% of her body. Her father burned his hands, so badly attempting to extinguish the flames that he couldn't work for months. He later told investigators that the nightgown seemed to have turned into fire the moment it touched the flames, as if the fabric itself were made of compressed flame waiting to be released. That phrase has stayed with me, compressed flame waiting to be released. It is such an accurate description of what these fabrics were doing, and no one had told anyone. The medical establishment, to its credit, began to recognize synthetic fabric burns as a distinct category of injury requiring specialized treatment. This was not merely a clinical observation. It had practical and immediate consequences because the standard assumptions about treating burns turned out to be dangerous when applied to synthetic materials. Traditional burn care assumed that removing clothing from a burn victim would stop the burning process. With synthetic fabrics, this assumption could cause serious additional harm. Pulling at melted synthetic material could tear away skin that had fused with the fabric, dramatically worsening the injury. Burn units developed new protocols. Cool water first to stop the burning, careful assessment of fabric adhesion, surgical removal of fused material rather than manual pulling. Dr. Harold Ashworth, a burns specialist at Manchester Royal Infirmary, published a series of papers in the late 1950s documenting the distinctive characteristics of these injuries. He described what he called the distribution pattern, the way burns typically concentrated in areas where fabric had pooled and melted. He described the severity gradient, the tendency for burns to be deepest where contact with melting fabric had been most prolonged. His work helped other physicians recognize and treat these injuries. It also served to document, in clinical terms, the human cost of a regulatory failure. The response to this crisis, when it finally came, took several forms. Public health campaigns were launched, educating parents about the dangers of synthetic clothing near open flames. These campaigns often specifically targeted nightgowns, encouraging parents to dress their daughters in close-fitting pajamas instead of flowing gowns. The messaging was direct, sometimes graphic. Images of burned children were used to drive home the point that clothing choices had consequences. This campaign, sometimes referred to simply as the pajama campaign, was controversial. Some parents resented being told how to dress their children. Others argued that the problem was open fires, not clothing, and that resources should be directed toward fire safety rather than wardrobe changes. The synthetic fiber industry pushed back, pointing out that cotton nightgowns could also catch fire. This was technically true, but it missed the point entirely. Cotton nightgowns didn't melt onto skin. Cotton nightgowns didn't continue burning after the flame source was removed. The argument was accurate in the narrowest sense and almost entirely beside the point. Fireguard legislation represented another approach. If children couldn't be kept away from fires, and if parents couldn't be convinced to dress them in safer clothing, then perhaps the fires themselves could be made less accessible. The Children and Young Persons Act of 1952 had already made it an offense to leave a child under 12 alone in a room with an unguarded fire. But enforcement was uneven at best. Many parents either didn't know about the requirement or didn't take it seriously. Regulations requiring fireguards in homes with young children were discussed, debated, and eventually partially implemented. The practical challenges were substantial. How would authorities know whether a home contained children? How would they know whether a fireguard was in use? Police and social workers could hardly go door to door inspecting living rooms. The law relied primarily on deterrent effect and voluntary compliance, neither of which proved particularly effective. Some local authorities took more direct approaches. Health visitors, who routinely called on homes with young children, were instructed to check for fireguards and to report their absence. Social workers dealing with families for other reasons made note of fire safety issues. Schools sent letters home to parents. Posters appeared in clinics, in shops, on public transport. Guard your fire, guard your child. The messaging was persistent. It was not always effective. The design of fireguards became a subject of debate in itself. Traditional guards were simple wire mesh screens that sat in front of the fire. These guards could be pushed over, climbed on, or reached around. Some children had been burned not by falling into fires, but by reaching through or over guards to retrieve toys or simply to feel the warmth. More secure designs were developed. Floor-mounted frames that couldn't easily be moved. Screens with finer mesh that wouldn't allow small hands through. But these were more expensive and less commonly purchased. The cheapest option remained the most common one. The architectural solution to all of this, the elimination of open fires entirely, was already underway, though for reasons having nothing to do with children's clothing. The Clean Air Acts of 1956 and 1968 were responses to the deadly smogs that had plagued British cities, not to nightgown fires, but their effect was to accelerate the transition away from coal fires and toward central heating, smokeless fuel, gas, and electric fires. These alternatives were, incidentally, far less likely to cause the catastrophic clothing fires that open coal fires had enabled. The very danger that had been present for generations was being removed. But being removed for entirely other reasons. The real solution ultimately was a combination of regulatory change and industry adaptation. Fire retardant treatments for fabrics were developed and gradually became standard for children's sleepwear. These treatments didn't make fabric fireproof, but they dramatically slowed ignition and flame spread, buying crucial seconds in which a fire could be extinguished before becoming catastrophic. Standards for children's nightwear flammability were established, with garments required to meet specific criteria before they could be sold. The development of effective fire retardants was itself a significant chemical undertaking. Early treatments were problematic in various ways. They washed out after a few laundry cycles. They changed the texture of fabric unpleasantly. They sometimes caused skin irritation. Some treatments proved to be toxic in their own right, introducing new health concerns even as they addressed fire safety. The chemical industry worked through multiple generations of fire retardant formulations, each improving on its predecessors while introducing new trade-offs. The testing protocols for fire-resistant fabrics became increasingly sophisticated over time. Early tests were crude, essentially setting fabric samples on fire and observing what happened. These gave way to standardized procedures that measured ignition time, flame spread rate, afterglow duration, and other relevant parameters. Laboratories specializing in textile fire testing emerged, and their certifications became important commercial assets for manufacturers who could demonstrate compliance. The British Standards Institution played a crucial role in establishing these standards, working with manufacturers, safety researchers, and government agencies to develop requirements that were both effective and practical. The process was contentious. Manufacturers complained about the costs of compliance. Safety advocates argued that the standards didn't go far enough. The resulting regulations represented compromise, as regulations usually do. Not perfect protection, but substantial improvement over what had come before. The transformation of the children's sleepwear market was visible in any department store by the mid-1970s. The flowing synthetic nightgowns that had been so popular in the 1950s had essentially disappeared, replaced by close-fitting pajamas and nightshirts made from treated fabrics. The aesthetic had changed along with the materials. Safety-compliant sleepwear looked different, felt different, served different cultural functions. Little girls no longer looked like fairy-tale princesses at bedtime, but they also no longer risked becoming human torches. These changes didn't happen overnight. The transition from unregulated to regulated children's sleepwear took more than a decade, during which preventable injuries continued to occur. The pace of change was determined by the usual factors: industry resistance to increased costs, political reluctance to impose new requirements, scientific debate about which standards were appropriate, simple bureaucratic inertia. Each year of delay meant more burned children, more scarred bodies, more families whose lives were transformed by a moment's contact between synthetic fabric and open flame. The transformation of British heating played a role in reducing these injuries as well, though it happened for reasons entirely unrelated to fabric fire safety. Central heating became more common through the 1960s and 1970s, replacing open fires with radiators that pose no ignition risk. Electric heaters, while they had their own dangers, didn't produce open flames. Gas fires with enclosed elements became standard, eliminating the exposed flames of earlier models. The very heat sources that had made synthetic clothing so dangerous were slowly being replaced with alternatives that didn't require constant vigilance around flammable materials. By the late 1980s, when modern fire safety standards were fully in place, the combination of safer fabrics, safer heating, and safer furniture had dramatically reduced the rate of domestic fire deaths and injuries. Children's sleepwear fires, once a leading cause of pediatric burns, became relatively rare. The flowing synthetic nightgown, that beautiful and deadly garment of the 1950s, essentially disappeared from the market, replaced by close-fitting, fire-resistant alternatives that prioritized safety over aesthetics. But the transition period had taken its toll. Thousands of children had been burned. Hundreds had died. Countless families had been marked by trauma that would persist for generations. These were the casualties of an era that hadn't yet learned to think systematically about product safety. An era that had introduced new materials without fully understanding their properties. An era that had prioritized convenience and cost over the protection of its most vulnerable members. I find myself thinking about something in all of this, something that doesn't quite fit into the official account. The children who died from synthetic clothing fires did not die to teach us a lesson. They died because adults failed to protect them, because systems failed to anticipate dangers, because the drive for profit and convenience outweighed concern for safety. Their deaths were tragedies, not sacrifices. We honor them best not by finding meaning in their suffering, but by working to ensure that similar suffering doesn't recur. The synthetic clothing fires of the 1950s also revealed something important about the distribution of risk in society. These fires disproportionately affected working-class families. Wealthier homes were more likely to have fire guards, more likely to have central heating, more likely to purchase higher-quality garments, often made from natural fibers. The cheap synthetic nightgowns that became death traps were marketed specifically to families who couldn't afford better. The democratization of fabric, like the democratization of furniture, came with hidden costs that fell heaviest on those least able to bear them. The gender dimension was equally significant. Girls died and were maimed in far greater numbers than boys, not because of any inherent vulnerability in the female body, but because of cultural choices about how children should be dressed. Flowing nightgowns were considered appropriate, even necessary, for respectable young girls. Boys could wear practical, close-fitting pajamas. Girls were expected to look pretty, even at bedtime. This gendered expectation, seemingly trivial, had life or death consequences once synthetic fabrics entered the picture. The nightgown wasn't dangerous because of anything inherent to female bodies. It was dangerous because society had decided that girls should wear a particular style of garment, and that garment happened to be especially hazardous when made from the new synthetic materials. The decision to dress daughters differently from sons, made for reasons having nothing to do with safety, turned out to have enormous safety implications once the material environment changed. This pattern recurs throughout the history we are moving through together. Social norms interacting with technological change to produce unexpected dangers. The 1950s home was shaped by countless assumptions about how people should live, how families should be organized, how men and women and children should behave. These assumptions were rarely examined, rarely questioned, simply taken for granted as the natural order of things. When new technologies entered this environment, they interacted with existing patterns in ways that no one had anticipated, revealing dangers that had been hidden within the social fabric all along. The open fire itself was an example of this. Fires had been central to British domestic life for centuries. Countless generations had grown up around them without incident, or at least without incidents frequent enough to prompt systematic change. The introduction of synthetic fabrics transformed this familiar fixture into a much more serious hazard, not because the fires themselves had changed, but because the materials surrounding them had changed. The danger was in the interaction, not in any single element. Understanding this helps explain something that might otherwise seem contradictory about the 1950s. Life expectancy was increasing. Infant mortality was declining. Diseases that had killed millions were being controlled or eliminated. In aggregate, Britain was becoming safer. But within individual homes, new dangers were being introduced faster than old ones were being eliminated. The overall statistics masked a complex reality in which certain risks were increasing even as others fell. Medical professionals of the era documented this pattern with growing concern. Hospital burn units, which had expected their caseloads to decline as public health improved, instead found themselves busier than ever. The burns they were treating were different from those of previous generations, more severe, more extensive, more likely to involve synthetic materials. They published papers, raised alarms, called for action. But translating medical observation into policy change was slow, difficult work, requiring the coordination of multiple institutions and the overcoming of significant resistance. The story of the nightgown fire campaigns illustrates both the possibilities and the limitations of public health intervention in this era. On one hand, determined professionals were able to identify a problem, gather evidence, and advocate for change. Their efforts saved lives, even if they couldn't save everyone. On the other hand, the pace of change was agonizingly slow, constrained by industry resistance, political indifference, and the sheer difficulty of changing established patterns of behavior. Parents who had always dressed their daughters in nightgowns didn't want to be told they were endangering their children. Manufacturers who had invested in synthetic fabric production didn't want to be blamed for injuries. Politicians who depended on both constituencies didn't want to take sides. The resolution of this conflict came through regulation rather than persuasion. When voluntary change proved insufficient, mandatory standards were eventually imposed. The market, left to itself, had not produced safe products. Consumers, left to themselves, had not made safe choices. Government intervention was necessary to break the cycle, forcing manufacturers to produce safer goods, and in turn giving consumers access to those safer goods. This was the lesson of the synthetic clothing fires, as it was the lesson of the chemistry sets and the polyurethane furniture. Markets alone do not produce safety. This lesson remains relevant today, though we sometimes forget it. Every few years, a new product category generates a new set of safety concerns, and the same debates recur. Industry argues that regulation will stifle innovation and raise costs. Consumer advocates argue that safety must take priority. Politicians triangulate, trying to satisfy everyone and often satisfying no one. The specific products change. Today, we might be talking about e-cigarettes, or autonomous vehicles, or artificial intelligence. But the underlying dynamics remain remarkably consistent. The children who were burned by synthetic nightgowns in the 1950s are now, if they survived, in their 70s and 80s. Many bear visible scars. All bear invisible ones. Their experiences helped shape the regulatory framework that protects children today, though they may never have known it. Each injury, each death, each family's tragedy became part of the evidence base that eventually forced change. The suffering was not meaningless, even though it was preventable. The transition from dangerous to safe children's sleepwear took approximately 30 years. From the first synthetic nightgowns in the late 1940s to the comprehensive flammability standards of the late 1970s. 30 years during which countless children were burned and some died. Each year of delay in implementing safety standards meant more victims. Whether the pace of change was acceptable, whether it could have been faster, whether the costs of delay were worth the benefits of caution, remains contested. What seems clear is that the system was not optimized for protecting children. Other considerations, economic, political, ideological, took precedence. Synthetic fabrics should have been tested for flammability before being marketed for children's clothing. When the dangers became apparent, mandatory standards should have been implemented immediately. The regulatory framework that we now take for granted should have existed from the beginning. But this is the wisdom of hindsight, available to us only because generations before us learned these lessons the hard way. The 1950s home, as we are discovering together, was a place where learning the hard way was standard practice. Chemistry sets taught children about chemical reactions by occasionally burning or poisoning them. Furniture taught families about fire safety by occasionally incinerating them. Clothing taught children about synthetic materials by occasionally melting onto their skin. Each lesson was paid for in blood and pain and grief, and each lesson eventually led to improvements that protected future generations. This was progress of a particularly brutal kind, purchased at a price that seems, from our comfortable present, almost inconceivably high. And now, having spent this time in the living room with its open fires and its flowing nightgowns, it is time to move toward another corner of that same room, another piece of furniture, another piece of technology that arrived in British homes through the 1950s and settled in as if it belonged there. The television set. Before the war, television had been a curiosity, a technological marvel demonstrated at exhibitions and owned by a tiny handful of wealthy enthusiasts. The BBC had begun regular television broadcasts in 1936, but the audience was measured in thousands rather than millions, and the outbreak of war had shut down the service entirely. When broadcasting resumed in 1946, television was still a novelty. Expensive, unreliable, offering only a few hours of programming per day. And then came the coronation. The coronation of Queen Elizabeth II in June 1953 was the event that transformed television from a luxury into a necessity. For the first time, a great national occasion would be broadcast live into people's homes. The BBC estimated that 20 million people watched the ceremony, an astonishing number given that fewer than 2 million households actually owned television sets at the time. Neighbors crowded into the homes of set owners. Pubs installed televisions and packed in customers. Shops displayed sets in their windows with crowds gathered on the pavement outside, watching in the cold. The coronation demonstrated, more powerfully than any advertising campaign could have, what television could do. The result was a buying frenzy. Television ownership doubled in 1953 and continued growing exponentially through the rest of the decade. By 1956, more than half of British households had a television. By 1960, the figure was approaching 80%. The television set, which had been a mark of affluence and modernity just a few years earlier, was now standard equipment in working-class homes across the country. Families who could barely afford it were buying sets on hire purchase, making weekly payments for years to own what had become an essential piece of furniture. The industry struggled to keep up with demand. Established manufacturers expanded production as quickly as they could. New companies entered the market, some with solid engineering backgrounds, others with more enthusiasm than expertise. Components were in short supply, and manufacturers made do with whatever they could source. Quality control, never particularly stringent to begin with, became even more lax as factories pushed to meet quotas. The priority was getting sets into shops, not ensuring those sets were safe. The television fires that plagued British homes through the 1950s and 1960s were not primarily the result of defective individual units, though those certainly existed. They were the result of systemic problems in how sets were designed, manufactured, and used. The technology itself was inherently prone to generating heat, and the industry had not yet figured out how to manage that heat safely in a domestic environment. A 1950s television was built around a cathode ray tube, a vacuum tube that generated images by firing electron beams at a phosphorescent screen. These tubes required enormous voltages to operate, typically around 15 to 20,000 volts. The power supply needed to generate these voltages produced substantial heat. The tube itself produced heat. The various amplifiers and oscillators that processed the signal produced heat. A working television set was, essentially, a sophisticated heater that happened to also display pictures. Modern electronics manage heat through carefully designed ventilation systems, heat sinks, and thermal cutoffs that shut down the device if temperatures become dangerous. The televisions of the 1950s had none of these features, or had them only in the most rudimentary form. Ventilation was typically just a few holes in the cabinet, often placed more for aesthetic reasons than for thermal management. Heat sinks were rare, and when present, often inadequate. Thermal cutoffs were essentially non-existent in consumer equipment. The sets were designed to work, not to fail safely. The cabinets themselves contributed to the problem. Television sets of this era were pieces of furniture as much as electronic devices, housed in wooden cabinets designed to complement the living room decor. These cabinets looked lovely, but wood is an excellent insulator, which meant that heat generated inside the cabinet tended to stay inside the cabinet. The backs of the cabinets were typically solid or nearly solid, trapping warm air rather than allowing it to circulate. Some manufacturers added ventilation slots, but these were often too small or poorly positioned to provide adequate cooling. The placement of televisions in British homes made things worse. Families naturally wanted their televisions to be the focal point of their living rooms, which typically meant placing them against a wall or in a corner. These locations restricted airflow around the cabinet, further impeding cooling. Some families, concerned about dust getting into the cabinet through ventilation holes, covered these holes with cloth or tape. Manufacturers should have warned against this. Often they didn't. The result was sets running hotter than their designers had intended, in locations that prevented the heat from dissipating. The fire mechanism was straightforward. As components inside the television heated up during operation, the temperature of the entire unit gradually increased. If ventilation was inadequate, because of cabinet design, placement, or user modification, the temperature could rise to dangerous levels. The insulation on wires would begin to degrade. Soldered joints would soften. Capacitors, which stored electrical charge, would begin to break down. Eventually, something would fail. A wire would short. A capacitor would burst. A component would catch fire. And the television would begin to burn. The fires typically started, and here the source material continues. The smell comes first. Something sharp and acrid, almost chemical, threading through the warm domestic air of an ordinary evening. A family on a sofa, the blue-white flicker of a television screen throwing soft light across their faces. Someone mentions it. Someone else suggests it might be the kitchen. And for a few minutes, life continues. The smell is coming from inside the television cabinet, from the components running hot in the dark, from insulation beginning to char around them. The fire, when it starts, is invisible to anyone watching the screen. Early signs were easy to miss or misread. A strange smell, that distinctive acrid quality of burning insulation. A slight flickering of the picture, which might just as easily be attributed to the general unreliability of early television technology. Families absorbed in their programs often didn't notice these warnings at all. And by the time smoke began to emerge from the cabinet, or small flames became visible through the ventilation holes, the fire was often already well established. What happened next depended almost entirely on timing and proximity. If someone was watching when the fire started, and if they acted immediately, the damage might be limited to the television itself and perhaps some scorching of the wall behind it. But if the television had been left running while the family was in another room, a common practice when switching between programs, the idea being to keep the tubes warm, or if the fire began during the night, the results could be catastrophic. A burning television could ignite curtains, walls, furniture, and spread through an entire house before anyone understood what was happening. The statistics from this period are difficult to interpret with precision. Fire reporting was inconsistent, and cause determination was often imprecise. But fire investigators who worked through the 1950s consistently reported that television fires represented a significant and growing problem. One estimate suggested that by the late 1950s, television fires were responsible for several hundred house fires annually in Britain, with dozens of deaths and hundreds of injuries. Those numbers may seem modest alongside other fire causes, but they represented something new, a category of risk that simply hadn't existed a decade earlier, and that was growing steadily larger as television ownership expanded. There is something quietly unsettling about that. A whole new way for a home to catch fire, arriving in a polished wooden cabinet, welcomed through the front door and given a place of honor in the living room. The Henderson family of Nottingham had one of those cabinets. Ronald Henderson had purchased a television set in late 1954, one of the newer models from a well-known manufacturer. The family was proud of their acquisition. It made them the envy of their neighbors, several of whom would come over on weekend evenings to watch popular programs. For nearly 2 years, the set worked well, providing entertainment and a connection to the wider world that the Hendersons had never quite experienced before. In September 1956, on an ordinary Tuesday evening, the family was watching a variety program when Ronald noticed an unusual smell. He mentioned it to his wife, Edith, who suggested it might be something burning in the kitchen. Ronald went to check, found nothing, and returned to the living room. The smell had grown stronger. He walked over to the television, bent down to look at the back of the cabinet, and saw smoke beginning to emerge from the ventilation slots. What followed demonstrated both the speed of television fires and the inadequacy of most families' preparation for them. Ronald unplugged the set, which was the right first instinct, but the fire inside the cabinet had already ignited the wooden casing. He tried to carry the burning television outside. It was heavy, awkward, and increasingly hot. He dropped it in the hallway. The carpet caught. Edith grabbed the children and ran for the front door. By the time the fire brigade arrived, the entire ground floor was engulfed. The Hendersons escaped with their lives. Their home was destroyed. The subsequent investigation found that a capacitor inside the television had failed, probably due to prolonged overheating, and had ignited nearby components. The fire had spread to the wooden cabinet, then to the wall, then through the house. Fire investigators recognized the pattern immediately. They had seen variations of it dozens of times. The television had been well maintained, properly used according to the standards of the time, and had still managed to burn down a house. Cases like the Hendersons accumulated through the late 1950s, gradually building pressure for some kind of response. The manufacturers were naturally reluctant to acknowledge any systematic problem with their products. They pointed instead to user error, improper placement, blocked ventilation, failure to have the set serviced regularly, rather than design defects. Some manufacturers did improve their designs, adding better ventilation, more robust components, and clearer instructions for safe use. But these improvements were voluntary and inconsistent. The retailers who sold televisions were in a difficult position. Their customers wanted sets, and wanted them now. Raising concerns about fire safety might discourage sales, might suggest that the retailer was offering dangerous products, might even invite legal liability. Most retailers said nothing about fire risks, assuming that manufacturers had already taken care of such matters. That assumption was, unfortunately, optimistic. The insurance industry was among the first to recognize the pattern clearly. Insurance companies tracked claims carefully, and television fires showed up plainly in their data. Some companies began asking about television ownership on application forms, adjusting premiums accordingly, or including specific exclusions for television-related damage. But these adjustments happened quietly, without public announcement, and did nothing to inform the consumers who were actually living with the risk. The government's response was characteristically slow. The Radioactive Substances Act of 1948 had established some regulatory framework for electronic equipment, but television safety had not been a priority within it. General electrical safety standards existed, but specific requirements for television design were lacking. The assumption had been that manufacturers would ensure their products were safe. an assumption that proved difficult to sustain against competitive pressure to cut costs and rush products to market. The turning point came, as turning points so often do, with an incident too painful to ignore. In March 1958, a television fire in a semi-detached house in Bradford killed 3 children who had been sleeping upstairs while their parents were out for the evening. The babysitter, a teenage girl, had noticed the fire too late and had been unable to reach the children through the smoke-filled stairway. The story made national news, prompted questions in Parliament, and produced demands for action. The result was the development of British Standard 415, which established specific safety requirements for television design. The standard addressed electrical insulation, component spacing, ventilation requirements, and the fire resistance of cabinet materials. Manufacturers were required to test their designs against specific criteria and to mark compliant products with appropriate certifications. The standard was voluntary at first, but retailers increasingly refused to stock non-compliant sets, and government pressure encouraged eventual mandatory adoption. Implementation did not happen overnight. Manufacturers needed time to redesign products, retool factories, and work through existing inventory. Some smaller manufacturers, unable to afford the necessary changes, simply went out of business. The television market consolidated around larger, better capitalized companies that could meet the new requirements. By the early 1960s, the worst of the television fire crisis had passed, though incidents continued to occur as older, pre-standard sets remained in use. The pattern by now will feel familiar. A new technology introduced without adequate understanding of its risks. Market pressure driving rapid expansion without corresponding attention to safety. Regulatory frameworks lagging behind technological development. The burden of risk falling on ordinary consumers who had no way to evaluate what they were buying. And change arriving only after enough people had died to make the problem impossible to ignore. But television fires were only one of the hazards that came with the new technology. The do-it-yourself culture that television helped promote would create its own category of dangers. And the amateur electrical work that many homeowners attempted, inspired by confidence from simpler projects, would prove even more dangerous than the professionally manufactured sets they were trying to accommodate. The 1950s home was becoming increasingly electrified, and the consequences of that electrification were only beginning to be understood. And so we come to the do-it-yourself revolution, which sounds on the surface entirely positive, and in many ways it was. But it was also, quietly and persistently, a revolution in new ways to get hurt. The DIY movement emerged from a confluence of factors unique to post-war Britain. Housing was in short supply, with millions of homes destroyed or damaged during the war and a baby boom creating further demand. The homes that did exist were often in poor condition, having suffered years of neglected maintenance while resources went to the war effort. Professional tradespeople were scarce and expensive, their ranks depleted by wartime casualties, and their services in high demand for reconstruction. For many homeowners, the choice was stark. Either do the work yourself or live with crumbling plaster, leaking roofs, and outdated facilities. At the same time, a cultural shift was underway that celebrated self-reliance and practical skill. The war had taught people, men and women alike, that they were capable of things they'd never imagined attempting. Women who had worked in factories, operated machinery, and kept households functioning through years of shortage weren't about to be told they couldn't hang wallpaper. Men who had served in the forces, learning everything from vehicle maintenance to basic construction, came home with skills they were eager to apply. The can-do spirit of the war years translated naturally into a can-do approach to home improvement. The media enthusiastically promoted this new enthusiasm. Magazine titles like Practical Householder, Do It Yourself, and Handyman proliferated, offering instructions for everything from building garden sheds to rewiring houses. Television programs demonstrated projects that viewers could attempt at home, with cheerful presenters making complex tasks look simple. These publications and programs provided genuinely useful information. But they also created expectations that sometimes exceeded reality. Watching a professional complete a task in a neatly edited segment was not the same as doing it yourself in a cluttered garage, with tools you barely knew how to use. The retail sector responded with enthusiasm. Hardware shops that had once catered primarily to trade customers now marketed directly to homeowners. New chains emerged dedicated entirely to the DIY market, offering tools, materials, and advice to amateur improvers. Power tools, which had previously been the province of professionals, became available in consumer-friendly versions, lighter, cheaper, and marketed with images of satisfied homeowners transforming their properties. All of this was, in principle, empowering. People who could improve their own homes saved money, gained skills, and took genuine pride in their accomplishments. The DIY movement helped millions of families create more comfortable living spaces than they could otherwise have afforded. It contributed to the general improvement in housing quality that characterized the post-war decades. But it also introduced new hazards into homes that had quite enough hazards already. You are standing at the foot of a ladder on a cold autumn Saturday. The gutters above need clearing before winter. The ladder is borrowed. The ground beneath it is slightly uneven, though you haven't quite noticed that yet. The leaves up there are heavy and wet, and the far end of the gutter looks worse than the near end. You begin to climb. If there is one piece of equipment that captures both the promise and the peril of the DIY movement, it is the humble ladder. Ladders had existed for millennia, and people had been falling off them for just as long. But the DIY revolution dramatically expanded the population of people using ladders for tasks that, in previous generations, would have been left to professionals. Gutters needed cleaning, roofs needed inspecting, high windows needed painting, trees needed pruning. All of these tasks required ladders. All of them offered opportunities for serious injury. The physics of ladder accidents is straightforward but merciless. A person standing at the top of a 12-foot ladder carries the potential energy of a 12-foot fall onto whatever lies below. At that height, landing on concrete, the most common surface around British homes, can easily cause broken bones, head injuries, or death. The elderly, whose bones are more brittle and whose reflexes are slower, are particularly vulnerable. But even young, fit adults can be seriously hurt by ladder falls, especially if they land awkwardly or strike obstacles on the way down. The statistics from the era suggest that ladder falls were among the most common sources of DIY injuries. Hospital accident departments saw a steady stream of patients who had been performing home improvements when they fell, with injuries ranging from minor bruises to fatal skull fractures. The pattern was consistent. Someone decided to tackle a task that required working at height, set up a ladder without adequate precautions, lost their balance or had the ladder slip, and fell. The variations were endless. Wet rungs, unstable ground, reaching too far, carrying too much, but the destination was always the same. Consider William Potter of Leicester, a 53-year-old factory supervisor who decided, one autumn Saturday in 1957, to clean his gutters before winter set in. He had borrowed a ladder from a neighbor, set it up against the side of his house, and climbed up to begin clearing leaves and debris. Everything went reasonably well until he reached the far end of the gutter, where accumulated debris had created a stubborn blockage. What happened next was reconstructed from witness statements and physical evidence. William, finding that he couldn't quite reach the blockage from his current position, decided to lean further rather than climb down and reposition the ladder. This is the cardinal sin of ladder work, the mistake that injures and kills more people than any other. The shift in weight caused the ladder to slide sideways along the wall. William grabbed for the gutter, which pulled away from the fascia board. He fell approximately 14 feet onto the concrete path that ran along the side of the house. His wife heard the noise and found him lying unconscious on the path, bleeding from a head wound. The ambulance took 20 minutes to arrive, which was not unusual for the era. William was pronounced dead at the hospital 3 hours later from a fractured skull and internal bleeding. His funeral was held the following Wednesday. His gutters were eventually cleaned by a professional roofer who charged the widow £3 for the service. That detail stays with me. £3. The cost of the job that William had been trying to avoid paying for, set against everything that followed. William Potter's death was not unusual. Variations of his story played out across Britain every weekend as enthusiastic homeowners tackled projects beyond their skill level or their equipment's capacity. The DIY magazines rarely mentioned such dangers, focusing instead on the satisfaction of completed projects. The hardware stores selling ladders didn't offer safety training. The cultural assumption was that adults could assess risks and make reasonable decisions, an assumption that proved tragically optimistic when applied to working at height. Beyond ladders, the DIY movement introduced people to power tools capable of causing serious injury far more quickly than their hand-powered predecessors. The electric drill in particular became a symbol of the amateur handyman and a source of numerous accidents. Early consumer drills were not the sophisticated, safety-featured tools familiar today. They lacked the clutches that stop a bit from spinning if it binds. They lacked guards that prevent accidental contact with spinning parts. They lacked the ergonomic designs that reduce fatigue and improve control. What they had was power, the ability to drive holes through wood, metal, and masonry with unprecedented speed. The injuries associated with electric drills ranged from minor cuts and abrasions to severed tendons, broken bones, and worse. A drill bit that caught and spun in material could wrench the tool violently from a user's hands, potentially striking them or anyone nearby. A drill bit that broke could send metal fragments flying. A drill used on electrical wiring, whether intentionally or by accident, could deliver a fatal shock. And a drill pressed against skin, even briefly, could cause serious lacerations. The contact adhesives that became popular for DIY projects in the 1950s presented a different kind of danger. Products sold under brand names like Avostic and Bostic were remarkably effective at bonding materials together. So effective, in fact, that they would also bond skin to skin, or skin to other surfaces, with potentially serious consequences. The solvents in these adhesives were volatile and flammable, creating explosion risks in poorly ventilated spaces. And the fumes, if inhaled in quantity, could cause dizziness, nausea, and impaired judgment, which were not ideal conditions for operating power tools or climbing ladders. The instructions on these products were typically inadequate, assuming a level of chemical knowledge that most users simply didn't possess. Using well-ventilated areas doesn't convey the same urgency as these fumes can make you pass out, and the vapors can explode if they contact a spark. Avoid contact with skin doesn't quite communicate that if you glue your fingers together, you may need surgery to separate them. The language of warning labels had not yet evolved to match the dangers of the products they described. But the most serious DIY danger of the 1950s was amateur electrical work. As British homes became increasingly electrified, adding outlets for televisions, power points for new appliances, lighting for rooms that had previously relied on gas or candles, homeowners increasingly decided to do this work themselves rather than pay for a qualified electrician. The results were sometimes comic. They were sometimes tragic, and they were almost always dangerous. Electrical work is uniquely hazardous among home improvement tasks because the dangers are entirely invisible. You can see a ladder wobble before it falls. You can feel a drill beginning to slip. But you cannot see electricity flowing through a wire, cannot detect the presence of a live circuit until it's already too late. The consequences of electrical mistakes range from minor shocks to fatal electrocution to house fires that destroy everything. And unlike most other DIY tasks, where a mistake is usually immediately apparent, electrical problems can lurk undetected for years before manifesting in the worst possible way. The fundamentals of electrical safety were not widely understood by the British public in the 1950s. Many people knew that electricity was dangerous in some vague sense, but didn't understand exactly why or how. The concept of grounding, connecting electrical systems to Earth to provide a safe path for fault currents, was poorly understood. The importance of proper wire sizing, circuit breakers, and fuse ratings was unknown to most homeowners. The techniques required for safe electrical connections, proper stripping, tight connections, appropriate insulation, were not part of general knowledge. Armed with ignorance and good intentions, homeowners tackled electrical projects that would make any qualified electrician weep. They ran wires without protecting them from physical damage. They made connections using tape instead of proper junction boxes. They mixed wire sizes without regard for load capacity. They bypassed fuse boxes they considered inconvenient. They assumed that because something worked when they finished, it was therefore safe, not understanding that electrical failures often developed gradually, the result of heating and deterioration that takes months or years to become visible. The case of Arthur Simmons of Bristol illustrates the pattern. Arthur was a maintenance worker at a local factory, someone who dealt with machinery every day and considered himself reasonably competent with technical matters. When his family acquired a television in 1955, he decided to install an additional power outlet rather than run an extension cord across the living room. He bought wire, a socket, and a faceplate from the local hardware shop, watched a neighbor who had done similar work, and proceeded to wire up the outlet himself. Arthur made several mistakes, each of which seemed minor at the time, but which combined to create a dangerous situation. He used wire that was too thin for the potential load. He didn't secure the connection to the existing circuit properly, leaving a loose joint that would gradually work free. He failed to ground the outlet, meaning that any fault would have no safe path to Earth. And he didn't notify the electricity board of his modification, which meant no inspector would ever check his work. For 3 years, nothing happened. The outlet worked fine, powering the television and occasionally a lamp or radio. Arthur congratulated himself on saving the money an electrician would have charged. Then, one evening in February 1958, the loose connection finally worked free enough to start arcing, creating tiny electrical discharges that generated intense heat in a confined space. The heat ignited the wooden wall behind the outlet. The fire spread into the wall cavity, invisible, until smoke began emerging from gaps around the skirting board. The Simmons family escaped the fire, which was fortunate, but their home was badly damaged. The fire investigator traced the origin to Arthur's amateur outlet installation, documenting the undersized wire, the loose connection, and the missing ground. Arthur was fortunate not to face prosecution. The regulations around DIY electrical work were ambiguous, and the authorities were generally reluctant to punish homeowners who had simply tried to improve their properties. But he had learned, at considerable cost, that electrical work was not a suitable project for an enthusiastic amateur. Arthur's experience was repeated, in various forms, across thousands of British homes. Some amateur electrical installations caused immediate problems: shocks, sparks, small fires caught before they spread. Others functioned for years before failing, quiet ticking time bombs of slowly degrading connections and overheating wires. The fire services became intimately familiar with the distinctive characteristics of electrical fires, learning to trace burn patterns back to their origins in badly wired outlets, overloaded circuits, and improvised connections. The problem was compounded by the culture of the era, which celebrated self-reliance and viewed professional services as unnecessary expenses. A man who hired an electrician to do work he could theoretically do himself might be seen as lazy, incompetent, or wasteful. The DIY magazines reinforced this attitude with article after article on electrical projects, the implicit message being that anyone could do them. They rarely mentioned the dangers, and when they did, it was in language that suggested caution rather than prohibition. The regulatory framework for domestic electrical work was, like so much else in this story, inadequate to the circumstances. Commercial and industrial electrical installations were subject to inspection and approval, but private homes were largely left to their owners' discretion. The electricity boards could, in theory, refuse to connect supply to unsafe installations, but had no authority to inspect existing work. Local authorities could enforce building codes, but these typically applied only to new construction, not to modifications made by homeowners afterwards. The assumption, once again, was that people would behave responsibly. And once again, that assumption underestimated both the complexity of the work and the confidence of those attempting it. The consequences accumulated through the 1950s and into the 1960s. Fire departments reported increasing numbers of electrical fires. Hospitals treated growing numbers of shock victims. Coroners investigated deaths that could be traced to amateur electrical work, though the precise cause was often difficult to establish after a fire had destroyed the evidence. The pattern was clear to anyone who looked, but looking required systematic data collection that didn't yet exist. Change came gradually, driven by the familiar combination of accumulated tragedy and quiet advocacy. The institution of electrical engineers developed standards for domestic wiring that, while initially voluntary, became increasingly expected. The electricity boards began offering inspection services, encouraging homeowners to have their work checked. Insurance companies, ever attentive to patterns in their claims data, began asking about recent electrical work and adjusting policies accordingly. And the DIY media, responding to growing concern, began including more safety information in their coverage of electrical projects. By the 1970s, a regulatory framework was emerging that would eventually require most electrical work to be done, or at least certified, by qualified professionals. The DIY enthusiast who wanted to install a new outlet would need to either hire an electrician or register as a competent person, capable of certifying their own work. This represented a significant change from the freewheeling 1950s, when anyone could do almost anything to their own home without oversight. The DIY movement itself didn't disappear. It evolved, adapting to new regulations and new expectations. Modern hardware stores offer extensive safety information. DIY programs now emphasize knowing your limits and calling professionals for dangerous work. The culture of home improvement survives, but tempered by a greater awareness of what can go wrong. The ladder falls, the drill injuries, the electrical fires. These still happen, but at rates dramatically lower than the peak years of unregulated enthusiasm. Looking back at the DIY era of the 1950s, there is a temptation to wonder how people could have been so unaware of the risks. How could they not realize that climbing ladders was dangerous? How could they not understand that electricity could kill? How could they tackle projects so far beyond their competence? But that judgment ignores the context in which these decisions were made. People needed to improve their homes and couldn't afford professionals. They were encouraged by media that made complex tasks seem simple. They lived in a culture that valued self-reliance and viewed caution as a kind of weakness. They made the best decisions they could with the information they had. And the same could be said for every danger we have visited in this story. The parents who bought chemistry sets, the families who purchased polyurethane furniture, the mothers who dressed their daughters in synthetic nightgowns, the consumers who bought televisions without safety certifications. All of them were making reasonable choices based on available information. The information was wrong or incomplete or shaped by commercial interests that had no particular reason to volunteer the truth. But they had no way to know that. They trusted the systems that were supposed to protect them, and those systems failed. This is the essential tragedy of the 1950s home. It was filled with dangers that ordinary people could neither identify nor avoid. The optimism of the post-war era, the faith in technology and progress, the belief that things were getting better, all of these contributed to a vulnerability that would exact a considerable price. The people who paid that price were not foolish or reckless. They were simply people in particular circumstances, doing what most people would have done. The 1950s home was, in many ways, an experiment in living with new materials, new technologies, and new patterns of life. Like all experiments, it generated knowledge. But that knowledge came at a cost. The chemistry set burns, the furniture fires, the nightgown conflagrations, the television explosions, the ladder falls, the electrical disasters. Each of these represented a data point, a piece of evidence that something was wrong. The accumulation of those data points eventually forced changes that made homes safer. But each data point was also a human being, a family, a life altered or ended by dangers that should have been anticipated. And we are not quite done with this house yet. We have looked at the living room with its combustible furniture and its burning televisions. We have visited the bedroom with its synthetic nightgowns. We have examined the amateur improvements that quietly transformed homes into hazard zones. There remains one more category of danger to consider, one that might seem at first glance simply like the stuff houses are made of. Asbestos. Lead. The materials themselves, woven into the walls and the paint and the pipes of ordinary homes, patient and invisible and very, very old. There is a house. It is sometime in 1957. You can't see it yet, but you're almost there. Stand for a moment at the front gate. The garden is tidy. The curtains are drawn back to let in the winter light. Through the window, you can see the blue flicker of a television set and a child sitting very still in front of it in a pale nightgown. Everything looks, from here, like the future. Everything looks entirely safe. Then the narrator comes back. And the narrator knows things the family inside doesn't. The dangers we've been cataloging so far had a certain drama to them. Fire that moved fast, a fall downstairs, an explosion that announced itself. The things we come to now announced nothing. They were written into the walls, breathed in with the morning air, dissolved into the water from the pipes. Silent and slow, taking years or even decades to become visible, killing people who never knew what had been harming them. But before we arrive there, it seems worth pausing to take in the full picture of what a typical British home in 1957 actually contained, all at once, without looking away. In the living room, furniture capable of burning with extraordinary speed and releasing cyanide gas as it went. A television set with the potential to catch fire from its own internal components. Electrical outlets and wiring installed by enthusiastic amateurs with no formal training and no governing standard to meet. In the bedroom, nightgowns for the children made from fabric that would carry a flame the length of a small body in seconds. In any room where a weekend project had recently been completed, the residue of amateur improvements that might hold, or might not, depending on factors no one had thought to check. None of this would have been visible. That's the part that stays with me quietly when I think about it. If you had walked through the front door of that house in 1957, you would have seen comfort. You would have seen modern life doing what it was supposed to do. The furniture would have looked substantial and soft. The television would have been a point of pride, mentioned to neighbors, admired by visitors. The electrical outlets would have looked exactly like electrical outlets. The children in their nightgowns would have looked like children at bedtime. The gap between what the home appeared to be and what the home actually was, that gap is perhaps the most unsettling thing about this era. The people who lived there weren't negligent. They weren't reckless. They thought they were living in the future, in homes filled with conveniences that made life easier and better and safer than anything their parents had known. They were right about the conveniences. The future they believed they were inhabiting was real enough, but it was also a transitional space, a kind of laboratory, and the people inside it were, without anyone's permission or even awareness, the subjects of the experiment. We are, of course, the beneficiaries of what those experiments eventually taught. Every fire-resistant fabric, every properly ventilated electrical component, every certified installation carried out to a published standard. These things exist because they were learned from suffering, from the fires and falls and slow poisonings of people who came before us and had no way of knowing they were teaching lessons that hadn't yet been written down. Whether we fully absorbed those lessons is a separate question. New technologies continue to arrive in our homes. Smart devices, lithium batteries, novel materials whose long-term effects are not yet understood. The regulatory systems we've built to manage these things are more robust than what existed in the 1950s, but they are not perfect. They lag behind innovation, as they always have. They remain vulnerable to commercial pressure and to the particular kind of political indifference that treats invisible risks as no risks at all. The fundamental dynamic hasn't changed, really. Progress generates risk, and societies must decide how to manage that risk without strangling the progress that produced it. The 1950s offer no clean answers to that dilemma. What they offer are examples and warnings. The examples show what can happen when risk is ignored, when safety is left entirely to markets and to individual judgment, when optimism stands in for caution, and no one asks the questions that most need asking. The warnings are for us. They remind us that our own most confident assumptions may prove, in time, to be as dangerously wrong as those of our grandparents. Somewhere in your home right now, there is probably something that will seem unconscionably dangerous to your grandchildren. The question is whether we will learn what it is before it hurts us, or only after. But that question belongs to another time. For now, we have more of this particular house to move through, more to catalog, more to understand. And so we come to the materials themselves, the things the house was made of. Asbestos is perhaps the most notorious of the hidden killers of this era, though its notoriety arrived long after the damage had already been done. In the 1950s, asbestos was not a villain. It was closer to a miracle. Fire-resistant, extraordinarily strong, easy to work with, and remarkably inexpensive. It seemed like the answer to almost every challenge a builder might face. It was used in roofing materials, in floor tiles, in pipe insulation, in cement products, in brake linings, in dozens of other applications. If you needed something that wouldn't burn, wouldn't rot, and wouldn't strain the budget, asbestos was the answer the industry kept returning to. The properties that made asbestos so useful were genuinely extraordinary. Its fibers could withstand temperatures that would destroy nearly any other material. They could be woven into fabric, mixed into cement, sprayed onto surfaces, compressed into boards. The resulting products were durable and effective. From a purely functional perspective, asbestos was an engineering triumph, a natural material that solved real problems in real applications and solved them well. The post-war housing boom created precisely the conditions in which a material like this would thrive. Millions of homes needed to be built quickly and built cheaply. Traditional methods couldn't keep pace with the demand. Traditional materials were often in short supply. Asbestos-containing products offered solutions at every turn. Roof tiles that held fast in storms. Floor coverings that would last for decades. Insulation that kept homes warm without the fire risk that haunted the era. Builders embraced these materials without hesitation, installing them across estates and terraces and new-build semis, with no awareness that they were placing inside those walls a slow catastrophe timed to arrive a generation later. The range of asbestos products in a typical 1950s home was quietly staggering. Ardex, that textured coating applied to ceilings across Britain until it became almost universal, frequently contained asbestos fibers added for durability. Floor tiles, particularly the 9-inch vinyl tiles popular in kitchens and bathrooms, often had asbestos backing. Pipe lagging, used to insulate hot water pipes and heating systems, was frequently pure asbestos fiber, wrapped and sealed around the pipework running through the walls. Roofing felt, garage roofs, shed walls, brake pads, ironing board covers. The list continued and continued. A typical 1950s home might contain asbestos in a dozen locations, and no one living there would have had any reason to count them. The manufacturers marketed these products with confidence, emphasizing their practical advantages and mentioning no concerns whatsoever. Asbestos cement boards were advertised as fireproof, weatherproof, and virtually indestructible. All of that was true. The materials performed exactly as promised. The same boards that would later require expensive specialist removal and careful hazardous disposal were sold at the time as products any sensible homeowner would be fortunate to have. Installation was equally casual. Workers cut asbestos boards with ordinary saws, generating clouds of fiber-laden dust that hung in the air of enclosed spaces. They mixed asbestos-containing compounds by hand, often without so much as a basic dust mask. At the end of the day, they brushed off their clothes, gathered their tools, and went home to their families, carrying fibers on their skin and in their hair that would settle on furniture, be handled by children, and contaminate environments far removed from the original worksite. In the homes themselves, the exposures were quieter but no less real. A housewife mopping her kitchen floor had no way of knowing that the tiles beneath her feet contained asbestos, or that each scuff and chip was releasing microscopic fibers into the air around her ankles. A father teaching his son to use tools in the garage might choose the old asbestos board propped against the wall as a good surface for practice. A child playing in the attic might disturb old insulation with a curious hand, breathing in fibers that would settle in their lungs and wait there, patiently, for 50 years before making themselves known. The geography of this exposure followed the geography of development. The new estates built in the 1950s, constructed rapidly with modern materials, contained the highest concentrations of asbestos products. The older housing stock, Victorian terraces and Edwardian semis, was often safer, having been built before asbestos became widely available. The families who moved proudly into gleaming new homes, celebrating their good fortune, their modernity, their distance from the cramped, outdated housing they had left behind, were often moving into environments that were, in measurable ways, more hazardous than what they'd escaped. The danger of asbestos lies not in the material when it is whole and undisturbed. Intact asbestos-containing products, left alone, pose relatively little risk. The fibers are bound within the matrix, unable to become airborne. The danger arrives when the material is cut, drilled, sanded, or simply left to deteriorate with age. Then the fibers are released. When inhaled, they lodge in the lungs. The body cannot break them down, cannot expel them. They remain, irritating tissue, causing inflammation and in some cases, eventually, triggering cancers. The diseases that asbestos produces read like a catalog of slow suffocation. Asbestosis is a chronic lung condition in which scar tissue gradually replaces normal lung tissue, steadily reducing breathing capacity and causing progressive disability. Mesothelioma is a cancer of the lining of the lungs or abdomen, caused almost exclusively by asbestos exposure and almost universally fatal. Lung cancer, while caused by many factors, occurs significantly more often among those exposed to asbestos, particularly in those who also smoked. What these diseases share, beyond their severity, is their patience. Someone exposed to asbestos in the 1950s might show no symptoms until the 1980s, the 1990s, or later still. This latency period is what made asbestos so insidious and so difficult to respond to. The workers who installed it had no idea they were being exposed to a carcinogen. The families who lived in those homes had no way to know that the ceiling above the dining table was releasing fibers that would, one day, be responsible for their death. The connection between the exposure and the disease was hidden by decades of apparently ordinary life, during which the damage continued, silently, without announcement. The medical profession had known about the dangers of asbestos since the early 20th century. Asbestosis had been recognized as an occupational disease in the 1930s. Insurance companies had begun excluding asbestos workers from certain coverage around the same time. But this knowledge remained within medical and industrial circles. The general public knew nothing of it. Construction companies had no obligation to tell them. The regulatory framework that might have required disclosure simply didn't exist. There was a plasterer named Harold Jennings who worked on new housing estates in the Birmingham area throughout the 1950s. Harold was skilled and in demand, known for the quality of his surfaces. He worked with asbestos-containing materials almost every day, mixing Artex, cutting boards, fitting pipe insulation. He breathed in fibers constantly, without protective equipment, without any knowledge of what the fibers were doing inside him. His employers likely didn't know either. The manufacturers didn't tell anyone, because telling anyone might have affected sales. Harold retired in 1978, looking forward to years of gardening and grandchildren. In 1986, he began to experience shortness of breath that his doctor initially attributed to age. By 1988, he could barely climb a flight of stairs. When the diagnosis finally came, it was asbestosis. His lungs were so scarred by decades of accumulated fiber exposure that they could no longer function as lungs were meant to function. Harold died in 1991, connected to an oxygen tank, in a condition he had done nothing whatsoever to deserve, unable to understand why a life of careful, honest work had sentenced him to slowly suffocate. Harold's story was repeated thousands of times across Britain. Plumbers, electricians, builders, decorators, anyone who worked with these materials in the 1950s was at risk, and many of them would pay for that exposure with the specific and terrible currency of their remaining years. Precise numbers are difficult to establish because asbestos diseases were frequently misdiagnosed or attributed to other causes. The trails went cold in ways that were convenient for some parties and devastating for others. The families who lived in asbestos-containing homes faced lower but still meaningful risks. They weren't cutting and drilling the materials daily, but they were living alongside them, year after year, as those materials aged. Every picture hung in an Artex ceiling released fibers. Every scuffed or chipped floor tile released fibers. Every repair that required disturbing pipe insulation released fibers. The exposure was intermittent and lower in concentration than what the workers received, but it was continuous, and it accumulated, and it mattered. The full extent of residential asbestos exposure will probably never be known. The long latency of the diseases means that cases are still being diagnosed today, more than 60 years after those homes were built. The people developing mesothelioma now include not only former workers but homeowners, DIY enthusiasts who drilled into asbestos boards without knowing what they were, and children who once played in rooms with deteriorating Artex ceilings. Each case is, in its way, a delayed reckoning. Asbestos was not the only toxic material embedded in the walls and floors and fittings of the 1950s home. Lead paint was still common, particularly on exterior surfaces where its durability was valued. Lead pipes carried the drinking water in many older properties. Various adhesives contained solvents and compounds that would later be recognized as hazardous. The cumulative exposure to these substances, day after day, year after year, created health risks that are still being studied. Lead is particularly concerning because of what it does to children. Lead poisoning can cause developmental delays, learning disabilities, and behavioral problems. In severe cases, brain damage and death. Children in homes with deteriorating lead paint were constantly exposed. in the ordinary way that children expose themselves to things, by touching surfaces and then touching their mouths, by playing on floors where paint dust had settled, by chewing the painted edge of a windowsill with the absent-minded persistence that is particular to very small children. The effects might not have been obvious at the time, but they were accumulating nonetheless. The paint industry had known about lead toxicity for decades. The knowledge, in fact, dated back to antiquity. But lead paint was more durable than the alternatives. It was more washable. It held its color better. These practical advantages outweighed, in the industry's calculation, the risks to health. After all, people had been using lead paint for centuries, and most of them seemed fine. The fact that some weren't fine, that some children were being quietly damaged in ways that might not show up for years, did not seem to constitute a sufficient reason to change. The adhesives used in 1950s construction and DIY projects contained a considerable range of potentially harmful compounds. Formaldehyde, present in many glues and resins, is a known carcinogen that also causes respiratory irritation and skin sensitization. Benzene, found in many solvents, is a potent carcinogen affecting the blood-forming tissues. Toluene and xylene, common in paints and adhesives, can cause neurological damage with prolonged exposure. The DIY revolution we've already explored multiplied these exposures considerably. Every amateur project involving adhesives, paints, or solvents was an exposure event. The father who spent his weekends in an unventilated garage working with contact cement was breathing in volatile organic compounds for hours at a stretch. The mother who painted the nursery with lead-based paint was creating a toxic environment for her unborn child. The children who were allowed to help with projects, given a small brush and a sense of inclusion, were receiving exposures that might affect their health for decades. None of this was done with any harmful intent. Parents wanted to build beautiful, comfortable homes for the people they loved most. They used the best materials available. They followed the instructions as written. They had no reason to suspect that anything was wrong. The information that might have warned them existed. It was in medical journals, in industry studies, in regulatory files. It simply wasn't on product labels. It wasn't in the pages of DIY magazines. It was nowhere that an ordinary person, going about their ordinary life, would ever encounter it. The regulatory response to these slow dangers was, as with almost everything in this story, painfully slow. Asbestos wasn't banned from construction products in Britain until 1999. More than 4 decades after the homes we're discussing were built. Lead paint wasn't fully restricted until the 1990s. Many hazardous solvents remained in consumer products well into the 21st century. The gap between scientific knowledge of these dangers and regulatory action to prevent further harm spanned generations, during which the exposures continued and the damage continued to accumulate. This is perhaps the most frustrating element of the toxic material story. It was not that the dangers were unknown. The knowledge of asbestos risks dated back decades before the 1950s. The knowledge of lead poisoning dated back to antiquity itself. The problem was the translation of knowledge into action, overcoming the inertia of existing industries, overcoming the resistance of those who profited from the products. This translation took time, and the currency of that time was human lives. The homes built in the 1950s with all their hidden hazards are still standing today. Many of them still contain asbestos and lead and other materials whose full implications took so long to reach policy. The current generation of homeowners lives with these legacies still, identifying hazardous materials, deciding whether to remove or encapsulate them, trying to protect households from exposures that began before they were born. The 1950s home is not simply history. It is still there, still capable, under the right circumstances, of continuing its slow work. But the hidden dangers of the 1950s weren't confined to the walls and floors and fittings. Some of them came through the front door carried in ordinary shopping bags, to be prepared in ordinary kitchens and placed on ordinary dinner tables. The food supply itself, transformed by post-war industrial innovation, was developing new ways to cause harm. Let us talk about chicken. Before the Second World War, chicken was not the cheap and abundant protein we know today. Raising birds was labor-intensive. They grew slowly on traditional diets of grain and kitchen scraps. A chicken dinner was a Sunday occasion, a celebration meal, something reserved for special circumstances. Working-class families might eat chicken a handful of times a year. For many, it was practically a delicacy, something spoken of with a particular kind of anticipation. The war changed this, as the war changed most things. Military research had developed techniques for raising birds more efficiently, selective breeding for faster growth, controlled environments that maximized how effectively feed was converted into meat, vitamin supplements that kept crowded birds alive and growing when older methods would have failed them. Applied to civilian production after the war, these techniques promised to make chicken affordable for ordinary families at every income level. The transformation was remarkable in its speed. Between 1950 and 1965, chicken production in Britain increased by several 100%. Prices fell dramatically. Supermarkets, themselves a new and strange phenomenon, featured chicken prominently in their refrigerated cases, selling whole birds and parts in a way that would have seemed extraordinary to a pre-war shopper. The chicken dinner, once a quiet marker of modest prosperity, became accessible to everyone. This was, in many genuine ways, an achievement. Protein deficiency had been a real problem in pre-war Britain, particularly among the poor. Making chicken affordable contributed to improved nutrition across the population. The efficiency gains reduced the environmental footprint per unit of protein produced. The industry created jobs in rural areas that needed them. By most measures, the industrialization of chicken production was a success. But there was a problem, and that problem was salmonella. Salmonella bacteria had coexisted with chickens since long before humans began farming them. In traditional small-scale production, this coexistence was manageable. Flocks were small. Birds had space. An infected bird could be identified and removed without compromising the whole operation. The bacteria existed, but at levels and in patterns that traditional food handling could manage. Industrial production changed everything about that equation. Thousands of birds crowded into single buildings created near-perfect conditions for disease transmission. The stress of crowded conditions weakened immune systems, making birds more susceptible to infection. The speed of production meant sick birds might enter the food supply before any symptoms had become apparent. And the scale of distribution meant that contaminated products could reach consumers across the country before anyone realized something was wrong. The feed supply was another critical factor. Industrial-scale chicken production required industrial-scale feed, and the most economical sources of protein for that feed were themselves often contaminated. Fish meal was particularly problematic. It was made from processing waste. Heads, bones, viscera collected from multiple sources and processed in bulk. Processing conditions did not always eliminate salmonella, and contaminated fish meal could introduce bacteria to previously clean flocks. A single contaminated batch could reach dozens of poultry operations, spreading bacteria across a wide geographic area before the source was identified. Imported feeds created additional complications. Britain was never self-sufficient in protein crops and relied heavily on imports to feed its expanding poultry industry. These imports came from countries with varying standards of production and processing, introducing bacterial strains that British poultry populations had no prior resistance to. The globalization of the feed supply, driven entirely by cost, created pathways for disease transmission that had never existed before. The processing plants themselves were another point of contamination. Birds arriving at slaughterhouses might carry salmonella without showing any visible signs of illness. The bacteria could colonize a bird's intestines while leaving it apparently healthy. During processing, intestinal contents could contaminate carcasses, spreading bacteria from infected birds to clean ones. The speed of industrial processing, designed to maximize throughput and keep costs low, left little time for careful handling that might have interrupted this transmission. Water was another vector. Processing plants used large quantities of water for washing, cooling, and transporting carcasses. This water, recycled for efficiency, could become contaminated and carry bacteria to every bird it contacted. Chilling tanks, where carcasses were cooled before packaging, were particularly problematic. Hundreds of birds might pass through the same water, with each contaminated carcass potentially infecting those that followed. The very efficiency measures that made industrial processing economical also made it, inadvertently, an effective bacterial distribution system. By the late 1950s, salmonella contamination had become endemic in British poultry production. Studies conducted in the 1960s would find that a significant percentage of raw chicken sold at retail was contaminated. Some estimates suggested that the majority of birds carried the bacteria by the time they reached the consumer. The industry knew this. Their own testing revealed contamination rates that would be considered completely unacceptable today, but they had no effective solution. The bacteria were too widespread, too embedded in the production system, too thoroughly established to eliminate. The industry's response focused on the consumer end of the chain. Proper cooking would kill salmonella. Therefore, the solution was to ensure that consumers cooked their chicken properly. The contamination of raw chicken was, in effect, accepted as an inevitable feature of production. The responsibility for safety was transferred to the person standing at the kitchen counter with a bird in her hands. This approach had a certain logic to it. Cooking genuinely does kill bacteria, but it assumed a level of food safety knowledge that most 1950s housewives simply didn't have. And here we arrive at the crux of it. Kitchen hygiene in the 1950s was, by modern standards, genuinely alarming. This is not a criticism of the women who ran these kitchens. They were doing what they had been taught, following practices that had served previous generations adequately enough. But those practices had developed in a world of small-scale local food production, where bacterial loads were lower and the consequences of a lapse were limited. In the new world of industrial food production, with its vastly higher contamination levels and its distribution network spanning the country, those practices were no longer sufficient. Consider what preparing a chicken dinner in a 1950s British kitchen actually looked like. The housewife would purchase the bird from a butcher, or increasingly from a supermarket. She would bring it home and store it, often at room temperature, because refrigerators were not yet universal, and those that existed were often too small to comfortably hold a whole bird. She would then prepare it for cooking, handling the raw meat with her bare hands, using the same cutting board and the same knife she would use afterward for vegetables and bread. She would wash neither her hands nor her equipment particularly thoroughly between tasks. The concept of cross-contamination was not widely understood. The idea that bacteria from raw chicken could transfer to other foods via hands, surfaces, and utensils had not made its way into ordinary domestic practice. A woman who handled raw chicken, and then, a few minutes later, assembled a salad was doing something entirely normal by the standards of her time. The notion that she should wash her hands thoroughly between these tasks, or that the chicken juices on the counter surface might endanger whatever was prepared on that same surface, had not yet entered common knowledge. The science existed. It simply hadn't been translated into anything a home cook would encounter. The cooking itself was often inadequate by modern standards. Recipes of the era routinely specified cooking times and temperatures that would today leave a food safety inspector reaching for their paperwork. The goal was a bird that looked cooked and tasted good, not a bird that had reached the internal temperatures required to reliably kill all bacteria. Without meat thermometers, which were rare in home kitchens, there was no dependable way to verify the cooking had been sufficient. Birds were frequently served, with pockets of undercooked meat near the joints. Stuffing presented a particular hazard. Traditional British practice called for filling the cavity of the bird with a mixture of breadcrumbs, herbs, and often raw egg. This stuffing, surrounded by insulating meat on all sides, might not reach safe temperatures even when the exterior of the bird appeared completely cooked. The result was a warm, moist environment perfectly suited to bacterial survival, hidden inside what looked like a well-prepared roast. Families who considered the stuffing the best part of the bird were frequently consuming the most dangerous portion. Leftovers brought further hazards. There is a roast chicken on the table. It is Sunday. The kitchen smells of warm fat and herbs. The children are called in from the garden. Everyone sits down together, and the meal is good, and the day feels ordinary in the way that only good days do, where nothing about the moment announces itself as significant. And yet, let's stay with the leftovers for a moment, because that is where so much of the harm began. The cold chicken set aside from Sunday dinner would appear again and again through the week, in sandwiches, in salads, tucked into reheated dishes on Wednesday night when no one felt like cooking. Proper refrigeration of those leftovers was often lacking. Reheating was frequently inadequate to kill bacteria that had multiplied quietly during storage. What had been a good meal on Sunday could become, by Wednesday, something genuinely dangerous, and no one at the table would have any idea. The symptoms of salmonella food poisoning are unpleasant. Nausea, vomiting, diarrhea, abdominal cramps, fever. They typically begin somewhere between 12 and 72 hours after eating contaminated food, and in healthy adults they generally resolve within a week without treatment. Most cases were probably never reported or even recognized as food poisoning at all. People assumed they had a stomach bug, rested for a few days, and recovered. The connection to the chicken eaten several days earlier simply never occurred to them. But for vulnerable populations, salmonella was something considerably more serious. The elderly, with weakened immune systems, could develop severe infections that spread far beyond the gut. Infants and young children, whose immune systems were still developing, were particularly at risk. People with underlying health conditions could experience complications that a healthy adult would never encounter. And even healthy adults occasionally developed serious infections, particularly when the bacterial dose was high or the strain was especially virulent. The mortality statistics from this era are difficult to establish with precision. Salmonella deaths were often attributed to other causes: gastroenteritis, dehydration, secondary infections, and reporting requirements were less stringent than they are today. But food poisoning deaths increased significantly through the 1950s and into the 1960s, and a substantial portion of that increase was due to salmonella contamination of poultry products. The exact numbers remain debated, but we are talking about hundreds of deaths annually, with many times that number experiencing serious illness. Let me tell you about the Crawford family of Newcastle. In August of 1959, Margaret Crawford prepared a roast chicken for her family's Sunday dinner. She was an experienced cook. She had been preparing meals for her husband and 3 children for over a decade, and she had no reason to suspect anything was wrong with the bird she'd purchased from her local butcher. The chicken looked fine, smelled fine, tasted fine. Everyone enjoyed their dinner. By Monday evening, 7-year-old Peter was vomiting. By Tuesday morning, his 5-year-old sister Ellen had joined him. Their mother assumed it was a childhood bug and treated them with the standard remedies of the era: bed rest, clear fluids, hope for the best. By Wednesday, Peter was severely dehydrated and barely conscious. The doctor was called and immediately ordered hospitalization. Peter Crawford died on Friday, the 14th of August, 1959, of complications from salmonella infection. His small body had been unable to cope with the severity of the infection and the resulting dehydration. Ellen recovered, as did the rest of the family, who had eaten smaller portions and had more robust immune systems. The chicken that killed Peter had been contaminated with a particularly virulent strain of salmonella, probably introduced through imported fish meal used in the bird's feed. No one would ever be held responsible. I think about Peter Crawford sometimes, about the ordinary Sunday he had before any of it began, the dinner that tasted fine, the way a week can turn. Cases like the Crawfords were not daily occurrences, but they were not vanishingly rare either. Every summer brought its pattern of food poisoning deaths, many of them children, many of them traced eventually to poultry products. The pattern was clear to epidemiologists who studied it, but translating that pattern into preventive action proved frustratingly difficult. The barriers to change were numerous. The poultry industry resisted any suggestion that their products were inherently dangerous, fearing damage to the market they had worked so hard to build. Government agencies lacked the authority or resources to impose meaningful regulations on food production or handling. The public health establishment could issue guidance, but couldn't compel compliance. And ordinary consumers, lacking knowledge of the risks, continued practices that put their families in danger. Educational campaigns began in the late 1950s and intensified through the 1960s. Leaflets distributed through clinics and schools explained the importance of thorough cooking and proper food handling. Cooking demonstrations emphasized the need to wash hands after handling raw meat. Home economics classes incorporated food safety into their curricula. The message gradually penetrated public consciousness. Raw chicken was potentially dangerous and required careful handling. The impact of these campaigns was real, but gradual. Practices that had seemed normal began to seem careless. Refrigerators became more common and began to be used properly. Meat thermometers appeared in more kitchens. The basics of cross-contamination became more widely understood. Food poisoning rates, while still substantial, began to plateau and eventually decline. But meaningful improvement required changes at the production end as well as the consumption end. Better hygiene in processing plants, stricter controls on feed ingredients, more effective inspection regimes. All of these eventually contributed to reducing salmonella contamination at source. These changes came gradually, driven by a combination of regulatory pressure, industry self-interest, and public demand. The chickens sold in British supermarkets today, while not entirely free of contamination risk, are dramatically safer than the birds available in the 1950s. And yet the story of salmonella and the poultry industry keeps returning to the same underlying pattern: the gap between technological capability and safety understanding. The techniques that made industrial chicken production possible were genuine innovations, representing real advances in efficiency and affordability. But they were implemented without adequate consideration of their safety implications, without the regulatory framework needed to manage new risks, and without the public education needed to protect consumers. The result was a food supply that was more abundant and more affordable than ever before, and also more dangerous. This pattern appears again and again in the history of the 1950s home. Innovation outpacing safety, efficiency trumping caution, progress generating unexpected harms. The chemistry sets, the synthetic materials, the electrical appliances, the building products, the food supply. Each represented genuine advancement, genuine improvement in the conditions of daily life, and each carried hidden dangers that would only become apparent after the damage was done. The 1950s were not uniquely dangerous because the people of that era were uniquely foolish or careless. They were dangerous because rapid change creates blind spots, because new technologies introduce new risks faster than we can identify and manage them, because the systems designed to protect us inevitably lag behind the innovations that threaten us. This was true in the 1950s. It remains true today. The specific dangers have changed, but the underlying dynamic persists. The materials in our homes, the food in our refrigerators, the devices in our pockets. All of these may carry dangers we haven't yet recognized. The regulatory systems and safety standards we rely on, however sophisticated they may seem compared to the 1950s, are still imperfect, still playing catch-up with innovation, still leaving gaps through which harm can slip. The people who died from asbestos exposure, who lost children to salmonella poisoning, who watched their homes burn because of faulty televisions or amateur wiring. They were not victims of a uniquely dangerous era. They were victims of the eternal tension between progress and safety, between the desire for improvement and the difficulty of anticipating consequences. They paid prices that in retrospect seem unnecessarily high, but that seemed at the time like the acceptable costs of a better life. We honor them best not by congratulating ourselves on our superior wisdom, but by recognizing that we face similar challenges today. Somewhere in our homes, our workplaces, our food supply, there are dangers we haven't yet identified. Dangers that will seem obvious to our grandchildren, who will wonder how we could have been so blind. The question is not whether such dangers exist. It is whether we will learn from the past quickly enough to identify them before they cause widespread harm. But there is still more of the 1950s home to explore. The living room with its flammable furniture, the bedroom with its synthetic nightgowns, the kitchen with its contaminated food. All of these we have examined. There remains one more room, a room where the dangers were perhaps most intimate and most terrifying, the bathroom. Because it turns out that the simple act of taking a bath in a 1950s British home could kill you in ways you would never expect. Carbon monoxide, the silent killer, the gas that creeps into closed spaces, displaces the oxygen you need, and leaves you drowsy, then unconscious, then dead, all without any warning that anything is wrong. The 1950s bathroom, with its gas water heater and its closed windows and its culture of privacy, created perfect conditions for this invisible thing. And thousands of British families would learn too late what happens when comfort and convenience are prioritized over ventilation and safety. But that is a story for the next chapter. For now, let's acknowledge what we've learned about the slow killers. The asbestos in the ceiling, the lead in the paint, the salmonella in the chicken. These were not the dramatic dangers of fires and explosions. They worked quietly, patiently, accumulating damage over years and decades. Their victims often never knew what had harmed them, attributing their cancers to bad luck, their children's difficulties to natural variation, their food poisoning to mysterious bugs. The connection between cause and effect was hidden by time, by complexity, by the sheer difficulty of tracing individual health outcomes to specific exposures. This is perhaps the most unsettling category of 1950s danger. The harms that couldn't be seen, couldn't be felt, couldn't be avoided because no one knew they were there. A family could do everything right, follow all the rules, take all the precautions that reasonable people would take, and still be slowly poisoned by the materials in their walls, the food on their table, the air in their lungs. And yet, despite all of this, life went on. Families raised children, celebrated holidays, weathered crises, and built lives in these hazardous homes. The dangers we've traced were real, but they were not the whole story. Most people, most of the time, were fine. The chemistry sets didn't explode, the furniture didn't catch fire, the chicken didn't make anyone sick. The dangers were probabilistic, not certain. They increased risks without guaranteeing harm. Most families got lucky. Some didn't. The difference between luck and safety is hard to perceive when you're living through it. A family whose television never caught fire might conclude that television fires weren't really a problem. A family whose children never got food poisoning might dismiss the warnings about kitchen hygiene as excessive. We tend to judge risks by our personal experience, not by statistics. And personal experience is a profoundly unreliable guide. The 1950s home felt safe to most people who lived in it, even though it was, statistically, considerably more dangerous than we would tolerate today. This gap between perception and reality is one of the most important lessons of the era. The 1950s were not experienced as a time of exceptional danger. They were experienced as a time of progress, of improvement, of optimism about the future. The hazards were hidden in that optimism, embedded in the very technologies and materials that seemed to promise better lives. Recognizing danger requires not just information, but imagination, the ability to see beyond immediate experience to statistical patterns, to connect individual incidents into systemic problems, to question assumptions that everyone around you takes for granted. The people of the 1950s were not lacking in intelligence or care. What they lacked was information. Information about the risks they faced, about how to mitigate those risks, information that existed somewhere but had not yet reached them. The systems that were supposed to generate and distribute this information, regulatory agencies, consumer advocates, public health authorities, were either absent, underfunded, or captured by the industries they were supposed to regulate. The market, left to itself, had no incentive to generate or share safety information. Quite the opposite, in fact, since such information might discourage sales. This is why regulation matters, why consumer protection matters, why the infrastructure of safety that we now take for granted had to be built through decades of struggle and tragedy. The 1950s home was an experiment in what happens when these protections don't exist or are inadequate to the challenges they face. The results of that experiment, the deaths, the injuries, the chronic illnesses, the lives cut short or permanently diminished, are the data points that eventually drove change. Each victim was, in a terrible sense, a piece of evidence, proof that something was wrong and needed to be fixed. The fixes came eventually. Asbestos was banned, lead paint was restricted, food safety regulations were strengthened, television standards were implemented, DIY electrical work was regulated, fire-resistant fabrics became mandatory. The 1950s home, in all its dangerous particularity, was gradually transformed into something safer. But the transformation took decades, and it came too late for those who had already been harmed. We live in the aftermath of that transformation, in homes that bear the marks of lessons painfully learned. Every safety standard, every warning label, every regulation that seems excessive or annoying, represents someone's injury or death, someone's campaign for change, someone's refusal to accept that the status quo was acceptable. These protections are not bureaucratic inconveniences. They are memorials to people who didn't have them. And the transformation is not complete. New dangers emerge as new technologies and materials enter our lives. The regulatory systems that protect us, however improved from the 1950s, are still imperfect, still reactive rather than preventive, still playing catch-up with innovation. The fundamental tension between progress and safety persists, demanding constant vigilance, constant advocacy, constant willingness to question whether the conveniences we enjoy are worth the risks we take. The 1950s home is not just history. It is a warning, a reminder, a cautionary tale about what happens when we assume that progress automatically means safety. The people who lived in those homes were not so different from us. They wanted the same things we want: comfort, convenience, better lives for their families. They made reasonable choices based on available information, and they paid prices that seem, in retrospect, unconscionably high. We can learn from their experience, or we can repeat their mistakes. The choice is ours, and we make it every day in the products we buy, the standards we support, the questions we ask about the materials and technologies that fill our lives. The 1950s are calling to us across the decades, reminding us that the future is not automatically safe, that progress requires vigilance, that the price of comfort can be higher than we ever imagined. Now let's step back into that kitchen, because we've discussed how salmonella entered the British food supply through industrialized poultry production, but we haven't fully traced what happened once that contaminated chicken reached the home. The journey from shop to stomach involved dozens of opportunities for bacteria to spread, multiply, and find their way into foods that were never meant to contain them. The kitchen itself, that warm and busy heart of the family home, became an unwitting accomplice in the transmission of disease. You step into the kitchen. The floor is linoleum, cool under your feet. The smell is soap and old wood and something faintly metallic from the pipes. A chicken sits on the counter in its paper wrapping, just home from the shops, already slightly warm from the bus ride. You reach out and touch it without thinking, because why would you think about it? That is the thing. No one thought about it. To understand the kitchen hygiene crisis of the 1950s, we need to observe what actually happened there. The housewife, and it was almost always a housewife, since men in this era rarely ventured into the kitchen for anything more ambitious than making tea, was managing a complex operation with inadequate knowledge, inadequate equipment, and inadequate time. She was preparing 3 meals a day for a family that might include young children, a working husband, and possibly elderly relatives. She was doing this in a kitchen that might lack running hot water, that almost certainly lacked a dishwasher, and that might not have adequate refrigeration. She was following practices handed down from her mother and grandmother, practices that had worked reasonably well in an era of local food production, but that were dangerously inadequate for the industrialized food supply she now faced. The physical layout of a 1950s kitchen contributed to the problem. Space was typically limited, with work surfaces crowded together and storage inadequate for proper separation of foods. A kitchen might have only one cutting board, used for everything from raw meat to bread to vegetables. A single sink served for washing dishes, preparing food, and rinsing hands, often with the same water, since running hot water was expensive, and many homes still relied on water heated on the stove. The cooking range dominated one wall, with food preparation happening on whatever surfaces were available nearby. The equipment available to the 1950s housewife was primitive by later standards. Refrigerators, where they existed, were small, often under 5 cubic feet of capacity, compared to the 20 cubic feet common today. Many were poorly calibrated, running warmer than modern safety standards would allow. Many households still relied on meat safes or cold larders, which kept flies away, but did nothing to maintain the low temperatures needed to slow bacterial growth. Ice delivery, common in the pre-war era, had largely ceased, leaving families without reliable means of keeping food genuinely cold. The cleaning supplies available were similarly limited. Modern antibacterial cleaners, which can reduce bacterial counts by several orders of magnitude, didn't exist. Bleach was available but rarely used in food preparation areas, where its smell was considered unpleasant and its potential for contaminating food was feared. Soap was expensive enough that it was used sparingly. Most surface cleaning was done with a cloth or sponge and water, which might remove visible dirt, but did very little to eliminate bacteria. The concept of cross-contamination, the idea that bacteria from one food could transfer to another via hands, surfaces, or utensils, was not part of common knowledge in the 1950s. This seems almost strange from our present position, where food safety education begins in primary school and every cooking program includes reminders about proper handling. But scientific understanding of bacterial transmission, well established in medical and research circles, had not yet reached ordinary households. The housewife preparing the family's meals had no framework for understanding that the invisible organisms on raw chicken could transfer to her hands, to the cutting board, to the knife, and from there to foods that would be eaten without further cooking. Let's trace a typical sequence of events that played out in thousands of British kitchens every day. A housewife returns from the shops with a chicken purchased from the butcher or the new supermarket. The chicken has been sitting at temperatures favorable to bacterial growth, in the shop display, in her shopping basket, on the bus ride home. She brings it into the kitchen and sets it on the counter while she puts away her other purchases. Already, bacteria from the chicken's surface have transferred to the counter, where they will remain until someone wipes the surface. And even then, the wiping might simply spread them around rather than remove them. She begins preparing the chicken for cooking. She removes it from its wrapping, handles it to inspect its quality, perhaps rinses it under the tap. a practice considered hygienic at the time, but one we now know spreads bacteria through splashing. Her hands are now contaminated. She reaches for a knife from the drawer, contaminating the drawer handle. She places the chicken on the cutting board and begins to joint it or prepare it for roasting. The cutting board is now contaminated. The knife is contaminated. The counter is contaminated. Throughout this process, she is interrupted. A child needs attention. The telephone rings. Something on the stove requires stirring. Each interruption involves touching something: a door handle, a telephone receiver, a pot handle, a child's face, with hands that have been handling raw chicken. The bacteria spread outward from the chicken like ripples from a stone dropped in water, reaching surfaces and objects that will be touched by every member of the family. When the chicken preparation is complete, the housewife might give her hands a quick rinse under the tap. Cold water, probably, since hot water was precious. She might not use soap. Hand washing with soap was not the automatic habit it is today, and soap itself was an expense that thrifty housewives used sparingly. She might dry her hands on a towel that will be used again and again throughout the day, transferring bacteria from hands to towel and back again with each use. Then she moves on to preparing other foods, perhaps a salad to accompany the chicken dinner. She takes vegetables from the pantry, rinses them under the same tap where she rinsed the chicken, places them on the same cutting board, now theoretically clean after a quick wipe with a cloth, and cuts them with the same knife. The knife might have been rinsed, but rinsing alone does not eliminate bacteria. It takes hot water and soap at minimum to achieve any meaningful reduction. The vegetables, which will be eaten raw, are now contaminated with bacteria from the chicken, which will be cooked. The cooking of the chicken itself might kill the bacteria on its surface and throughout its flesh, assuming the cooking is thorough enough, which, as we've discussed, was not always the case. But the salad will not be cooked. The bacteria transferred to the vegetables will be served directly to the family, alive and ready to multiply in the warm, moist environment of the human digestive system. This sequence of events was not the result of carelessness or poor housekeeping. It was the natural consequence of following the standard practices of the era, practices that had been perfectly adequate when the chicken came from a local farmer and the bacterial load was lower. The housewife wasn't doing anything wrong by the standards she'd been taught. She was doing exactly what her mother had done, what the cookery books recommended, what everyone else was doing. The problem was that the food supply had changed, and the practices hadn't changed to match. The timing of food preparation added another layer of risk. In an era before widespread refrigeration, food was often prepared well in advance of serving. The chicken might be cooked in the morning for an evening meal, then left at room temperature for hours while the family went about their day. Bacteria that had survived the cooking, perhaps in undercooked portions, perhaps in the stuffing, would multiply enthusiastically in this warm environment. By the time the meal was served, bacterial counts might have increased 1,000-fold from what they were immediately after cooking. Leftovers presented similar challenges. The Sunday roast would provide meals for several days, with cold chicken appearing in sandwiches, salads, and reheated dishes. A meat safe in the pantry might keep flies away, but it did nothing to slow bacterial growth. Refrigerators, where they existed, were often too small to accommodate large items, or were set to temperatures that slowed but didn't stop bacterial multiplication. The leftovers that seemed perfectly fine on Monday might be dangerous by Wednesday, with no visible or olfactory signs to warn the cook who was simply trying to feed her family. The particular danger to vulnerable populations became apparent in the pattern of serious illness and death. Healthy adults who contracted salmonella from contaminated food typically experienced several days of unpleasant symptoms and then recovered. Their immune systems, developed through years of exposure to various pathogens, were usually able to contain the infection. But infants, elderly people, and those with compromised immune systems faced far greater risks. The vulnerability gradient was stark. A healthy 30-year-old who ate contaminated chicken might spend a few miserable days in bed, lose some work time, and recover completely with no lasting effects. That same meal, served to their infant child, their elderly parent, or a family member recovering from another illness, could trigger a cascade of complications ending in hospitalization or death. The bacteria didn't discriminate. But the body's response varied enormously, depending on the victim's age and health status. The statistics, such as they exist, paint a grim picture. Studies from the 1960s and 1970s, looking back at food poisoning mortality, found that children under 5 and adults over 65 accounted for the vast majority of deaths. These populations might represent a relatively small fraction of food poisoning cases, but they represented a hugely disproportionate share of serious outcomes. The kitchen's invisible hazards fell heaviest on those least able to bear them. The seasonal distribution of food poisoning cases added another layer of complexity. Summer months saw more cases overall, as warmer temperatures accelerated bacterial growth in inadequately refrigerated foods. But the winter holiday season brought its own surge, as large meals were prepared in advance, stored improperly, and served to extended family gatherings that included vulnerable elderly relatives. The Christmas turkey, centerpiece of the family celebration, could become a vehicle for infection that spread through multiple generations at once. Infants were particularly vulnerable for several reasons. Their immune systems were still developing, lacking the sophisticated defenses that adults take for granted. Their small bodies dehydrated quickly during bouts of vomiting and diarrhea, and severe dehydration could become life-threatening within hours. And the feeding practices of the era often exposed them to contaminated food in concentrated forms. Consider the common practice of preparing baby food at home. A mother might cook chicken, then mash or puree it for her infant. The preparation would involve the same cutting boards, knives, and surfaces used for other food preparation. Surfaces that might be contaminated with bacteria from raw chicken handled earlier. The pureed chicken might be stored at room temperature for convenience, allowing any surviving bacteria to multiply. The infant fed this lovingly prepared food would receive a dose of bacteria that their immature immune system was ill-equipped to handle. Worse still was the practice of pre-chewing food for infants, which was more common in this era than we might like to imagine. A mother or grandmother might chew food to soften it before giving it to a baby, inadvertently transferring bacteria from her own mouth, and any bacteria she had recently ingested, directly to the infant. This intimate act of feeding, motivated by love and the desire to provide proper nutrition, could transmit infections that the baby's body couldn't fight. There is something very human in that detail, the harm flowing through the gesture of care itself. The elderly faced different but equally serious risks. Aging immune systems lost their effectiveness gradually, leaving older adults more susceptible to infections that younger people would shrug off. Chronic health conditions common in the elderly could be exacerbated by the stress of food poisoning, and the medications that many older people took for heart conditions, diabetes, arthritis, could interact badly with the physiological stress of severe diarrhea and dehydration. There is something quietly particular about the way an era ends its dangers. Not with explosions or declarations, but with a cup of tea, a warm bath, a clean kitchen. The ordinary rhythm of a day, and somewhere inside it, a thing that could kill you. We have been moving through this house together for some time now, and we are nearly at the end of the tour, but not quite. There is still the bathroom. There is still the kitchen's long aftermath, and there are still the appliances waiting on the counter, their cords coiled neatly, their promises gleaming. Let us stay a little longer. The food poisoning that spread through 1950s homes did not announce itself. It arrived quietly, through practices that seemed perfectly reasonable, in a world that had changed faster than the people living in it could follow. In households where multiple generations lived under one roof, as many did in 1950s Britain, where housing was scarce and family ties ran deep, the risks multiplied with the head count. The same dish served to a healthy adult who would recover might also be served to an elderly grandparent who would not. The baby in the high chair might receive a smaller portion of what the parents were eating. Smaller, yes, but still enough to carry the bacteria, still enough to cause serious illness in a body just beginning. The medical response to all of this was limited by both knowledge and resources. General practitioners might recognize severe cases as food poisoning, but the milder ones were often attributed to a stomach flu or a vague bug, without any real investigation of what had caused them. When hospital treatment was needed, it focused on managing symptoms, replacing fluids, controlling fever, providing supportive care. The underlying infection was treated as the weather is treated, as something to be endured rather than understood. Antibiotics, which might have helped in some cases, were often not prescribed at all. Not because they weren't available, but because the bacterial nature of the infection wasn't recognized. The treatment that might have mattered never arrived, because no one knew to reach for it. And there is something in that which stays with you. Not negligence, exactly. Not cruelty. Simply the gap between what was known in laboratories and what reached the kitchen, the surgery, the bedside. The record-keeping that might have revealed the true scale of the problem was inconsistent at best. Food poisoning was not a notifiable disease for much of this period, meaning that cases did not have to be reported to health authorities at all. When reporting did occur, it was often incomplete, with many cases attributed simply to unknown causes. The connection between specific foods and specific illnesses was difficult to establish, particularly when symptoms didn't appear until days after the contaminated meal had been eaten. The scattered, individual nature of food poisoning cases made them invisible as a public health phenomenon, even as they killed and sickened thousands, year after year. The families affected often blamed themselves. A mother whose child became seriously ill from food poisoning would wonder what she had done wrong, what mistake she had made in the kitchen that had caused her child to suffer. The answer, of course, was that she hadn't made any mistakes, by the standards of her time. She had simply followed practices that were inadequate for a food supply that had changed faster than knowledge could keep up. But that answer provided little comfort to mothers who watched their children suffer, who lost children to infections that seemed to come from nowhere. The educational response to this crisis began in the late 1950s and intensified through the 1960s. Public health officials, recognizing the gap between scientific knowledge and household practice, launched campaigns to teach basic food safety. The messages seem obvious to us now. Wash hands thoroughly with soap and water after handling raw meat. Use separate cutting boards for raw meat and other foods. Cook poultry to internal temperatures that ensure bacterial death. Refrigerate leftovers promptly and use them within a day or two. Posters appeared in clinics, doctors' surgeries, and schools, illustrating the chain of contamination from raw meat to prepared food. Radio broadcasts, since television was still not universal, included public service announcements about food safety. Home economics teachers incorporated food safety into their curricula, ensuring that the next generation of homemakers would know what their mothers had not. The women's voluntary service and organizations like it played important roles in spreading this information. These groups had organized effectively during the war and maintained networks of local volunteers who could reach into communities that official campaigns might miss. They organized demonstrations of safe food handling, sometimes setting up displays in market halls or community centers, showing the right and wrong ways to prepare a meal. Their peer-to-peer approach was often more effective than official pronouncements, because it came not from above, but from alongside. You are standing in a market hall on a gray afternoon, the smell of damp wool and institutional tea, Someone at a folding table is showing a small crowd how to wash a cutting board. It seems simple. It seems almost too simple. And yet. Then narrator resumes. The medical profession gradually became more attuned to food poisoning as a distinct category of illness. General practitioners learned to ask about recent meals when patients presented with gastrointestinal symptoms. Public health officers became more systematic in their investigations of reported cases. Better laboratory techniques made it possible to identify specific bacterial strains, linking cases that might previously have seemed unrelated. This improved surveillance revealed the true scale of the problem, which in turn justified more intensive prevention efforts. The more clearly the danger was seen, the more seriously it was taken. But translating these messages into actual behavior change was something else entirely. Housewives who had been cooking for decades were not eager to be told they had been doing it wrong. The suggestions seemed fussy, excessive, perhaps even insulting to women who took genuine pride in their kitchen skills. And the practices being recommended required changes to routines that had become automatic through years of repetition. Telling someone to wash their hands with soap after handling chicken is easy. Getting them to actually do it, every time, when they've spent 20 years not doing it, is considerably harder. The introduction of new kitchen equipment gradually made some safe practices easier to follow. Hot water heaters made it practical to wash hands and dishes in water hot enough to kill bacteria. Larger refrigerators made it possible to store perishable foods at safe temperatures. Dishwashers, though they remained rare in British homes until the 1970s and beyond, provided more effective cleaning than hand washing in cold water. The material infrastructure of the kitchen slowly evolved to support what safety required. But the most important changes were in knowledge and habit. Generations of children grew up learning about bacteria in school, understanding that invisible organisms could cause illness, internalizing practices that their grandparents had never heard of. The culture of food handling gradually shifted, with each generation slightly more aware of cross-contamination risks than the one before. The transformation took decades, and it is still incomplete today. But the direction of change has been clear. The kitchen hygiene crisis of the 1950s represents, in miniature, many of the same patterns. A change in one part of the system, the industrialization of food production, created risks that existing practices couldn't manage. Knowledge that might have prevented harm existed, but wasn't communicated to those who needed it. The burden fell disproportionately on the most vulnerable, infants, the elderly, the poor, those with the least power to protect themselves. And change came slowly, driven by accumulated tragedy rather than proactive prevention. The kitchens of today are vastly safer than those of the 1950s, thanks to better equipment, better knowledge, and better habits. Food poisoning still occurs, of course. No system is perfect, but the rates are dramatically lower and the most serious outcomes are much less common. We have learned, collectively and gradually, how to handle food safely. The price of that learning was paid by the families who suffered when we didn't yet know, by the children who died from preventable infections, by the elderly whose last days were shadowed by illness that should never have happened. And now, we leave the kitchen. We walk down the hallway. We push open a door we have not yet opened on this tour. The bathroom. What waited there was different from everything else we have described. Fires could be seen. Falls could be heard. Contaminated food could, with enough knowledge, be avoided. But the danger in the bathroom gave no warning at all. It was invisible. It was odorless. It crept into the body quietly and shut down its ability to use oxygen, while the person breathing it felt only a mild heaviness, a pleasant warmth, a drowsiness that seemed entirely natural in a hot bath. We are going to talk about carbon monoxide. Carbon monoxide is produced whenever carbon-based fuels, gas, coal, wood, oil, burn incompletely, when there isn't enough oxygen to convert all the carbon to carbon dioxide. In small amounts outdoors, it disperses harmlessly into open air. In enclosed spaces, it can reach concentrations that are rapidly fatal. And the terrible thing about carbon monoxide is that you cannot see it, cannot smell it, and often cannot feel its effects until it is already too late to save yourself. The mechanism of carbon monoxide poisoning is almost elegant in its lethality, if elegance is a word that can be used for such a thing. Hemoglobin, the protein in red blood cells that carries oxygen throughout the body, has a much stronger affinity for carbon monoxide than it does for oxygen, about 200 times stronger. When carbon monoxide enters the lungs, it binds to hemoglobin molecules and refuses to let go. It disables those molecules from carrying oxygen. As more hemoglobin becomes bound to carbon monoxide, less is available to transport oxygen, and the body's tissues begin to suffocate, even though the person is still breathing. The symptoms are initially subtle and easily mistaken for other things: headache, dizziness, nausea, confusion. These might be attributed to tiredness or illness or simply feeling off. Victims often don't realize anything is seriously wrong until they are too impaired to help themselves. The confusion caused by oxygen deprivation to the brain prevents clear thinking about escape. People have been found dead just feet from doors or windows, having lost the cognitive ability to save themselves. The connection between carbon monoxide and the 1950s British bathroom begins with a specific event, a specific week in December 1952. For 5 days that month, a combination of cold weather, windless conditions, and massive coal burning created a toxic fog that blanketed London. It killed an estimated 4,000 people directly, with many more dying in the weeks and months that followed. The Great Smog, as it came to be known, was primarily caused by coal smoke. The government's response was the Clean Air Act, passed in 1956 and strengthened in 1968, which created smokeless zones and encouraged the transition from coal to gas and electricity. The images from that December week were difficult to forget. Visibility reduced to a matter of feet. Traffic stopped entirely. People dying in their homes and in the streets. It created a political momentum for change that had never existed before. Coal, the fuel that had powered Britain's industrial revolution, was suddenly seen as an enemy to be replaced. The transition that followed was, in many ways, genuinely beneficial. Gas burned cleaner than coal, producing less particulate matter and less sulfur dioxide. Electric heating produced no combustion products at all. The pea-soup fogs that had been a fixture of London life for centuries gradually disappeared, remembered now only in period films and nostalgic memoirs. But the transition also introduced new hazards, particularly in one specific room. The bathroom itself was a relatively new concept for many British families. Victorian and Edwardian houses had often been built without dedicated bathrooms at all, with families making do with tin baths filled from kettles, heated water carried laboriously upstairs. The post-war housing program included bathrooms as standard, but hot water supply remained a challenge. Many homes had no central water heating. Others had systems that were expensive to run or inadequate to supply the whole family's needs. The logic of installing gas water heaters in bathrooms seemed, at the time, entirely sensible. Hot water for bathing was something many families desperately wanted after years of heating kettles and hauling water up narrow stairs. A gas-fired instant water heater mounted on the bathroom wall could provide endless hot water on demand. No waiting for a tank to heat up. No rationing hot water among family members. The heater would be right where it was needed, eliminating the heat loss that occurred when hot water traveled through pipes from a distant boiler. And the heat generated by the burner would warm the bathroom itself, which was a comfort on cold mornings. That was the intention anyway. Manufacturers marketed these heaters enthusiastically. Advertisements showed families enjoying steaming baths, children splashing happily, parents relaxing in hot water after long days. The heaters were presented as modern, convenient, affordable, everything a forward-looking family would want. Installation was straightforward enough that many were fitted by amateur plumbers or even handy homeowners, following instructions that focused on getting the gas supply right without necessarily addressing ventilation requirements. And there it was, the gap that would cost lives. Gas heaters need oxygen to burn properly. They produce carbon monoxide when they don't get enough. A bathroom is typically a small enclosed space, exactly the kind of environment where oxygen can be depleted and carbon monoxide can accumulate. The British climate encouraged keeping windows and doors closed, especially during the cold months when hot baths were most appealing. And the British tradition of privacy in the bathroom meant that family members bathing were often alone, behind locked doors, with no one to notice if something went wrong. The sequence of events in a carbon monoxide bathroom death typically followed a predictable pattern. The person would enter the bathroom, close and lock the door, and start running a bath. The gas heater would provide the hot water, consuming oxygen from the bathroom air and producing combustion products, including small amounts of carbon monoxide. As the bath filled, oxygen levels in the room would drop and carbon monoxide levels would rise. The person settling into the warm water might notice feeling a little lightheaded, perhaps attributing it to the heat of the bath or to simple relaxation after a long day. They might feel drowsy. That would seem natural in a warm bath. Their thinking would become fuzzy, their reactions slow. By the time they recognized that something was seriously wrong, if they recognized it at all, they might be too impaired to get out of the bath, open a window, or call for help. In the worst cases, they simply slipped beneath the water and drowned, their muscles too weakened by oxygen deprivation to hold them upright. The locked door that had provided privacy now prevented rescue. Family members who came to check might assume the bather simply wanted to be left alone. By the time concern grew to the point of forcing entry, it was often too late. The victim would be found in the bath, apparently peaceful, with no obvious cause of death. The carbon monoxide that had killed them would have dissipated by the time the door was opened, leaving no evidence of its presence. A death that came from nowhere, a room that held no clues. Dorothy Blackwell lived in Croydon. She was 43 years old, a mother of 2 teenagers, wife of a civil servant, by all accounts a healthy and active woman. She had a habit of taking a long hot bath on Sunday evenings, her one regular indulgence in a life of domestic responsibility. Her husband George had installed a gas water heater in the bathroom the previous autumn. He was proud of the improvement he had made to the family home. On the evening of February the 17th, 1957, Dorothy went upstairs for her bath at approximately 7 o'clock. George remained downstairs, reading the newspaper, listening to the radio. The children were in their rooms, doing homework or perhaps not. At 8 o'clock, George called up to Dorothy that her program was about to start on the television. There was no response. He called again at 8:15. Still no response. He went upstairs and knocked on the bathroom door. No answer. He knocked louder. Nothing. Growing concerned, he tried the handle and found the door locked. He called through the door, his voice rising with worry. When there was still no response, he forced the door open, a difficult task in a house with solid internal doors, but fear gave him strength. Dorothy was in the bath, her head above water but slumped to one side. George pulled her out and tried to revive her, shouting for the children to call for an ambulance. Despite his efforts, and those of the paramedics who arrived 20 minutes later, Dorothy was pronounced dead at the scene. The coroner's inquest determined the cause of death as carbon monoxide poisoning from the inadequately ventilated gas water heater. George Blackwell, who had installed the heater himself, would carry the guilt of his wife's death for the rest of his life. Dorothy's death was far from unique. Throughout the late 1950s and 1960s, coroners across Britain recorded deaths from carbon monoxide poisoning in bathrooms with gas water heaters. The pattern was recognizable every time. A small room, an unflued gas appliance, inadequate ventilation, a victim found dead or unconscious in the bath. Some victims were revived, but suffered permanent brain damage from oxygen deprivation. Others survived only because someone happened to check on them before the exposure became fatal. Many simply died, their deaths attributed to misadventure, their stories serving as cautionary tales that never quite reached the people who needed to hear them. In Manchester, a young mother named Janet Coates was found unconscious in her bath by her husband in March 1959. She survived, but spent 3 weeks in hospital and suffered permanent memory problems that affected her ability to care for her children. In Glasgow, an elderly widower named Robert Campbell was discovered dead in his bathroom by a concerned neighbor who hadn't seen him for 2 days. The gas heater had been running the entire time. By the time the body was found, the carbon monoxide had long since dissipated, leaving the room silent and ordinary-looking. In Cardiff, a newlywed couple, both in their 20s, died together when the husband decided to join his wife for a bath. The bathroom was too small and the heater too powerful, and by the time they realized something was wrong, neither could reach the door. The demographics of carbon monoxide bathroom deaths revealed patterns that were both tragic and preventable. Single people were at higher risk because no one would notice if they failed to emerge from the bathroom. The elderly were at higher risk because their bodies were less tolerant of oxygen deprivation and because they often took longer baths. Young children were at lower risk only because they were usually supervised during bathing. And when they weren't, the results could be catastrophic. Working-class families were at higher risk because their housing was more likely to have improvised heating arrangements and less likely to meet modern ventilation standards. The timing of deaths followed predictable patterns. Most occurred in the evening, when people took baths to relax after work or before bed. Winter months saw more deaths than summer, not just because windows were more likely to be closed, but because people took longer, hotter baths to warm up from the cold. Weekend deaths were common when families had more leisure time for bathing. Sunday evenings, like the evening Dorothy Blackwell died, were particularly dangerous. The traditional time for the weekly bath in many households. The technical problem was well understood by those who thought about it. Gas appliances need adequate air supply for combustion and adequate ventilation to remove combustion products. Unflued heaters, those that vented directly into the room rather than through a chimney or flue, required particularly good ventilation because all their combustion products entered the living space. Bathroom installations were particularly risky because the rooms were small, and because people tended to close doors and windows for warmth and privacy. The solution was either to install fluid heaters that vented outside, or to ensure permanent ventilation that couldn't be blocked. Air bricks in walls, vents in windows, gaps under doors. But implementing these solutions required awareness of the problem, and that awareness was slow to develop. Gas companies and appliance manufacturers were naturally reluctant to emphasize the dangers of their products. Installers, many of them amateur or semi-professional, weren't always trained in ventilation requirements. Homeowners who installed their own heaters might follow the gas connection instructions carefully while completely ignoring ventilation guidance. And the victims, of course, could not report back on what had gone wrong. The regulatory response developed gradually through the 1960s and 1970s. Gas safety regulations began to specify ventilation requirements for different types of appliances. Coroners' reports on carbon monoxide deaths accumulated, building a body of evidence that couldn't be ignored. Gas board inspectors began checking ventilation as well as gas connections. New buildings were required to include permanent ventilation in rooms with gas appliances. Existing installations were subject to safety checks when gas supplies were turned on, or when properties changed hands. The installation of unflued gas water heaters in bathrooms was eventually prohibited, though the transition took years, and thousands of existing installations remained in use throughout. Carbon monoxide detectors, which would have provided life-saving warning of dangerous accumulations, did not become widely available until the 1990s. They were not required by law until even later. The gap between recognizing the problem and solving it stretched across decades, during which families continued to lose members to a hazard that could have been prevented. The seasonal pattern added its own particular quality to the tragedy. Deaths peaked in winter when cold weather encouraged closed windows, and when the contrast between cold rooms and hot baths made long soaking especially appealing. The dark evenings of winter meant that many baths were taken in artificial light, in bathrooms that might not have been entered since morning, where dangerous conditions could develop unnoticed. The very season when people most wanted comfort was the season when that comfort was most likely to kill them. The social distribution of these deaths reflected broader inequalities. Expensive homes were more likely to have proper central heating and purpose-built bathrooms with adequate ventilation. Cheaper homes, rented properties, converted buildings were more likely to have improvised heating arrangements, including bathroom gas heaters installed without proper safety considerations. Working-class families who could least afford proper heating systems were most likely to resort to the dangerous expedient that killed them. The psychological impact on surviving family members was severe and lasting. Unlike deaths from obvious causes, accidents, illnesses, fires, carbon monoxide deaths often came without warning and without explanation. A healthy person went into the bathroom and simply didn't come out. The locked door meant to provide privacy had instead created a death chamber. The survivor's guilt was compounded by questions that could never be answered. Why didn't I check sooner? Why didn't I notice something was wrong? Why didn't I know about this danger before it was too late? George Blackwell suffered from depression for years after Dorothy's death. He blamed himself endlessly for installing the heater, for not knowing about ventilation requirements, for not checking on her sooner. His children lost not just their mother, but effectively their father as well, as George withdrew into grief and guilt. The family that had seemed so ordinary, so stable, was shattered by a danger none of them had known existed. The modern bathroom is dramatically safer than its 1950s counterpart. Gas water heaters in bathrooms are either prohibited or subject to strict ventilation requirements. Carbon monoxide detectors are now recommended and increasingly required. Building regulations specify minimum ventilation for rooms with fuel-burning appliances. The knowledge that might have saved Dorothy Blackwell, and thousands like her, is now taught in schools, included in home safety guides, and enforced through inspection regimes. We have learned, at a terrible cost, how to provide hot water without poisoning the people who use it. And the lesson extends beyond bathroom gas heaters. It reminds us that comfort and convenience can have hidden costs, that new technologies can introduce new risks, that the gap between innovation and safety is often measured in human lives. The 1950s home, with its gas heaters and inadequate ventilation, was not designed to kill people. It was designed to make life easier and more pleasant. The deaths that occurred were side effects, unintended consequences of choices made with the best of intentions. But they were deaths nonetheless, each one representing a failure of the systems that were supposed to protect us. The bathroom, that most private of rooms, became in some homes a chamber of silent death. The locked door that guarded privacy also blocked escape. The warm water that provided comfort also extended the time of exposure. Everything about the 1950s bathroom seemed designed to maximize comfort. But the cumulative effect of those design choices, in homes with inadequate ventilation, was to maximize risk as well. We have now moved through most of the rooms in this house. The living room with its flammable furniture and exploding televisions. The bedroom with its synthetic nightgowns and amateur electrical work. The kitchen with its contaminated food and inadequate hygiene. The bathroom with its silent carbon monoxide. Each room held dangers that ordinary families couldn't see, couldn't anticipate, couldn't avoid with the knowledge available to them. What remains is the question of how society eventually responded, how the consumer protection movement emerged to demand safer products, how regulatory frameworks evolved to fill the gaps that had allowed so much harm. The story of the 1950s is not only a catalog of dangers. It is also the origins story of the safety systems we now take for granted. Every smoke detector, every flame-resistant fabric, every ventilation requirement. Each of these represents a lesson learned from the tragedies described in these rooms. But before we arrive at that part of the story, there is one more category of hazard to consider. The electrical appliances that filled kitchens and living rooms across Britain, humming with potential energy, and all too often releasing that energy in ways their manufacturers never intended. The electric kettle, the iron, the electric blanket. These seemingly ordinary devices had their own deadly potential, their own contribution to make to the casualty count of the post-war home. The electrification of the British home was one of the great transformations of the 20th century. Before the war, electricity had been a luxury, available in cities certainly, but often limited to lighting and perhaps a few simple appliances. Many rural areas had no electricity at all. Farmers worked by oil lamp and heated their homes with coal, just as their grandparents had. The post-war push for modernization changed all of this. The nationalization of the electricity industry in 1947 created a unified grid that could reach every corner of the country. Government programs subsidized the extension of power lines to remote areas. By 1960, virtually every home in Britain had access to electricity, and the market for electrical appliances had exploded accordingly. The appliances themselves seemed like miracles of modern engineering. An electric kettle could boil water in minutes without the need to tend a flame. And we will stay with that thought, and with what happened when those miracles misbehaved, a little further along. For now, though, let the house settle around you. The rooms are quiet, the hallway is dark. Somewhere a clock is ticking, the way clocks ticked in 1950s houses, steadily, without urgency. You don't need to go anywhere just yet. The story will be here when you return to it. There is something almost tender about the idea of electricity entering the home. Not the grid, not the industrial machinery, not the great turbines of the power stations, but the quiet domestic arrival of it. A wire running to a kettle. A coil of nichrome thread sewn into a blanket. The promise that warmth and convenience were now as simple as turning a dial. For the women who had spent hours each day carrying heavy iron kettles to the stove, heating sad irons on the range, and testing their temperature on wetted fingers, these appliances were not luxuries. They were liberations. An electric iron meant the slow ceremony of heating flat irons on the range was simply gone. An electric blanket meant climbing into a cold bed in winter. That particular British misery was something that no longer had to happen. Sales grew quickly and eagerly through the 1950s, and the manufacturers understood the appetite well. The advertisements of the era showed smiling housewives effortlessly managing their homes, freed from drudgery by electrical assistance. The messaging emphasized modernity, progress, the future. These were familiar themes by the mid-century, themes that carried, as we have seen before, familiar risks. Because these appliances were being produced and sold without adequate safety standards, tested only minimally, used by consumers who had no way to evaluate whether what they had brought home might harm them. Let us begin with the electric kettle, perhaps the most universal of British electrical appliances. The kettle had been a feature of British life for centuries, essential to the national obsession with tea. Traditional kettles, heated on stoves or open fires, were slow but reasonably safe. The worst that usually happened was a burn from touching hot metal or a splash of spilled water. Electric kettles promised to speed the whole process dramatically, boiling water in a fraction of the time required by traditional methods. The early electric kettles of the 1950s were, by modern standards, alarmingly primitive. They were essentially a metal container with an electrical heating element submerged directly in the water, connected by a cord to a plug. The heating elements were often poorly insulated, with the real possibility that electrical current could flow through the water and into anyone who touched it. The thermostats meant to prevent overheating were unreliable, sometimes failing to cut off power when the water boiled, or worse, when the kettle boiled completely dry. The cords were often inadequate for the current they carried, prone to overheating and creating fire hazards. And the thin metal bodies of the kettles could become electrically live if the internal insulation failed. Water conducts electricity, and the human body, being mostly water, conducts it very well indeed. A properly designed kettle manages this combination safely, with multiple layers of insulation and protection between the current and the person holding it. But a poorly designed or poorly manufactured kettle could turn the simple act of making tea into something much more serious. And in the 1950s, many kettles were exactly that: poorly designed, poorly manufactured, produced by companies more interested in meeting demand than in ensuring safety. The severity of an electric shock depends on the voltage involved and on the path the current takes through the body. A shock through dry hands might be painful but survivable. A shock received while standing on a wet floor or while touching a grounded metal sink could be fatal. The heart is particularly vulnerable to electrical current, and shocks passing through the chest could trigger arrhythmias that stopped it altogether. You are standing at a kitchen counter on a Saturday afternoon. There is tea to be made. It is September 1956. The kitchen smells of floor polish and something that has been baking. Your hand reaches for the kettle, which you have used hundreds of times before. You do not know yet that something inside it has quietly changed. Mrs. Edith Thornton of Wolverhampton reached for her kettle on exactly such an afternoon. It was a task she had performed thousands of times. The kettle had been purchased from a local shop 18 months earlier, and it had worked without incident until, invisibly, it had not. The internal insulation had degraded, allowing current to flow to the metal body. When Edith touched it to pour the boiling water, the shock threw her across the kitchen. She survived. She spent 2 weeks in hospital recovering from burns to her hand and from irregular heartbeats that took months to fully resolve. Her husband Albert examined the kettle afterward and found obvious signs of poor manufacture. Wires twisted rather than soldered, insulation that crumbled at a touch, components that appeared to have been salvaged from other devices entirely. The brand name on the kettle was one Albert did not recognize, and investigation revealed the company behind it had been operating for less than a year. It would close before the end of the decade. There was no way to sue them, no regulatory body to complain to, no mechanism by which other kettles from the same source could be recalled. The Thorntons threw away the kettle and bought another, hoping this one would be safer. Electric irons presented similar hazards, with the added danger of high temperatures. An iron needed to get hot, that was its entire purpose, but it needed to get hot safely, without exposing users to electrical shocks or starting fires when left unattended. The irons of the 1950s often failed on both counts. Their heating elements could develop shorts that made the handle or body electrically live. Their thermostats could stick in the on position, allowing the iron to heat until it damaged whatever surface it rested on. Their cords, subjected to constant flexing at the point where they entered the iron, could fray and expose bare wire. The ironing process itself created additional risks. Ironing was typically done standing, often on hard floors that might be damp from recently mopped surfaces. The ironing board, a metal frame with a fabric cover, offered multiple grounding points if something went wrong. And the task required constant contact with the iron. Holding it, moving it, setting it down. Dozens of opportunities for a fault to become a shock. Fires from electric irons were depressingly common. A housewife interrupted mid-ironing might set her iron face down on the board, intending to return in a moment. If the thermostat failed to cut power, or if the iron was simply left too long, the board cover could begin to scorch, then smolder, then catch. The fire would spread to nearby clothing, to curtains, to furniture. Within minutes, something that had begun as an ordinary afternoon task had become a conflagration. Fire investigators of the era consistently identified electric irons as a major source of domestic fires, and an estimate from the early 1960s suggested that irons were involved in thousands of fires annually in Britain, causing dozens of deaths and hundreds of serious injuries. The advice to never leave an iron unattended became a standard safety message. But the underlying problem, irons with inadequate safety features, remained until design standards improved. But perhaps no electrical appliance of the 1950s illustrates the gap between promise and safety more completely than the electric blanket. British bedrooms in winter were notorious for their chill. Bedrooms were often unheated, and climbing into bed meant enduring minutes of shivering while body heat gradually warmed the sheets. Hot water bottles helped but cooled quickly and could leak. Stone bed warmers were effective but cumbersome. The electric blanket promised to solve the problem definitively, warming the bed continuously through the night with minimal effort. For elderly people who felt the cold most keenly and were most vulnerable to its effects, electric blankets seemed like a gift from the modern world. For invalids confined to bed, they provided comfort that had previously been impossible. For ordinary families, they transformed bedtime from an ordeal into a pleasure. Sales grew rapidly through the 1950s, and by the end of the decade, electric blankets were present in millions of British homes. The design of these early electric blankets was, in retrospect, extraordinary in its casualness about danger. Heating wires were sewn between layers of fabric, connected to mains electricity, and placed in direct contact with sleeping human bodies for hours at a time. The wires could break from repeated folding and flexing, creating hot spots where current arced across gaps. The insulation around the wires could degrade with age, particularly in blankets that were washed or stored improperly. The controls that regulated temperature could fail, allowing the blanket to heat far beyond safe levels. And the whole assembly was placed on a bed, typically the most flammable location in a house, surrounded by sheets and pillows and mattresses and curtains. The materials compounded the danger further. Fabric covers were often made from cotton or synthetic materials with no fire-resistant treatment. The heating wires were typically nichrome or similar alloys, chosen for their electrical properties rather than their safety characteristics. The insulation around the wires was often basic PVC or rubber, materials that could degrade significantly over time, especially when exposed to repeated heating and cooling cycles. The controls, simple thermostats or just on-off switches, lacked the sophisticated safety features that would later become standard. Storage practices created hazards that manufacturers had apparently not considered. At the end of winter, most families would fold their electric blankets and store them until the following autumn. This folding stressed the heating wires at the same points each time, gradually weakening them. Blankets stored in damp conditions could develop corrosion in their electrical connections. Those stored in very dry or hot conditions could have their insulation become brittle. By the time the blanket was brought out for the next winter, it might have developed faults invisible to the eye but ready to manifest in the dark. The washing of electric blankets presented yet another risk. Some manufacturers advised against washing entirely. Others provided instructions for careful hand washing. Many consumers, faced with blankets that had accumulated a season's worth of skin cells and sweat and dust, ignored these instructions and put their blankets in ordinary washing machines. The mechanical agitation could damage heating wires. Water could penetrate insulation and cause shorts. A blanket that worked perfectly before washing might be dangerous afterward, with no external sign of the damage done. The fires that resulted were particularly terrible because they caught their victims in bed, often asleep, in the worst possible position to respond. A person who woke to find their bedding alight had only seconds to escape before flames and smoke became overwhelming. Many did not wake at all, succumbing to smoke inhalation while still unconscious. The elderly, who were the heaviest users of electric blankets, and who were also most likely to sleep deeply and respond slowly, were disproportionately among the victims. Ernest and Florence Mitchell, an elderly couple from Norwich, died in their bed on a January night in 1958. Their electric blanket, purchased 2 years earlier, had developed a fault that caused its heating wires to overheat dramatically. The blanket caught fire sometime after midnight. By the time neighbors noticed smoke coming from the house and called the fire brigade, the bedroom was fully engulfed. The Mitchells were found in their bed, having apparently never woken. They were 73 and 71 years old. They had been married for 48 years. They had been looking forward to their golden anniversary the following spring. I find myself pausing on that detail. Not the fire, not the investigation, but the golden anniversary. 48 years. A spring morning they were planning for and never reached. The electric blanket that killed the Mitchells bore a respected brand name, not one of the fly-by-night manufacturers who produced the most dangerous products, but an established company with a reputation to protect. Investigation revealed that the fault had developed gradually, probably beginning with a stress fracture in one of the heating wires that had been folded too sharply when the blanket was stored during the summer. That fracture had created a hot spot, which slowly degraded the surrounding insulation over many months of use. On the night of the fire, something, perhaps a shift in the blanket's position, perhaps a particularly cold night that caused the thermostat to demand more heat, had finally pushed the degradation past the point of no return. The Mitchells' case was far from unique. Throughout the late 1950s and into the 1960s, fire investigators documented deaths from electric blanket fires with depressing regularity. The victims were predominantly elderly, predominantly killed in their sleep, predominantly using blankets that had been in service for multiple years without inspection or maintenance. The pattern was clear. The response was slow. The manufacturing landscape for electrical appliances in the 1950s was, to use the phrase investigators of the era sometimes used, almost Wild West in its lack of regulation. Anyone with access to components and basic assembly facilities could produce appliances and sell them to the public. No testing was required. No certification was needed. No inspections occurred. The consumer had no way to distinguish between a safely designed product from a reputable manufacturer and something assembled in a backyard workshop from salvaged parts. Some manufacturers were conscientious, investing in safety testing and quality control because they believed it was right, or because they understood that dead customers were bad for long-term business. But others cut every possible corner, using the cheapest components, the simplest designs, and the minimum amount of material that would allow the product to function, for a while at least. A cheap, dangerous kettle looked much like an expensive, safe one on the shop shelf. The retailers who sold these appliances were in no position to evaluate their safety. A shop owner might stock products from dozens of manufacturers, each with their own specifications and quality standards. There was no independent testing that retailers could rely on, no certification marks that guaranteed safety, no regulatory framework that established minimum requirements. A retailer could examine a product visually, perhaps plug it in to verify it worked, but had no way to detect the hidden faults that would manifest only after months of use. The relationship between retailers and manufacturers was often distant. Products might pass through multiple intermediaries, importers, wholesalers, distributors, before reaching the shop floor. The shop owner might never know the actual manufacturer, dealing only with a brand name that could represent an established company or something far less substantial. Returns and complaints were difficult to process through these long supply chains, and manufacturers could easily avoid accountability by hiding behind layers of intermediaries. The high street electrical shop of the 1950s was a confusing place for the person trying to buy something safely. Products were displayed with minimal information, perhaps a price tag and a brand name, nothing more. The shop assistant might know how to use the products, but knew little about how they were made or whether they were safe. Consumers made choices based on price, appearance, and brand recognition, none of which correlated reliably with safety or quality. Some retailers did develop reputations for reliability, implicitly performing a filtering function by choosing to stock products from manufacturers they trusted and refusing to carry the most suspicious offerings. But this filtering was informal, inconsistent, and invisible to consumers. There was no way to know which shops did this, and which simply stocked whatever they could buy cheaply. The instruction manuals that accompanied these appliances, when they included manuals at all, ranged from inadequate to incomprehensible. Many were poorly translated from foreign languages, having been produced abroad and imported with minimal modification. Others were written by engineers who assumed a level of technical knowledge that ordinary consumers did not possess. Still others simply omitted crucial safety information, whether through carelessness or calculation. Consider an actual instruction from an electric blanket manual of the period. Do not fold blanket while in use. Sound advice, certainly, but it failed to explain why. That folding could stress and break the heating wires, creating exactly the kind of fault that killed the Mitchells. Without understanding the reason behind the instruction, users might dismiss it as overly cautious. Might fold the blanket just a little, without realizing what was happening inside the fabric. There is something worth sitting with here. The gap between an instruction and an explanation. Between telling someone what not to do and trusting them to understand why. The appliances we have been discussing, kettles, irons, blankets, were primarily used by women, who did the vast majority of housework in this era. The victims of appliance-related injuries and deaths were disproportionately female, not because women were somehow more careless, but because they had far more exposure to these hazards. A man might use an electric kettle once a day to make his morning tea. His wife might use it a dozen times as she served the family and entertained visitors. This gendered exposure pattern had implications for how appliance safety was perceived and addressed. Safety concerns raised primarily by women were sometimes dismissed as excessive worry, as inability to handle modern technology, as evidence that women could not be trusted with electrical devices. The paternalistic assumption that women needed protection from technology competed with an equally paternalistic dismissal of women's concerns about that technology. The result was a kind of double bind. Women were expected to use these appliances, but they were not taken seriously when they reported problems with them. The situation began to change, slowly, through a combination of factors. But before we reach that part of the story, it is worth acknowledging the full scope of what had to be overcome. The 1950s consumer faced a marketplace filled with products of unknown quality, from manufacturers of unknown reputation, with no independent testing, no regulatory standards, and no effective recourse when things went wrong. Buying an electrical appliance was essentially a gamble. Most of the time, things would be fine. But some of the time, the product could shock you, burn your house down, or kill you in your sleep. And there was no way to know which category your purchase fell into until it was too late. Into this landscape came a remarkable development: the birth of the modern consumer protection movement. This movement would transform the relationship between producers and consumers, creating mechanisms for accountability that had never existed before. One of its most important early expressions was a small magazine launched in 1957, which would grow to become one of the most influential voices for consumer safety in British history. The magazine was called Which, and its founding represented a fundamental shift in how ordinary people could protect themselves. The idea was simple but genuinely revolutionary. What if there were an organization, independent of manufacturers and retailers, that would test products and publish the results? Consumers could then make informed choices, avoiding dangerous or poorly made products and rewarding manufacturers who invested in quality and safety. The market, properly informed, might actually work. The Consumers Association, which published Which, was founded by Michael Young, a social researcher who had been instrumental in developing the Labour Party's 1945 manifesto. Young understood that post-war prosperity was creating a new kind of consumer. People with money to spend but little experience evaluating the products that were suddenly available to them. These consumers needed guidance, and the existing sources of product information, advertisements, and retailers had obvious conflicts of interest. What was needed was an honest broker, someone who would simply tell consumers the truth about what they were buying. The first issue of Which appeared in October 1957, with a print run of 10,000 copies. It tested electric kettles, appropriately enough given the dangers we have been discussing, and found enormous variation in quality and safety. Some kettles heated water quickly and safely. Others were slow, inefficient, or potentially dangerous. For the first time, British consumers could see objective comparisons that manufacturers could not manipulate. The inaugural issue also tested scouring powders and cake mixes, establishing from the beginning that Which would cover the full range of consumer products, from the mundane to the genuinely hazardous. The format was straightforward: clear descriptions of testing methodology, honest reporting of results, specific recommendations about which products to buy and which to avoid. There were no advertisements. That absence was crucial. It guaranteed the magazine's independence from commercial pressure in a way that no advertisement-funded publication ever could. The response was overwhelming. Within months, Which had waiting lists for subscriptions. The offices were flooded with letters from consumers who had been waiting for exactly this kind of guidance. Some wrote to share their own experiences with dangerous or defective products, contributing to the knowledge base that would inform future testing. Others wrote simply to express gratitude that someone was finally looking out for ordinary people in a marketplace that had seemed designed to exploit them. By 1959, circulation had reached 150,000. By the mid-1960s, it was approaching 500,000. The Consumers Association became one of the largest membership organizations in Britain, its influence extending far beyond its subscriber base as newspapers and other media reported on its findings. A Which recommendation became valuable currency in the marketplace, something manufacturers actively sought and feared losing. The organization expanded beyond the magazine, establishing local consumer groups, providing advice services, and lobbying for legislative change. It developed expertise in legal issues affecting consumers, product liability, and regulatory policy. What had begun as a simple testing publication had become a comprehensive consumer advocacy organization, one of the most effective in the world. The methodology of which testing was rigorous. Products were purchased anonymously from ordinary shops, exactly as any consumer would buy them. They were tested according to standardized protocols that measured safety, performance, durability, and value for money. The results were published without fear or favor. A manufacturer whose product tested poorly could not buy better coverage and could not prevent the publication of unflattering results. This independence was the magazine's most valuable asset and the source of the trust that consumers placed in it. The impact on manufacturers was immediate and dramatic. A poor rating in which could devastate sales. A good rating could launch a product to market leadership. Manufacturers who had never thought about independent testing suddenly found themselves competing not just on price and advertising, but on objective quality metrics. The incentive structure of the market shifted, rewarding safety and reliability rather than just cheapness. Some manufacturers resisted this new accountability. Legal threats were made against Which for negative reviews. Advertising was pulled from publications that reported on Which's findings. Industry associations lobbied against what they called unfair testing regimes. But consumers voted with their wallets, and manufacturers who wanted their business had to adapt. The alternative, being publicly identified as producers of dangerous or shoddy goods, was simply too costly. The electric blanket industry provides a good example of how Which testing drove safety improvements. Early reviews of electric blankets in which highlighted the dangers we have already discussed: fires, overheating, poor durability. The magazine's testing protocols included stress tests that simulated years of folding and use, revealing weaknesses that would not be apparent in normal operation. Products that failed these tests were named. Products that passed were recommended. The manufacturers who wanted Which recommendations had to invest in better design and construction. They developed heating wires that could withstand repeated flexing. They improved thermostats and added thermal cutouts that would disconnect power if temperatures rose dangerously. They strengthened insulation and improved manufacturing quality control. The electric blankets of the 1970s were dramatically safer than those of the 1950s, and Which testing had driven much of that improvement. The magazine also played an educational role, teaching consumers what to look for in products and how to use them safely. Articles explain the importance of proper ventilation for gas appliances, the risks of overloaded electrical circuits, the dangers of certain DIY projects. This education complemented the product testing, helping consumers not just choose safer products, but use them more safely. But Which could not solve all the problems alone. Some dangers were serious enough to require government intervention. Regulations that would establish minimum safety standards and remove the most dangerous products from the market entirely. The consumer protection movement recognized this and began advocating for legislative change alongside its testing and education activities. The legislative response developed gradually through the 1960s. The Consumer Protection Act of 1961 was an early milestone, giving ministers the power to make regulations requiring goods to meet safety standards. The act was limited in scope, applying only to goods that posed obvious dangers, but it established the principle that the government had a role in protecting consumers from unsafe products. Subsequent legislation expanded that principle, creating frameworks for product safety standards, testing requirements, and enforcement mechanisms. The political context for these reforms was complicated. The conservative governments of the 1950s and early 1960s were generally skeptical of regulation, preferring market solutions to legislative intervention. Industry lobbied heavily against any requirements that would increase costs or reduce flexibility. The argument was familiar. Regulation would stifle innovation, raise prices, and ultimately harm the consumers it was meant to protect. These arguments found receptive ears in government ministries, where business interests had considerable influence. But the accumulating evidence of consumer harm was difficult to ignore. The deaths from electric blanket fires, the injuries from defective appliances, the growing documentation from which and other sources of products that were simply dangerous. Public opinion, shaped by media coverage of individual tragedies and by the consumer protection movement's advocacy, gradually shifted towards supporting stronger regulation. The Mullany Committee, established in 1959 to examine consumer protection, played an important role in building the case for legislative action. The committee, chaired by James Mullany, spent several years gathering evidence and hearing testimony from consumer advocates, industry representatives, and government officials. Its final report, published in 1962, made numerous recommendations for strengthening consumer protection, many of which would eventually be implemented. The Trades Descriptions Act of 1968 was another significant milestone, making it a criminal offense to make false claims about products. This law addressed the problem of misleading advertising, giving consumers legal recourse when manufacturers lied about their products' capabilities or safety. Enforcement was initially uneven, but the act established important precedents for holding businesses accountable for their marketing claims. The electrical appliance industry was among the first to be subject to comprehensive safety regulations. The Electrical Equipment Safety Regulations of 1975 required all electrical products sold in Britain to meet specific safety standards. Products had to be tested and certified before they could be sold. Manufacturers had to maintain quality control systems. Enforcement officers could inspect factories and remove dangerous products from the market. The Wild West days of unregulated electrical appliance production were finally over. The impact was dramatic. Fire deaths from electrical appliances declined sharply. Electrocution injuries became rare rather than common. The horror stories of the 1950s, the Thornton's shocking kettle, the Mitchell's deadly blanket, became historical curiosities rather than everyday occurrences. Products still failed occasionally, of course. No system is perfect. But the catastrophic failures that had characterized the earlier era became vanishingly rare. The consumer protection infrastructure that developed from these beginnings now seems so natural that we barely notice it. When you buy an electrical appliance today, you buy it inside a system of protections that did not exist in 1955. Testing standards, certification marks, regulatory enforcement, consumer advocacy organizations with the resources and independence to hold manufacturers accountable, the right to return dangerous goods and to seek redress when they cause harm. All of that had to be built by people who were angry that their neighbors were dying, by researchers who believed ordinary consumers deserved honest information, by legislators who eventually accepted that some problems the market simply could not solve on its own. It is quiet work, most of it, unglamorous, the committees and the testing protocols and the lobbying letters. But it is the kind of work that means the kettle you fill tonight is, in all reasonable probability, safe. And that is not nothing. The kettle on your counter carries a small embossed mark, a CE symbol, pressed into the plastic near the base. You may never have noticed it. It sits there quietly, doing nothing visible, meaning everything. That mark means the kettle has been tested. That someone, somewhere in a certified laboratory, applied heat and pressure and electrical load to something very like your kettle and wrote down what happened. It means the instructions tucked inside the box were reviewed. The warnings were considered. And if the kettle one day proves defective in a way that causes harm, there is legal recourse. There is a system. There is, in the language of our modern world, accountability. None of that is natural. None of it arrived on its own. It was built, piece by piece, over decades, on a foundation laid by organizations like the Consumers Association. And beneath that foundation, deeper still, lie the people whose injuries and deaths made the argument undeniable. The argument that something had to change. Part of what changed was education. The Electrical Association for Women, founded in 1924 but expanding considerably in the years after the war, offered courses and demonstrations throughout the 1950s, teaching women the proper use and maintenance of electrical equipment. The courses addressed something that most institutions of the time preferred not to acknowledge directly, which was that the people most likely to use domestic electrical appliances were women, and that women had largely been left without the knowledge they needed to use them safely. The association taught them, and it did more than teach. It advocated for better appliance design, for safety improvements built into the objects themselves rather than patched on afterward through instruction leaflets and warnings. The goal was not simply to educate women into surviving dangerous products. It was to make the products less dangerous. The local electricity boards contributed as well. Their motivation was not entirely altruistic. Electrocution victims, as someone once observed with grim practicality, do not pay electricity bills. But the effect was useful regardless of the cause. Housewives who might never have sought out safety information encountered it anyway, when the meter reader came to the door, or when they visited the electricity showroom to settle their accounts. The message arrived quietly, through ordinary channels, and over time it settled into public consciousness. Electricity was useful. It was also dangerous. It required respect. And slowly, through the accumulation of all these efforts, the picture changed. Looking back across the decades from here, the transformation follows a shape that is possible to trace. Independent testing, pioneered by organizations like which, gave consumers the information they needed to make safer choices. Regulatory standards, established through legislation, removed the most dangerous products from the market altogether. Education, provided by consumer groups and industry bodies alike, taught people how to use what they had bought. Enforcement, through inspection and the power of recall, ensured that standards were not merely written down but actually met. Each of these things was necessary. None of them alone was enough. The human cost of learning all of this was enormous. And that word, enormous, is not adequate, but it is the word available. The people who died from defective kettles and burning blankets and all the other dangerous products of that decade paid with their lives for knowledge that now protects everyone who comes after them. They were not volunteers. They were not subjects in any experiment they consented to. They were ordinary people who wanted warm beds and hot tea and clean kitchens, and they encountered instead a marketplace that had no way to tell them which things were safe and which things were not. They were casualties of a transition from traditional to modern living that happened faster than safety could keep pace with. We owe them a debt that cannot be fully repaid, but it can be partially honored by remembering what happened and by maintaining the protections that grew out of their suffering. The 1950s home we have been moving through across this long series of evenings, with its dangerous chemistry sets, its flammable furniture, its nightgowns that caught fire, its exploding televisions, its contaminated chicken, its carbon monoxide bathrooms, and its appliances that shocked the hands that tried to use them, was not some strange aberration. It was not an unusually careless era or an unusually unlucky one. It was simply a time when new technologies and new materials were being introduced into ordinary life faster than anyone could understand their risks. When the safeguards we now take entirely for granted had not yet been imagined, let alone built. When consumers had no way of knowing, standing in a shop, holding a product, whether the thing they were about to buy would serve them or hurt them. Every era faces something like this. Today, the anxieties attach to different things. The safety of artificial intelligence, the behavior of autonomous vehicles, novel materials and chemicals whose long-term effects are not yet understood, products manufactured in distant countries under quality controls that are difficult to verify. The specifics change. The fundamental dynamic does not. Innovation creates risks that existing systems were not designed to manage, and someone always pays the price, while the rest of us work out how to protect ourselves. The 1950s carry both a warning and a kind of hope, and both are worth holding at once. The warning is straightforward. Do not assume that a product is safe simply because it is available for purchase. Do not extend to manufacturers, whose primary motivation is profit, a trust they have not yet earned. Do not wait for government to act when government moves slowly and industry moves quickly. The hope is equally clear. Consumer organizing can make a difference. Regulations can be written and enforced. The market can be shaped, through enough pressure applied in enough places, to reward safety and punish the absence of it. The transformation that happened between the 1950s and today proves that progress is possible, even when the cost of reaching it is terrible. We began this long tour of the 1950s home with a simple observation: that the post-war era, for all its optimism and its genuine forward motion, was filled with dangers that ordinary people could not see and could not avoid. Room by room, product by product, we have moved through those dangers. We have met families whose lives were changed entirely by a moment's contact with a hazard they never knew existed. We have traced the way individual tragedies connected into patterns, and the patterns into systemic failures, and the failures eventually into response. The home you are in right now is dramatically safer than any home of the 1950s. The products around you have been tested. The materials in your walls meet standards that someone fought to establish. The food in your refrigerator was produced under sanitary conditions that someone had to legislate into existence. The electrical appliances in your kitchen will not shock you if you touch them with wet hands. These protections exist because of what happened in that decade, because enough people were harmed, because enough advocates refused to let it continue, because enough legislators were finally persuaded to act. But there is a quieter thought that sits beside all of that. Somewhere in your home right now, there is almost certainly something that the people who come after us will look back on with the same slow disbelief we now direct at the asbestos ceiling tiles and the flammable nightgowns. Something we are using every day, without concern, that will one day be understood as a hazard we should have seen sooner. The 1950s are not as far away as we sometimes feel. The dynamics that created their dangers are still present, still generating new risks that no one has quite named yet. The price of safety, it turns out, is attention. Organized, sustained, funded attention. And the lesson of the 1950s is that such attention does not arise on its own. It has to be built. It has to be maintained. It has to be fought for again and again against the same pressures that have always pushed in the other direction. So the next time you fill a kettle without a second thought, or eat a chicken dinner without anxiety, or pull an electric blanket around you on a cold evening, take a moment, just a breath, to think of the people who made those ordinary comforts safe. They did not mean to be pioneers. They were not trying to change anything. They were just people, living ordinary lives in homes that were trying to kill them in ways they could not have imagined. Their stories are worth remembering, not as curiosities, not as warnings in the abstract, but as real people whose real suffering purchased something real and lasting and genuinely good. The consumer protection movement that was born from that decade is still here. It is still testing products, still advocating, still fighting the long, slow, necessary battle between profit and protection. That fight is worth continuing. That legacy is worth honoring. And you, right now, in your bed, in your home, surrounded by objects that meet safety standards that exist because someone paid for them with their life. You are the reason that fight was worth having. The chemistry sets that burned children. the furniture that released cyanide gas, the nightgowns that became flames, the televisions that caught fire in living rooms, the amateur electrical work that killed the people attempting it, the asbestos that waited, patient and silent, for 20 years before announcing itself, the chicken that carried invisible bacteria, the carbon monoxide that moved through bathrooms without color or smell or warning, the appliances that shocked and burned the hands that reached for them in good faith. All of it seen, traced, followed all the way from the morning it happened to the afternoon a regulation was finally written. And somewhere in that long arc from harm to protection, from ignorance to knowledge, from tragedy to legislation, there is something worth carrying with you, not as weight, but as understanding. The past is not simply past. It is a guide and a caution, and on the best days, a kind of quiet reassurance that things can get better, even when getting better is slow and expensive and arrives too late for the people who needed it most. The 1950s are quiet now. Their dangers have mostly been retired, but they are still speaking, if you listen, across all those decades, reminding us that the future is not automatically safe, that comfort is not automatically earned, and that the price of both is a vigilance that never quite gets to rest. Sleep well tonight, in a bed that will not catch fire, in a room with working smoke detectors, in a home safer than any generation before ours has ever known. That safety is a gift. Someone paid for it. Good night. Sleep well tonight. Wherever you are, whatever you're carrying, the story will still be here in the morning. Sleep well.